Subramaniam's Stability 1, Chapter 2, because these things come and then people again. Pressure at any point is the force per unit area. Its standard international units are newtons per meter square. But in ship stability, we all know ships sail on the surface of the earth where acceleration due to gravity is practically fixed. So, for the sake of simplicity, what do? We basically talk about pressure in terms of a point, the depth of the point below the water surface, and multiplied by depth. We leave the g. Otherwise, in physics, if this is the level of the liquid, and here is the point you want to talk about pressure at point x, and this distance is h, then the pressure at x would be h rho g, where h is the depth or d is the depth, whatever you want to call it. Rho is the density of the liquid, and g is the acceleration due to gravity, with units being newtons per meter square. But in ship stability, we limit our scope of pressure only about the water column, which is on the immersed area. Okay, so we'll just limit our thing from air pressure, this pressure, that pressure. We just only talk about the pressure below the surface of the liquid. The pressure due to column of a liquid at any point is equal to the depth multiplied by density multiplied by acceleration due to gravity. Now, as the ship, it floats on the surface of the earth and g is practically constant, we do not remove g. We just leave it out for the sake of COPLL is 4 meters, so answer remains 4 meters, but you have to show this step, right? Correct, beta? Question wants COP from the bottom of the bulkhead, correct?
Yes, sir.
Yes, sir.
Okay. So COP from liquid level as well as from the bottom, both are 4 meters incidentally, but you have to give it from the bottom because that is how the question is asked. This is a MMD question, beta, maybe a 25 mark question. I don't know, 25 or 12, whatever it is. But that's a MMD question, so that should give you some confidence into what we are covering. Okay, what is the time now? Time is 11:22. Let's take 8 minutes break. I'll remain logged in. Don't log out. Shall we resume sharp at 11:30 with more questions, beta?
Okay, sir.
Sure, sir.
Yes.
And
Okay,
and those of you who have doubts can review these two questions and shoot their doubts after the break. I'll just mute myself. I'm very much going to be in the meeting only. I'm not going out of the meeting. I'm not deleting anything. It's all being retained. I'll just mute once and then put the screen again on. Area of the bulkhead will be integration of this, and for this we make columns like this in our Simpsons table, and that takes care of the area, right? And finally you put, correct. Are you all comfortable with this part of calculation of area? Yes or no?
Yes, yes.
Correct. Then we wanted to add lever to it, so we see the diagram. Geometric center identified. This is the lever. We add to moment of inertia, first moment of elemental strip about liquid level. You multiply the area by lever. Then moment of the full bulkhead about liquid level will be integration of this. How do you take it further? You can just multiply this by lever, and you see you get this. You'll get SOP moment, and you'll get the moment by this, and you can get the DLL also by this formula. Up to this also everybody is familiar, guys, or any questions? Up to this you're all familiar in phase one, correct, guys?
Yes, sir.
And now we come to the last part, inertia. We apply the theorem of parallel axis for this. Where is it going? Okay. I elemental strip about liquid level will be I elemental strip about ZZ. ZZ is the axis drawn through the geometric center plus area of the elemental strip into x square. Do this. Okay, I just missed out 12 here, beta. Guys, put 12 here. Okay, by dx cube by 12. H12 is missing from my working here. So please, that's an omission. It's not something to be left out. Now I have already explained why dx cube by 12 is negligible, leaving us with yx square dx. And from this expression, if I have to make it yx square dx, I add the liver once again, and then I get product of inertia about liquid level, and I get SOP inertia about liquid level. I
ये
put
ढूंढा
it
क्या
through the final formula,
क्या
and
को
I get the inertia.
पापा
Is
पापा गन
this
रहे हो
working for horizontal ordinates? Clear?
पापा गन रहे हो
This is only for horizontal ordinates, guys. Please don't
हाथ में ही तो उधर दिन लिख
that
के ना
part.
गया तो
Is that clear, guys?
कि
So
तुम
this
मेरे
will be
के
the
मेरे पर्स में
comprehensive
को
table that we will
हाँ
review it and tell me if there's any
पापा से पूछ लेके तो
or any
पापा दे रहोगे नहीं
doubts.
मेरे पर्स में को
As far as horizontal ordinate handling is concerned, you have not understood derivation. It's
पहले
okay.
मेरे पर्स में देख ले शायद
As long as you understand
है
whether it is horizontal
मेरे पर्स में देख ले मेरे
and
पर्स
if it's
में पाओगे
horizontal, if you can execute this, good enough. No issues.
So in this, what do we have to learn, you said? Only the last part.
This table, this execution part, how to execute get the inertia for horizontal ordinate, right? Not the derivation part. In the first case, this is the liquid level, kg 4.5 meters. You have to calculate the GMT. So let me just help you with the diagram first. The diagram, the dry dock is 44-meter wide. So we are making the cross-sectional view. Okay, we are not making the longitudinal view. We are making the cross-sectional view. This is 44 meters of breadth of the thing. It has this dB, which is 44 meter in width. Of course, it will be subdivided. That's another issue. And their depth is 4 meters. So height of the dB is 4 meters. And then on the sides, you have tanks. These tanks are 4 meters wide each. You have another tank on the sides here. This is also 4 meters. And this is the space where you'll have the dry dock, you'll have the center line blocks here, you'll have the side blocks here. The ship will come and later on sit like this. Correct, guys? Can you appreciate the diagram? You don't have to make the ship, but once I made the ship, now can you appreciate the diagram, right? Okay. So basically, it is now he said that the vertical sides on this are side tanks 4 meter wide. Length is not given, so you can take any length L. Length can be anything L. Okay. And if the dry dock is at a 8 meters, so it is so obviously it will be above the dB somewhere here. This is the water line. Find the GM of the vessel. Kg of the dry dock is given as 4.5 meters. GM is to be found. We already know GM is equal to Km minus Kg, right? This will be equal to Km is equal to Kb plus Bm minus Kg, and of course minus FSC also, if any. So you'll have to calculate these components. Give it a try. I've given you the teaser for homework. I got this answer. You can try and see if it matches. Would you like to try it, guys?
Yes, sir.
Okay, sir.
Yes, sir.
Okay, so
Yes,
try
sir.
this. Yeah, try this. You can take down this question and take the answer. With this, we come to end of. If you are taking down, I'll come back to it again. No problem. There are some regular geometric shapes which are frequently used in our ship stability questions. So this part is only specific to ship stability calculation. So we have picked up only those shapes. And these regular geometric shapes have standard formulae of moment of inertia about some standard axis. So axis also is standard, the shape is standard, and there are standard formulae. These formulae are all mathematically derived formulae, guys. Some of them I know in our times we used to do in class 8, 9 about a rectangle and all that. I don't know about the curriculum these days, whether you have it or not, but whatever it is, what you need to do is what formula we are going to now learn, understand, you need to take them down and learn them. Initially, what you can do them is You can refer to your notes, use them, and as you apply, they will automatically be, you'll be thorough with them. So if you refer to them for solving and understand, that's okay. But over a period of time, those formulae need to be learned by heart so that you can use them. Okay. Now, which are the regular geometric shapes that we are interested in ship stability? One is rectangle, guys. The other is triangle. Third is a circle. Fourth is a semicircle. And fifth is a quadrant. These are the 5 shapes which do figure in our questions, and we will be learning some formulae and then putting them to use during the numericals. And we'll start using we'll start applying them today itself. It's not that today we'll learn formula, tomorrow we'll apply it. No, we'll learn today, we'll learn to apply them today, and we'll do some questions at home so that tomorrow we can take this topic next to the next step. Now, first we talk of rectangle. We all know what a rectangle is. I don't have to tell that to you. Let's say we have this rectangle of length L and breadth B. Now, area of this rectangle, all of you know, is L into B. I don't have to ask you that. All of you know this, guys. Then where is the geometric center? You should be able to identify the geometric center of these shapes, guys. So that's also going to be important. We know the geometric center of this rectangle is at the intersection of the diagonals. That means here you have one diagonal coming up, you have the second diagonal that has come, and where these two diagonals intersect. This is the geometric center of the rectangle. We know along the length it is L by 2, and along the breadth it is B by 2. We know it's at mid length and mid breadth. All of us know it, guys. Okay. Now, which are the standard axes about which moment of inertia needs to be learned? You can have one axis this now, XX. Now, tomorrow somebody could be writing it A, Y, Y, you can name whatever. But what is this XX axis? Please pay attention to this. XX axis is an axis A passing through the geometric center of the rectangle. 2, it is parallel to length. So you have to now, because if you change the orientation of the axis or you change the point, then the formula that you will learn will not be applicable. Okay. So what is XX axis in our representation? It's an axis passing through the geometric center of the rectangle and parallel to length. In such a case, learn is IXX will be equal to LB cube by 12. LB cube by 12. You can take down these formulae, beta. Another axis could be, instead of being parallel to length, I could have another axis which is parallel to the breadth in this case. I may call it YY. The formula would be similar, but in this case, it will be cube of the length, BL cube by 12. So IXX in our diagram is LB cube by 12. IYY will be BL cube by 12. Now, how do you remember it? Which one to cube? Guys, firstly, the axis must be passing through the geometric center of the rectangle. If it is not passing through the geometric center, these formulae become null and void. Please remember that. Secondly, you will cube the axis must be parallel to one of the sides. Thirdly, what do you cube? You cube the side which is cut by the axis. In the first case, in the case of XX, it is cutting B, so it is B cube here. In case of YY, it is cutting L, so it is L cube. This way, you can help in this will help you in remembering it. So I'm sure you'll be able to recall these formulae. Any questions up to this point, guys?
No, sir, negative.
No, sir.
Okay.
No,
Good. Very good. So you've taken down the formula. I'm continuing, guys. Next we do is the triangle, guys. Now, before I go to the triangle and show you my presentation, I want to clear a very basic doubt in case of a triangle, guys. Any triangle you can take. And this is the mistake we people make because we don't focus on the fundamentals. Now, please remember, this triangle has 3 sides. Okay, it has three sides: side 1, side 2, and side 3. We all know that area of the triangle is half base into height. Okay, inside of side, let me call it base 1, base 3, and base 2. Okay. Now, which is the base and which is the height? Please remember, the height is corresponding to the base. Any of the three sides, depending on your requirement and suitability, any of the three sides can be used as a base. But then, if I use B1, then the height will be corresponding to base B1. Now, what do we mean by, okay, one second. Okay, one second. Let me keep this and, okay, let me change the color of the pen. Okay, guys. Now, if I'm taking base 1, okay, if I'm taking base 1, then this height has to be corresponding to base 1. What does it mean? That means through the opposite vertex, the vertex opposite to B1 is A. Through A, you draw a line parallel to the base. And the perpendicular distance between these two parallel lines is the height h1, which corresponds to base B1. So that means area will be equal to half B1 into h1. Now somebody else says, no, sir, I don't want to, I can't use this as a base for whatever reason. I want to use side 2 as the base. Now, if you are using side 2 as the base, guys, this is side 2. The opposite vertex is B. Through B, you'll draw a parallel line. And this is the perpendicular distance, which is height 2. And obviously, this area will be equal to half into B2 into H2. Obviously, if B2 has changed, H2 will be different from H1. If B1 and B2 are not same, then H1, H2 cannot be same because the area is the same. Likewise, for the third triangle also now, I'm sure that doesn't need to be repeated here, but just for the sake of clarity, for the third triangle also, I'm sure all of you would agree that for the third triangle, for the third base, sorry, for this base, which will be the vertex, guys? B, correct? Sorry, this is B, so this is C, okay. For this third side, C is the vertex. We draw a perpendicular parallel side through C, and this perpendicular distance is the height 3, and this will be equal to half base third into height 3. Guys, is this concept of base and height clear to everybody? Because many people I have seen making mistake in this. They'll say why this is base, why this is height. Any side could be acting as a base. Height, when we say, is the one which corresponds to that base. Is that clear, guys? Here is the triangle. Area of the triangle is, we know, half base into height. In this case, I'm taking B as the base, and obviously the height will be the corresponding to it, and area will be half base into height. I have already shown this caution. We have discussed this point here, guys. Height should be the one corresponding to the base chosen, right? And I'm sure all of you would agree that for the base chosen B, capital D represents the height or the depth of the triangle. So the area of the triangle is half base into depth, half BD. You change the side, the height will change, obviously. Then where is the geometric center of a triangle? The geometric center of a triangle is at the intersection of its medians, beta. What is median? Median is a line which joins a vertex to the midpoint of the opposite side. That means, please mute yourself, guys. Can you see this is one median that has drawn from vertex, this vertex here to the midpoint of the other one. If we draw the other medians also one by one, then all the medians will intersect at one point, and this point of intersection of the median will be the geometric center of this rectangle triangle. Now, the distance of this geometric center is always 1/3 of the height from base. That means, now since we are talking of this base and this height, then we are talking of basically this distance from the base, and this is the distance from the vertex. This distance is 1 by 3d and this distance is 2 by 3d. Again, 1 by third or 2 by third of the height. Height which one? Corresponding to the base in question. So the G is at a distance of 1/3 of the height from the base and 2/3 of the height from the vertex. So whichever point we need in our questions, we will be able to get this distance provided we know the height and we know the geometric center. And we can get 1/3 of the depth or height or at the or the 2/3 of the height, whatever is fitting in that particular situation. Okay, any questions up to this point, guys, on triangle? I'll clear the slide. Any questions with this one? In every shape, we will have definitely an axis passing through the geometric center. Other than that, we may have an additional axis, but there will always be an axis that will take, which is passing through the geometric center of that figure. Guys, what is so special about this axis? This axis XX is passing through the geometric center of the triangle and is parallel to the base. Which base? B. Okay, so the standard axis of a triangle is the one passing through its geometric center and parallel to the base. Okay, now this IXX for triangle is BD cube upon 36. Base into cube of the height divided by 36. Obviously, again, I'm reiterating, the height has to be the one corresponding to the base being used. Now, there's one more axis. If you learn about that, it will simplify, it will be helpful in the numericals. You can cut short. Another axis I want you to learn about is this one. YY. What is it? It is coinciding with the base. It's coinciding with the base. So in other words, it will give you moment of inertia of the triangle about the base. Base could be any one of them, and accordingly the height will change. Now IYY formula is BD cube by 12. Sometimes we will use about XX if that is making our calculation simple. Sometimes we'll use YY if that is making it simple. We can always use about XX and calculate about YY. That's not an issue by theorem of parallel axis, but there is no need. If you remember this one extra formula, it will help you saving time in the exams. So guys, are the two formulas moment of inertia of triangle clear? We know if this circle has a diameter d, radius r, we know the area of this circle is pi r square. Where is the geometric center of the circle? At the intersection of diagonals, diameters. At the intersection of diameters. So you draw more diameters. Wherever they'll intersect, that will be the geometric center. We all know where the geometric center is, right? Of a circle, not an issue. Now, you see, you take any of these diameters. You take this diameter, which is about XX. You take any other diameter, YY, or you take, for that matter, any other diameter. You can take a diameter like this, you can take a diameter like this. You take diameter in whichever way you want. You see, the area of the circle will be distributed in the same fashion about each diameter. Therefore, moment of inertia about any diameter, whether that is XX, YY, ZZ, or any of the other diameters, the formula will be pi d4 upon 64, where d is the diameter. Pi d4 upon 64. If you put d as 2r, it will simplify to pi r4 upon 4. So you can use whichever you want, pi d4 upon 64 or pi r4 upon 4. This will be not about xx or yy. This will be about any diameter of the circle. Am I right, guys? Clear?
Yes, sir.
Okay. Circle is done, guys. Any questions up to circle then?
Sir,
Yeah.
sort of,
Was for circle. For circle, it was pi d4 upon 64 or pi r4 upon 8. This was for the full circle, right? About the diameter. Okay.
Sir, pi r4 upon 4, no?
Oh, my mistake. Pi r4 upon 4. My mistake. Sorry. So now you see this circle we had just dealt with, right? Now I made it a semicircle. What happens to the area? Area becomes half. You all know it. So area will be pi r square by 2. For the full circle, it was pi r square. For half the circle, it will be pi r square by 2. Okay. Now, where will be the geometric center of it? I'm sure all of you would agree that geometric center would be on this line. Yes or no? The red line that I've drawn. Correct, guys? Why? Because on either side of this line, area A and B are identical. So geometric center has to be on this line. Yes or no, guys? Tell me.
Yes, sir. Yes, sir. On this line.
Yes.
Correct? Okay.
Yes, sir.
Right. Very good. So this is what I've written. The geometric center shall be on the radius which is perpendicular to the diameter of the semicircle. And now the distance. Now let me clear it off. Let me clear my work from here. Okay. Now here you see what have I done? You have this line coming up, and the distance of the geometric center from the diameter from here, it will be somewhere here. That distance is this formula you need to learn, guys. The distance is 4r by 3 pi. That means this is the geometric center of this semicircle, and this distance is 4r by 3 pi. This is another formula you need to learn, guys. You can mark them in the diagram. You don't have to write. You can mark them in the diagram and you can just use them. Okay. Now, one axis we have taken. Yeah, tell me.
So just a minute, one minute.
Okay.
Sir, excuse me, sir. Sorry to interrupt you.
Yeah.
Sir, one of my friends just messaged me and he wanted to join the stability class now. Can I tell him to message you and he can?
You tell him to, you send him the link and tell him to join and he can pay later on. But I don't want to be distracted now while I'm in the class.
Sure, sir. Sure. Okay, sir. Thank you.
And he can send me a message later on. Then I can send him the details. Okay. But tell him to join the class first.
Okay, sir. Okay, sure. Thank you.
Okay.
So can you explain this part 4r by?
This is a formula which has been calculated through radial integration because here you have a curved surface.
Yeah. Okay.
This is through radial integration that you get the moment and divide by the area, and this distance from, so you get the moment of the whole area about this diameter, and then divide by the area, it will give you the distance of the GC from diameter, and that comes to 4r by 3 pi beta. Okay. So this formula you'll have to learn, guys. Don't miss out on this. Okay, now we have to learn moment of inertia about some axis. Guys, we already have learned the moment of inertia about the diameter of a circle when the circle was like this, right? What was the formula about the diameter? About yy, what was the formula?
Pi r4 by.
Yeah, pi r4 by 4 or pi d4 by 64, right? Now what has happened? Axis is same. I have removed pi d4, pi d4, 4. Pi d raised to power 4 beta upon 64.
Okay, copied, sir. Thank you.
Yeah. So now what has happened from the full circle, this was the formula about this axis. Now what have we done? We have retained only this part and we have done away with this one. This one is removed now, right? So you have only half. So moment of inertia will also become half. That means about yy, the moment of inertia of this semicircle will be pi d4 upon 128. It will, half of it will be 128 or pi r4 upon 8. Do you understand what have I tried telling you here? About the diameter, it will be exactly half of what it was for the full circle, right, guys? So easier to remember.
Yes, sir.
Yes, sir. It is half of full circle.
Yeah, half a full circle. Why? Because axis has not changed. But as I told you, we also need, in each case, we will also learn the formula about our axis passing through the geometric center. So in this case, the standard axis would be this one. What is this axis? Xx. How do I define it? It is passing through the geometric center. Through the geometric center, infinite axis can pass. What is so special about it? The speciality about it is that this is parallel to the diameter. So we have a standard formula about xx, which is an axis passing through the geometric center of the semicircle and parallel to the diameter. Don't forget that. And about xx, the formula, you will have to learn this figure. Its formula is little complicated in a fractional form with pi and all that, but I have simplified to a simple fraction. And you learn this fraction 0.11003 raised to power r raised to power 4. So please learn this formula. Ixx would be equal to 0.11003 r raised to power 4. That will be the moment of inertia of the semicircle about this axis xx, which is passing through the geometric center and parallel to the diameter. Guys, everybody, if you want to take a screenshot, then I'll clear it and then you take why you want to take with this handwritten stuff. But if you want to note it down, you can note down, and it's your wish, whatever way you feel comfortable. I have nothing about studied full circle, right? Then we studied semicircle. In semicircle, you said here is the G. Okay, very good. Now tell me, beta, if I have these two parts A and B, okay, if the G of A and B, the geometric center of A plus B is at G, then I'm sure you will agree with me that geometric center of A would be on this line somewhere and geometric center of B would be on this line, and then only the combined geometric center will come at G. Yes or no? Correct, beta? Yes or no?
Yes, sir. Yes.
Yes.
That means if I knock off this part, then I'm sure you'll agree that the geometric center of this quadrant would be on this line. Yes or no? Correct? Yes or no? If I remove this part, then I'm left with a quadrant. Yes or no? Correct,
Yes,
beta?
Right.
sir.
So that means the geometric center will be on, let me write this as something. Now the geometric center will be on the line XY. Yes or no? Correct?
Yes, sir.
Okay. Now if I take the semicircle like this, okay, where will be the geometric center of this semicircle which I am drawn in red? The geometric center of this semicircle
Sir,
will be
where
4r by 3 pi
radius.
somewhere here, right, beta? It will be here, correct? Yes or no? And
Yes,
now
sir.
if I knock off this part, then the geometric center of this quadrant would be on this line also. Yes or no?
Yes, sir.
Correct, bit? Because if I take the semicircle in this orientation, so that means where will be the geometric center? The geometric center of the quadrant would be here at a distance of 4r by 3 pi from here and 4r by 3 pi from this side also. Let me just clear it. I'll explain again if anybody has any doubts. But if you can understand, good. If you cannot, now I make it a, now up to this you did with semicircle, right? Now I make it a quadrant. Now it's quadrant. Okay. What will be the area? It's 1/4 of the circle. What was the area of the circle? Pi r square. So area will be pi r square by 4. Where will be the geometric center of this quadrant? It will be on this line and a similar line drawn like this from this radius. The geometric center shall be at the same distance from each of the radii. So if it is at a distance of 4r by 3 pi from this radius, it shall be at the same distance from this radius also. That means where will be the geometric center of this quadrant? The geometric center would be here 4r by 3 pi from each of the radii. That means the geometric center is here as reflected by G in the diagram. This is where the geometric center would be. So the distance of the geometric center in case of a quadrant will be 4r by 3 pi. It's the same formula. So there's no change in the formula what we learned earlier. It's 4r by 3 pi from each of the radii. Okay. Now for moment of inertia, we have again two formulae. One is my circle was like this, and if I make my circle was like this, guys. Now if I keep the same axis, this axis, but I remove 3/4 of it, the moment of inertia will become 1/4 of what? 1/4 of pi d4 upon 64 or pi r4 upon 4, which was for the full circle. It will become 1/4 of that. Yes or no? Correct, beta?
Yes.
Okay.
Yes, sir.
About ZZ. Now, whether I take about ZZ, moment of inertia, or I take about AA, do you think the moment of inertia about both these axes would be same? Yes or no? Why?
Both will be same. Sir. Both will be same.
Very good. Very good. So, IZZ and IAA would be same. And they would be equal to what? 1/4 of that of a circle. 1/4 of the circle would be these values. Correct, guys?
Yes, sir.
Okay. Then we also need to have a formula about an axis passing through the geometric center. You can see which are those axes. One can be XX passing through the geometric center and parallel to the radius ZZ. And the other axis can be this. Both will be same. Doesn't make a difference whether you're taking about YY or XX. In this case, IXX will be equal to IYY, and you don't have to make it another formula. It will be half of that of a semicircle. So don't make another fraction. Write it as 0.11003 by 2 r raised to power 4 so that you don't have to remember too many figures. Don't make it again divide 0.05 and don't do that because then you'll mess it up. Just keep it simple. It's half of what it was about for the semicircle. Why? Because the axis is the same, x is the same axis as for the semicircle. Only thing is half the area has been removed. So the theorem of parallel axis. This is mentioned in your syllabus. This is extensively applied. And sometimes it can be part of your theory question also. Describe or explain theorem of parallel axis. This is theorem of parallel axis for moment of inertia. That's what we mean. Now you can take any shape, does not have to be regular geometric shape, but since rectangle is the easiest to make, we can explain it with the help of a rectangle. Let's say we have this rectangle here and suppose of length L and breadth B. Suppose I want the moment of inertia about this axis ZZ. Okay. Now, what you can do is through the geometric center of this shape, we don't have to call it rectangle, it can be any shape. Through the geometric center of this shape, we draw an axis parallel to ZZ. We draw an axis parallel to ZZ. So what was the thing? Whose moment of inertia we wanted? We wanted the moment of inertia of this area. About which axis? ZZ. What have we done? We have drawn an axis parallel to ZZ through which point? Through the geometric center of the shape. Now, when you have this thing done now, as per theorem of parallel axis, what will you do? If you have to write in theory, you'll explain what I have just spoken. That we have a shape, let us say rectangle. We want moment of inertia about the axis ZZ. We draw an axis parallel to ZZ through the geometric center of the rectangle. Let's call that as YY. Once you have explained your diagram, then as per theorem of parallel axis, IZZ is equal to IYY plus the area which is in question into square of perpendicular distance between these two parallel axes. This is the expression for theorem of parallel axes, guys. IZZ is equal to IYY, or more instead of YY, do one thing, don't write YY, write small gg, so that it always reminds you this passing through the geometric center. Make it gg. IZZ is equal to IGG plus AD square. This is the theorem of parallel axes. Now, the same thing, when you put it in words, it becomes the definition of the theorem of parallel axes. What would it be? Theorem of parallel, as per theorem of parallel axes, moment of inertia, you don't have to mug it up, huh? And look at this formula and I'll keep pointing out. As per theorem of parallel axis, moment of inertia about any axis, in this case the any axis was ZZ, is equal to sum of, this is the sum of what? Moment of inertia about a parallel axis passing through the geometric center. That means we are talking of IGG. So sum of moment of inertia about a parallel axis passing through the geometric center and the product of the area with the product of the area and the square of distance between the two axes. Square of perpendicular distance between the two axes. So the same thing when you express in text, or you explain it, that becomes the definition of the theorem of parallel axis. So as per theorem of parallel axis, moments of inertia about any axis is equal to sum of the moment of inertia about a parallel axis passing through the geometric center together with the product of area and the square of perpendicular distance between the two axes. This is what is theorem of parallel axis. Any questions on it, guys?
Yes, sir. So this IZZ, ZZ is the axis which is parallel to this.
No, IZZ is the axis about which you wanted the moment of inertia.
Okay, sir. But it is there is no relation between this GG axis and ZZ axis. Like it is parallel in this case.
So we'll draw GG will always be drawn parallel to ZZ. So it is, you start from ZZ, don't start from GG, right? GG is drawn.
Okay.
GG is drawn parallel to ZZ, right? So it's Z which will define the orientation of GG, right? Am I clear?
Okay, sir. Okay. ZZ is the any axis.
ZZ is the required axis about which is the axis of interest, right? About which you need moment of inertia, correct?
Okay, sir.
And since ZZ is not, I can't use my standard formula here. So what am I attempting? I will see if I can draw a parallel axis through geometric center and see if I can use the standard formula and then get the moment of inertia about ZZ by using theorem of parallel axis. Is that clear, beta?
Yes, sir. And sir, A is the area. Which area is this? The area of the rectangle.
Area whose moment of inertia is being taken. Whose moment of inertia is being taken, correct? Clear?
Okay, sir.
Now I'll tell you, let me take an irregular shape just to put you, one of the axis must pass through the geometric center. You cannot say, I have another axis here, ZZ, and I have YY. Can I apply theorem of parallel axis between these two? No. For theorem of parallel axis, one of the axis must pass through the geometric center. Is that clear? Clear, beta?
Yes, sir. Yes, sir. Sir, can you once again repeat the definition?
So the units of measure in ship stability that we often use are tons per meter square. So guys, you will be able to calculate the pressure at any point below the surface of the liquid now when it comes in the numericals. I hope we don't have to go again looking for this formula, right? And the units of pressure will be tons per meter square. Any questions on this, guys? Done?
No.
Okay. Then the next term we need to know is, before we get on to the center of pressure, is the thrust. If you have a surface which is immersed, like if you fill up a tank with, say, water ballast, the bulkheads of the tanks, different points in the bulkhead will experience different pressure. Why? Because they are at varying depth from the liquid surface. Now, if the pressure at all these points is aggregated, integrated, it will result into the total force acting on the surface. That total force acting on the surface is called as the thrust. And since it's force, SI unit should be newtons, but as with pressure, here also the G is kept aside. So this thrust will be expressed in tons. Okay. So tons, the thrust is the force exerted on a surface. As regards ship stability, we'll limit our scope to thrust, that is force exerted by the liquid on any immersed surface only. Thrust on the immersed surface is obtained by, how do we obtain the thrust? All of you know it. We find the pressure at the geometric center multiplied by the immersed area. We find the geometric center and we multiply by the immersed area, and that's what will give us the thrust. So thrust is equal to pressure at the GC of the immersed area multiplied by the immersed area. And we have just studied what is the pressure at any point. Pressure at the GC will be the depth of the GC into the density of the liquid. This will be the pressure multiplied by the immersed area will make it thrust. What were the units of pressure? Pressure was tons per meter square. What is the unit of immersed area? Meter square. So what will be the unit of thrust? Tons. So units of thrust will be tons. Guys, let me clear it and leave it for you to see and ask if any doubts. I don't think there should be any doubt on this. This we have been using right from our PC days, right? Correct, guys? Pressure and thrust is okay, guys?
Yes.
Will be used? Yeah, okay. Now we come to the center of pressure. Beta, what is center of gravity? It's a point through which the entire weight of a body can be assumed to be acting through. Why? Because weight is a force made of different constituents. And if this entire weight has to be represented as one force, then it must act through a point, and that is called as center of gravity. Center of gravity is like the center of force of weight. You have center of buoyancy like that. Similarly, we just studied thrust. What is thrust? Force. Acting where? On the immersed area. That area is made of different parts. Now, if I say the thrust, like the weight of the ship, if I say thrust is one force, then this one force should have a center through which this force can be assumed to be acting through. And the center of this thrust, force of thrust, is called as the center of pressure. Center of pressure is the point through which entire thrust can be assumed. It is not acting through there, it's acting over the entire area, of course. It can be assumed to be acting through that point, and that is called as center of pressure. Thrust is the force exerted on the liquid by the liquid on the immersed area. If the thrust exerted on a surface is to be considered as one force, it can be assumed as one force acting through the center of that particular force, called as the COP. So what is COP in the first place? COP is the point through which the total thrust, the entire force of the thrust, can be assumed to be acting through. Like the entire weight can be assumed to be acting through center of gravity. Entire buoyancy can be assumed to be acting through center of buoyancy. Likewise, they were also forces. Similarly, thrust is also a force. So the point through which entire force of thrust can be assumed to be acting is called as the thrust. Is the meaning of is called as the center of pressure. My mistake. So is the meaning of COP clear, guys?
So 1 minute.
Okay. COP is the point through which the thrust can be assumed to be acting through. The total force of thrust can be assumed to be acting through. So if there is one point through which I can say the total thrust can be assumed to be acting through, that point is the center of pressure. Is that clear, guys?
Yes, sir.
Now, to get the distance of the center of pressure, we have a formula. It's a derived formula. Its derivation is not very difficult, but it's not part of our syllabus. But any one of you at any stage in your life want to go through it, pick up directs. In the chapter on center of pressure, you have the derivation of center of pressure in the directs. Okay, guys. So I have told you the source where the derivation is available to you in case you want to see it. What you need to learn is this formula. Yesterday I corrected it and again it has become DLL. Let me just see why it's not getting saved.
पी लिया मैंने पी लिया खत्म हो
I have done it the other day and it's again become capital. I don't know why. Now this is the formula you have to learn. Now understand each of these terms. What is COPL? This formula will not give you the distance of COP from wherever you want. No, you don't have a choice. This formula will give you the distance of the COP from liquid level. LL represents the liquid level. So the COP formula, center of pressure formula, will always give you from the liquid level. Am I clear about it? Clear,
Yes,
beta? Tomorrow you
sir.
cannot say, can I write this formula like this from the COP bottom? No, you can't write the formula. You can at the end do addition, subtraction and do whatever. But the formula will always give you from liquid level. Am I clear, guys? Clear?
So with respect to us, it means from the water surface.
Liquid level, it can be any liquid. No, why only water, beta?
Okay, understood.
Yeah, in a tank, the liquid may be oil or something, right?
Right, sir.
Okay.
Yes, sir.
Now, what is ILL? So this is the distance of the COP from liquid level. Please pay attention to this. What is ILL? I is moment of inertia. But when I told you the introductory part, I said, when don't stop at moment of inertia. Say, whose moment of inertia? About which axis? So it is the moment of inertia of the immersed area. It is the moment of inertia of which area?
immersed area
Area which is immersed in the liquid. And about which axis? Axis is liquid level. So I told you in the beginning, ask for area, ask for axis. I have answered both. ILL, excuse me, is the moment of inertia of the immersed area about liquid level. What is A? It is the immersed area. And what is DLL? It is the distance of the GC of the immersed area from liquid level. So when I'm putting this LL in the subscript, guys, it makes it easier for us to every time tell ourselves that where is this distance from, where is this COP from, where is this ILL from. If I just write like this, COP is equal to I upon A into D, this will leave numerous opportunities for being misunderstood, making mistakes yourself, and will not give you a clear picture. So it is, I would strongly recommend that you learn the formula in this form and every time use it like this. Is that clear, guys? Now, the first question, I will be talking aloud and I'll be doing the question. From second question onwards, you will try and help me in drawing the diagram, then solving it. And what I told you in the beginning is whatever I'll be speaking to you, you must speak to yourself when you're doing the question. If you develop this habit in all subjects, you'll never have a bad day. Now, I'm reading this question to myself as if I am attempting this question. I will be speaking to you and solving as if I'm talking to myself and solving the question. And please pay attention to the steps involved, the way it's being done, and I'll address all your doubts, whatever you have, once we have done that. Transverse bulkhead of a tank is 10 meters wide and 8 meters high. Put the word transverse bulkhead of a tank is rectangular because the shape is not put here. So that should not lead to any, I think that one word is missing from here. Okay, transverse bulkhead of a tank is rectangular in shape, 10 meters wide, 8 meters high. Find the thrust on the bulkhead and the distance of the COP from the base of the bulkhead if the tank contains seawater of RD 1.010 to a head of 3 meters. Now this is my bulkhead, which is 10 meters wide and 8 meters deep. It contains seawater to a head of 3 meters. When you say that there is a head of 3 meters, it means the water level is 3 meters above the top of the tank. Where is the top of the tank? This is the tank. That means the water is in the sounding pipes and air pipes. So I just make a sounding pipe or air pipe, whatever you want to say. And water is up to this place. Here is the liquid level. And this distance is the head of 3 meters. He wants you to find out the thrust on the bulkhead and the distance of the COP. Okay. Now, first and foremost, I identify the immersed area. Now, the immersed area would be, I'll just change the marker for sake of clarity. Now, first I identify the immersed area because thrust will be the force of the immersed area. This is the immersed area. Its shape is rectangular. So its geometric center will be the intersection of the diagonals. We learned a while back. Here will be the geometric center of the immersed area. What is the distance of this geometric center from immersed from here? This will be equal to half of 8 is 4 meters plus 3. This is DLL and this is 7 meters. Now you know how DLL is obtained in this simple case. Distance of the geometric center from liquid level is 7 meters. Okay.
Excuse me,
So
sir.
now, yeah, tell me.
Excuse me, sir.
Yeah, tell me.
Just one doubt. I mean, over here in the question, we say that the distance of the CAP from the base of the bulkhead, if the tank contains the salt water.
Never mind. Doesn't make a difference. So what difference it makes? Why? My formula will always be from LL.
No, that's true, sir. Just I want to understand the meaning of head of 3 meter. What does it mean?
I said no, head of 3 meters means that the water level is 3 meters above the top of the tank.
Okay.
That means water is in the sounding pipe and air pipe, correct?
So this saying 8 meter high, so it will be
8 meter high is the bulkhead, bete. So sounding will be 11 meters, no? If you take the sounding of this tank, the sounding will come 11 meters, right?
okay, sir.
Sir, can't it be like the level of the water is inside the tank and up to the sounding of 3 meters? The question says like this.
No, up to sounding of 3 meters means what? Sounding of 3 meters means sounding of 3 meters, beta. He's not saying sounding, he's saying head of 3 meters, okay?
The head of 3 meter means the pressure for the head for 3 meters, correct, sir?
Pressure will depend on the point where you're calculating the pressure, beta. Head means the level of the water above the top of the tank. Okay. Then I identified the geometric center of the immersed area. Then I have got the DLL. I'm loading my diagram with the information. Okay. Now, we just said the thrust on the bulkhead will be equal to pressure at GC. You don't have to write all this. I'm talking to myself. Pressure at the GC. Pressure at the GC will be equal to the depth of the GC below the liquid level. That is how much? 7 meters. Into density of the liquid. That is 1.010 given here in the question. This is, guys, this is only for explaining that I'm doing. This is the pressure at the GC. This multiplied by the immersed area. What is the immersed area? 10 into 8. This is my immersed area. And this will become the thrust in tons. Yes or no? Correct, guys?
So immersed area 10 into 8 we are taking, sir.
What else do you want to take of the bulkhead? Tell me, beta. What is the doubt? This is this doubt you're having because this is a 2D diagram. You place yourself on the ship. Is the sounding and pipe and air pipe, are they part of the bulkhead or they are inside the bulkhead? They are clear of the bulkhead, yes or no?
Yes, sir, they're clear of bulkhead, sir.
So this area which is causing you doubt is not part of the bulkhead. That is the sounding pipe, beta, which is not part of the bulkhead, right? If you see the side elevation, if this is the tank, this is bulkhead, this is one bulkhead, this is other bulkhead, then the sounding pipe may be somewhat like this, correct?
Yes, sir, yes, sir.
So then, if the water is in the sounding pipe, how does
up to 8 meters only, yes, sir.
Yeah, so this is the 2D diagram which is unnecessarily causing concern, right?
Sir.
Okay, guys. Okay, so whatever you get here will be the thrust. Can somebody give me the answer?
565.6.
56.5 tons.
Okay. Anybody has any questions on this, on the thrust part?
Yes, sir. This is Kumar Saurav. I do have a question.
Yeah, tell.
Just to ask about this, the pressure at the
10 into 8. What is DLL? 7. So into 7 square. This completes my numerator. Yes or no, guys?
Yes, sir.
And divided by the area, 10 into 8 into DL 7. And you don't have to do any other calculation. Now pick up the calculator, use your brackets and BODMAS and solve it on the run and give me COPLL. How many meters?
7.762.
7.762.
Okay, everybody to calculate and everybody to see that you're clear with the calculation of each component of this formula.
762.
Yeah, 762 somebody is saying, I don't know. I'll show you the component. Never mind.
1.762.
Okay, very good. Is that okay with everybody in the class? Okay, guys, the question does not want from liquid level. Question wants from the bottom. Now, suppose the center of pressure is here. This is the distance I have got. You don't have to mark in the diagram. What does the answer want? He wants this as the answer. So what do I do? From sounding, I subtract it? Yes or no?
Yes,
correct,
sir.
guys?
3.238.
So, yeah, COP from base would be equal to the sounding minus COP LL. And this will be whatever it comes to. The answer is again on display here. Thrust is 565.6 tons and COP from base, also sometimes referred to as KP, as 3.238 meters. Please review.
I did not, so I missed out on after calculating COP. Actually, I was calculating COP and we went ahead.
Okay, what does the question want? Read the question, it's on display. What does the question want? Where does he want the COP from?
Base of the bulkhead.
What has the formula given you from? Where has the formula given you from?
From top.
Liquid, no, not from top, from liquid
level. Liquid level. Yeah.
Don't use the wrong words, then you'll fall in a trap otherwise. Okay. What is the distance between the bottom of the tank and liquid level? Look at the diagram. What is the total distance? Equal to sounding? Yes or no?
Yes, 11 meters, yeah.
Yeah, that's all. 11 minus this.
Oh, okay.
So that it is easier for you initially to comprehend the question. So this is the area of our interest now. Correct, guys? Right? Tell me what will be the distance of the geometric center of this immersed area from the liquid level? Go to the property of triangles. We have done it.
So median.
By 3 of 8.
My question is not about median. My question was what will be the distance?
4 meter and DLL will be 4 meters.
Sorry?
1 by 3 by 8.
That
1
by 3 times D from the base.
So what is D, beta? Talk in context of this question. I want to see whether you can correlate that to the question.
8 meters.
8 meters from bottom, sir.
Sir, 2 from the base, sir. 2 meters from the base.
I'm asking you this blue triangle, where what will be the distance of, please listen to the question carefully. What will be the distance of the geometric center of the blue triangle from the liquid level? This LL.
1 by
1 by 3, 1 by 3 sir. 8
The,
meters.
what, 1 by 3 of what? Figure batao na.
8 meters.
8 sir, 8.
So
8
now,
meters.
now the class is telling me G would be somewhere here. And what they're telling me is that this is DLL. And they are saying DLL is 8 by 3. Correct?
2.66.
No, don't round off. It will be rounded off in the calculation automatically. Hai na? Why unnecessarily do rounding off here also? Correct, beta? Does everybody agree DLL is 8 by 3? Yes or no?
Yes, sir. Yes, sir. It is
1 by 3 of 8.
Yes, sir.
Correct, beta? Because 6 meter is the base and corresponding height is 8 meter of the triangle. Yes or no?
Yes, sir.
Okay, very good. So
Yes,
now
sir.
he wants thrust also. So now the thrust will be equal to, I'm talking to myself, I'm not going to write like a pre-C guy writing all the steps. Maximum you'll say pressure at GC multiplied by area, and it will be pressure at GC will be equal to, the depth of the point is 8 by 3 into density of the liquid, that is 1.025. This is the pressure at the GC multiplied by area. Area will be half, base is 6, height is 8. So many tons would be the thrust. Do you agree with me? The expression, don't worry, focus on calculations. Do you agree with this expression that I've written, guys? This is the area here of the immersed part. And this is the pressure at the GC. Does it make sense? Yes or no?
Sir, in question it is asked from take center thrust from bottom of the bulkhead, but we are taking from the liquid level.
अरे COP from the bottom पूछा है बेटे, उसने thrust थोड़ी bottom से होगा. Thrust will be the force.
Okay, okay.
He's not asked you the thrust. Position of the COP.
Okay.
Thrust is not from bottom or top. Thrust is thrust. It's the pressure at the GC multiplied by area. Correct? Don't get confused, right?
Okay, sir. Thrust is clear.
Okay. So the answer is 65.6 tons. I just saw it and
Yes, sir. 65.6.
Okay, guys. Any questions up to thrust on this? It's a MMD question. Then he says, what is the distance of the COP from bottom? But we will get from COP liquid level, right? Will be equal to ILL upon area into DLL. Let's calculate the area. Okay, area baad mein, it's okay now, mate. Okay, what is ILL equal to? Now, is ILL is liquid level a standard axis for the blue triangle? Yes or no? First answer that.
Yes, sir. Yes, sir.
Liquid level is a standard axis for this.
No, sir. No, sir.
Yes. Yeah, you know, it can be.
That
it
is
can
not
be.
passing through G.
No. But you know one formula, no? Base also. You have another formula, no? BD cube by 12.
Yes, sir.
Correct? You can use BD cube by 12, or if you want to use GG, you can use, I'll solve it by both. Okay, now, mate. If I want to use theorem of parallel axis, then I'll draw GG through geometric center, and this will become IGG plus area into DLL square divided by A into DLL. What will be IGG? It will be BD cube by 36. For blue triangle, what is B? 6 meters. What is D? 8 meters. So BD cube upon 36 IGG. So this is this figure. Plus area, half base into height into DLL square, 8 by 3 whole square divided by area is half, 6 into 8 into DLL is 8 by 3. Where you'll solve this, this will come 4 meters. Please calculate it and see.
सर ये 4 मीटर आ रहा है बट 6 into 8 क्यूब डिवाइड बाय 12 होगा सर वो
कौन सा? अरे मैंने
So,
थ्योरम पे मैंने थ्योरम पैरेलल एक्सिस लगाई है, मैंने दूसरे ढंग से किया, तुम यू हैव यूज्ड द बेस फार्मूला, आई एम यूजिंग जीजी फार्मूला फर्स्ट, आई हैव
अच्छा
यूज्ड
हाँ
थ्योरम।
हाँ सर वो देखो ओके सर।
That's what I said I'll do by both the methods, na? So first I have applied the theorem of parallel axis to reinforce the theorem of parallel axis, okay?
Okay sir.
What you have done is this: ILL upon A into DLL, and तुम्हारा ILL directly you have taken as base 6 D cube 8 cube by 12 divided by area half base into height into DLL 8 by 3, and this is also coming 4 meters, right? This is what you have done.
Yes sir.
They're both going to give you 4 meters. Guys, any questions? If anybody has any questions to ask. Hanji, all clear up to this point, guys? And the question does not want from liquid level, question wants from the bottom. So COP bottom will again be 4 meters, but you have to show the step will be equal to the sound. Please read the question and see if you can make a diagram, but make it in rough. I'll not be doing this question in the class. I'll give you the answer, but I'll take the next question in which we have a semicircle. The bulkhead of a tank comprises of a rectangle atop a triangle. So I'll just so I'll leave it here. You can do it. I'll send you these questions with answers. Don't worry, you don't have to waste time taking it down. We have more important things to do than. I'll not take this one also. Let me take this one first. Is it semicircle? Let me take this one. Yeah. The bulkhead. Now this I'll solve with. We'll solve together in the class, beta. Bulkhead of a tank comprises of a rectangle atop a semicircle. So it's a semicircle. On top of that, you have a rectangular bulkhead. The rectangle is 10 meter wide and 8 meters high. So 10 meter wide, 8 meters high is the rectangle. And it is atop a semicircle. So obviously the semicircle will have the same diameter as 10 meters, correct? So you see, everything need not be given in the question. You have to use your shipboard experience also. So I'm sure you'll agree that the diameter of the semicircle, though not given in the question, would be 10 meters. Yes or no? Correct, beta? Read the question and see.
Yes, sir.
Okay. Does everybody agree with the diagram? Now tomorrow you should not get confused. The diameter, the radius of the semicircle was not given, sir. How to do it? Okay. Tell me who will tell me what is the height of the bulkhead?
5, sir.
Sorry, height of the bulkhead is
5 meters.
height of the bulkhead.
13 meters. Sorry, 13 meters.
13 meters is the height.
13 meters.
13 meters. Very good. 13 meters. So he says it contains seawater to a sounding of 15 meters. Means there is a head of 2 meters, right? Correct, beta?
Yes, sir.
It contains seawater to a sounding of 15 meters means what? There is water in the sounding pipe, air pipe, and there is a liquid level is somewhere here, and this head is 2 meters. Yes or no? Why? Because bulkhead is 13 meters high and total sounding is 15. So head of 2 meters, yes or no?
Yes,
Yes,
yes.
sir. So
Guys,
sorry, I'm not getting it.
What are you not getting it? Tell me.
So how 13 meters? I'm not able.
So as per you, what should be the height of the bulkhead? Look at the diagram and tell me the height of the bulkhead. As per you, what should be the height of the bulkhead? Height of the bulkhead, I mean this distance, right? How much should it be as per you?
Yes, sir.
How much should it be?
8 मीटर above होगा सर, नीचे रेडियस होगा सर,
अरे
रेडियस
अरे नहीं, इसको बोल लेना ना यार, लेट हिम स्पीक. हाँ, as per you, what should be the height of the bulkhead?
So 8 plus 4.
Why 4? 4 has come from where?
1 meters wide and 8 meters high. So but radius भी तो दिया नहीं है ना.
So ship पे bulkhead कैसा होगा? How is the bulkhead on the ship?
diameter है यार वो.
So have you seen a bulkhead like this, that it is broad on top and then the semicircle is like this with protrusions on outer side, each side?
No sir.
Or have you seen a bulkhead
sir,
like
no,
this?
sir,
No,
no.
or have you
Right,
seen a
right, right.
bulkhead? Have you seen a bulkhead like this?
No sir. Understood sir. Well understood.
So now what is the height?
समझ गया.
Hey, what is the height?
13
समझ
sir.
तो-
8
8 plus?
8 plus
From
5
where?
sir.
Yeah, 5 is the radius of the bulkhead, right? Or the semicircle, right? 10 is
10
the diameter.
yes.
Okay, fine. So that means the head is 2 meters, guys. Okay. So now we have two shapes, and similar thing we'll have in the triangle question also. So we'll have two shapes. One is a rectangle and one is a semicircle. So let's first calculate the areas separately. It will become easier for us. What is the area of the rectangle? Now I'm talking of immersed area. The full area is immersed, obviously. Okay. So area of the immersed rectangular part is 10 into 8 equal to 80 square meters. What is the area of the semicircular part, beta? It is pi 22 by 7 r square 5 square divided by 2. Why? Because pi r square is for the full area. Pi r square by 2 is for semicircle. Can you calculate and give me how much this area comes to, guys?
39.28.
280?
286, 39.270.
39.270.
No, don't use 3.14. Use 22.7. 22 by 7.
39.286.
286. Yeah. So 39.286. Okay, fine. So now we have got these areas. Now, where will be the distance of the geometric center of the rectangular part? Where will be the geometric center of the rectangular part? The geometric center of the rectangle will be here at G1. And this distance is, let us say, I can call it as D1 rectangle or DLL rectangle, right? DLL rectangle will be how much, guys? Can you tell me? How much?
6.
6.
6
4
meters.
plus
6
2,
meters.
6. Does everybody agree DLL of rectangle is so much? Yes or no? Somebody, not many people are participating. Kya hua bhai? Is it clear or no?
Understood sir. Understood sir.
Clear,
6.
clear, sir.
Understood. Okay.
Yes.
Where will be the geometric center of the semicircle? It will be somewhere here. Correct, guys? Yes or no?
Yes sir.
Yeah. So this distance will be 4r by 3 pi. Yes or no?
Yes, sir.
And this distance, this full distance, will be equal to DLL of the semicircle. Yes or no? Correct, beta?
Understood sir. Yes sir.
Yes.
So can you calculate 4r by 3 pi?
So DLL2 will be 10.121.
10.121. I have written. Let somebody confirm. I don't know. I'm just writing whatever you're giving me. I'm not saying it is correct or right or wrong. Let me just calculate 4r by 3 pi also. 4r 4 into
12.11.
2.121.
Sir, 12.123.
12.12.
12 आएगा ना?
DLL of
Okay,
semicircle.
okay, fine.
Sorry,
Four.
sir, 12.121. Yeah, I missed that.
Okay, you missed out the head, I think. Okay, now mind. Okay, now mind. 4 into r divided by 3 divided by 22 multiplied by 7. 3.712. It is 3. Is it coming 3.712? How much is this one coming?
2.121.
Am I making mistake? 4 into r
2.12.
upon 3 pi, no? Okay, 2.121. Yeah. So this is 2.121, and then everything falls in place. Guys, any question on
So DLL is coming 12 point something, right?
DLL of the rectangle is coming
Semicircle.
as 6 meters, and I'm writing here DLL of the semicircle is coming as 12.121.
Correct. Correct. 12.1.
Any questions on these four things? Area of the rectangle, area of the semicircle, DLL of the rectangle, and DLL of the semicircle. Guys, any doubts on that? None?
No, sir.
Okay.
Yes, sir.
So now we know the total area, immersed area, will be equal to 80 plus 39.286, which will make it 119, right? 20 चला जाएगा तो yeah 119.286. Yeah, correct. And we can calculate the geometric center of the combined area, guys. DLL. This you have done in phase 1 when you are doing Simpson's rules. If you have two different areas, you know their livers, then what do? A1 into D1 plus A2 into D2 upon A1 plus A2, yes or no?
Yes, sir.
Correct, guys?
Yes, sir.
So DLL is the distance of the geometric center of the full bulkhead. That means rectangular and semicircular combined. It will be, yeah, area of the rectangle 80, DLL of the rectangle 6, plus area of the semicircle 39.286, and 12.121 divided by the total area 119,286. Can you calculate and give me DLL?
8.016, sir.
Okay, 8.016 is one answer that has. Okay. Now, anybody has any questions on getting DLL? Don't hesitate, because there's no point in rushing forward with it.
Can you just repeat the last one?
Which one, beta? Tell me.
Yes, sir.
The DLL formula?
Yes, sir.
Beta, you must have done Simpson's rule. You must have done the Simpson's rules in which you had, you remember, you had in Subramaniam sir's book, you had a bulkhead like this and a rectangular appendage down below. So you said this is area A1, this is area A2. Then how did you find the total area? A1 plus A2, yes or no?
Yes, understood, sir. Like moments method, right?
And then moments, yes, this is the moment of the rectangular portion about liquid level. This is the moment of the semicircular portion about the liquid level. Correct?
Yes, sir.
So we have taken the moments about liquid level, right? Now it's okay. Now it falls in place.
Yes, sir. Sounds clear.
So the numerator is the total moment of the bulkhead about liquid level divided by total area will give you DLL. Is that clear, beta, now?
Yes, sir.
Yes.
Okay, guys. So the thrust will be equal to now DLL is 8.016. Density is seawater into total area is 119.286. And this becomes the thrust. And this should be coming to 980.101. Just see.
Yes, sir. 102.
Yeah, okay. That's rounding off issue. That's not an issue. Okay. Is that clear, guys? So that gives us thrust.
Yes, sir.
Okay. Let everybody come and calculate up to this place. Now, whatever steps we are going to follow now for COPLL, same steps will apply to that triangle and rectangular bulkhead which we jumped. Only thing is there, instead of a semicircular bottom part, you'll have a triangular bottom part. Okay, that's the only change that will happen, nothing else. Okay, now COPLL, guys, will be to ILL of what? Of the full bulkhead divided by what? Full area multiplied by DLL. Full A you already have 119.286. DLL you already have. Yeah, so now CO, like the moments, even the moment of inertia of different components can be added. That means I can have ILL of the triangle plus rectangle. I drew rectangle but said triangle. Okay, plus ILL of the semicircle divided by A into D. If you're not comfortable making these symbols, you can put A1 and A2 in your diagram. So it's up to you how you want to present. Okay. That much variation you can do. Does everybody agree with this formula that I have made now? Any questions on this? The numerator ILL of the whole area would be equal to the sum of the ILL of its constituents. Now, look at the diagram. Is ILL a standard axis or rectangle? Yes or no?
No.
No.
So what do? I draw a parallel axis through G1, the geometric center of the rectangle. And now since it's G1, maybe I can call them as XX, no problem. You can name whatever you want, XX. Guys, please tell me, apply theorem of parallel axis for ILL. ILL rectangle.
Sir, IXX
8 cube
plus
into 10
IXX of the rectangle plus area
8
of the
square
rectangle
into D.
DLL of the rectangle whole square.
Rectangle.
Guys, this is in the box bracket is theorem of parallel axis for the rectangle. Does everybody agree or any questions? I have just put this box bracket. It has no mathematical significance. This is only to make sure that we know that this is what has been applied from here, because all things will be plus, plus, plus. So box bracket has no relevance, but this will help us in making sure that we don't mess around with the theorem of parallel axis. Correct, guys?
Yes, sir.
Likewise, somebody who feels he needs to revise, or first take a moment, write down the theorem of parallel axis for ILL semicircle. Let's call this axis as YY. We're passing through the geometric center of the semicircle. Let's call it as YY. And I'm writing quietly. You can compare after that and tell me. Is that correct? IYY of the semicircle plus area of the semicircle into DLL of the semicircle whole square, the square of the D, right? Divided by, I have A and DLL in this formula which comes here, right? Guys, please satisfy yourself with this step first, because if you have any issue, we resolve that first. Please feel free to clarify if there's any doubt. Now I'll straight away start putting the values, beta. Now you see, this is after this you straight away put the values, and then don't calculate each part. Just use the calculator and solve it on the run and give the answer straight away. What am I saying when I'm saying now I'll put the values? You see, I'll use the blue mark here so that it over. IXX of the rectangle. Look at the diagram. Diagram will speak. For the rectangle, IXX will be equal to 10 into 8 cube upon 12. Does everybody agree this is IXX rectangle?
Yes, sir.
Then plus area of the rectangle is 80 square meters and DLL of the rectangle is 6, so 6 squares. So this is the second term I have put here. Yes or no? Now I don't have to put box bracket. I can continue putting plus, 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 right, beta? Everybody agrees what has been put in blue? 10 into 8 cube by 12
Yes,
plus
sir.
80 into 6 square, right?
Yes, sir.
Plus IYY of the semicircle, if you remember, it was 0.11003 R raised to power 4. R is 5 meters. So 5 raised to power 4. This is IYY of the semicircle. Yes or no, guys?
Yes, sir.
Yes, sir.
Yes.
Plus area of the semicircle was 39.286 into square of the distance. The distance was 12.121 square. Whole thing divided by the total area. Total area is 119.286 into DLL 8.016. I have just, this is how you'll do whatever I'm writing. These steps are more than enough. And now you will not simplify any further. You'll just write COPLL is equal to so many meters, and this should be coming 7.566. Calculate and see. This should be coming 7.566 meters. But get into the calculation only if you're convinced with the steps.
Sir, 9 point आ रहा है सर, 9.566.
नहीं सॉरी 9 पॉइंट आएगा, ये तो बेस, ये बेस से होगा ना शायद, एक मिनट, नहीं टॉप से, थोड़ी सॉरी टॉप से, इसमें 9 आएगा, माय मिस्टेक, 9.566, माय मिस्टेक, because I picked up from the answer actually. Okay, 9.566, you are right, very good. And the question says find the COP from the bulkhead top. Bulkhead top is 2 meters below this, so therefore COP from bulkhead top will be equal to 9.566 minus 2 meters equal to 7.566 meters. This is the answer to the question. Correct, beta? So
Yes.
answer to the question is 7.566 only. So through this example, what have we done? We have used the formula for semicircle. We have done the combination concept. Now combination shapes can be any shapes. We have done the combination. So in the earlier question, instead of this semicircle, this was a triangle. Concept will remain same. Yeah, tell me. Liquid. And the COP is given. Instead of finding COP, he is saying COP from the base of the bulkhead is given. Calculate the sounding. It has to be done the opposite of it, what you have done until now. Correct, beta?
Yes, sir.
Yes.
Okay. Or no, this question I'll take tomorrow. Don't worry. This question I'll take tomorrow. Leave it here. Let me just show you something. Let me discard everything here. Guys, I'm sending you these questions. I'm sending you these questions to you. Okay. This part, the last question I have left. Some we have solved. First we solved. Second we solved. This semicircle one we have solved. What we have not solved are the two questions here. Now in these two questions also I want to draw your attention to this one before I close, because I want people to be able to solve it. Here he says there is a triangular bulkhead with apex upwards. He's not said apex down here, you see, be careful. Here is a triangular bulkhead in shape with apex vertex upwards. The triangle has a base of 10 meters and a height of 12 meters. The bulkhead is like this, awkward bulkhead, but the question says so, so it's so. Find the thrust on the bulkhead and the distance of the COP from top of the bulkhead if the tank contains oil of RD 0.93 to a sounding of 9 meters. That means the liquid level is somewhere here, with this being 9 meters. Okay, and this is basically this is your immersed area. Correct, guys? Am I right? Correct?
Yes, sir.
What is the shape of the immersed area? Trapezium. Now this question can be done in multiple ways. Whole triangle minus small triangle, this, that, it can be done in multiple ways. Okay, so don't get surprised if you see the solution in some other way somewhere else. The simplest of all, time tested simplest of all, is to draw any one diagonal of the trapezium, this diagonal or the other one, whichever you want to draw. And this will divide the trapezium into two triangles, 1 and 2. Correct, beta? Correct? Yes or no?
Yes.
Okay. You have just done a case where there was a rectangle and a semicircle. We have also one question in the exercise where shape is rectangle plus triangle. Now in this question, we have shapes which are triangle plus triangle. Doesn't make a difference. We use the combination concept, but both are triangles. Is that clear? Is that clear, guys?
Yes, sir. Clear.
Shall we do this question? Shall we do this question right now, or you want to do it on your own? And if there are any, so
We'll
I
try.
don't. Yeah. So as I told you in the beginning, guys. Yeah. Oh, as I told you in the beginning, I am not in a hurry to rush through, but make a sincere effort. Figure out your problem areas. I'll try and answer them tomorrow, and then we'll get going with the curvilinear shape. So even if half an hour, 40 minutes goes into it, it's absolutely acceptable. कोई problem की बात नहीं है. Do not worry at all. I'm sending you these questions, so you don't have to waste your time taking down these questions. These questions are coming to you. Okay? Or why don't you take the screenshot now only? Take the screenshot. Why you want to bother me? Can you take the screen? Take the screenshot now itself.
Yes, sir. Okay. Taken, sir.
So you have the answers, you have everything, you can solve the questions, right, beta?
Sir, am I audible?
Yeah, you are audible. You are audible.
Sir, in the last question, you have drawn the picture. Just an approach I have, I just want to say. Can't we do it taking the moment of entire triangle for calculating the DLL in the moment of small triangle?
Yeah, I told you this can be done in multiple ways. No, I said so, na beta. You missed out on my statement.
Yes, sir.
And I myself said that it can be done in more than one ways. But what I suggested was that the simplest would be to deal with two triangles. Okay, I said what will be the simplest to handle, because you're already used to adding two different shapes, right?
Yes, sir.
Why you want to suddenly go into subtraction mode and then mess it up somewhere? Okay.
Okay, sir.
So the D will be calculated by 2 by 3 and 1 by 3, right? Like that only, no? In this
Beta, in this, first you will calculate this part by similar triangles. Guys, what will be this value of x? Tell me. What do I divide? X by how much?
X by 10.
X by 10 is equal to 4 by 12.
Divide by
4 by 12.
3 by 12. This is 9 meters, beta.
Okay, sorry.
This is 3. No, it's okay. So this will be basically x will be equal to 30 by 12, right?
2.5.
2.5 exactly. Okay, 2.5. So first we'll calculate this. Now for triangle 1, now you see, guys, for triangle 1, base is 2.5 meters. Height of this triangle is 9 meters, right?
Yes, sir.
Triangle 2, base is 10 meters.
Height 9
meters. Height is 9 meters. Now you can solve. Now I don't think there should be a problem.
Yes, sir, no problem.
DLL for this will be 3 meters. DLL for this would be 6 meters. Correct?
Yes, sir.
Yes, sir. Because here is the vertex of the triangle 2. Yes or no?
Yes, sir.
Understood? Now I've given enough hint. Now do some thinking and solve the questions. You have the answers with you, right?
Okay.
Okay, sir. Right.
Okay, guys. We'll connect at 9:30 tomorrow. And as I said, please do not make it a practice to connect by 9:25. We keep another 5 minutes break up to buffer up to 9:35 to take care for any last minute delays which may happen once in a while in everybody's life. But try not to stretch it beyond that, because we would like to complete the things in time. By 30th, he says calculate the sounding of the tank. That means you need to find out where is the liquid level. I said when I don't know the liquid level in a question, there can be two situations. One is the sounding is less than or equal to the height. That means the liquid level is either below the top of the bulkhead or in line with the top of the bulkhead. That means it's not above the bulkhead. The second is the liquid level is above the top of the tank. That means the water is in the sounding pipe and air pipe. Now is it clear, guys? Clear, beta? Now first you'll have to figure. Yeah, so first you'll have to figure out whether the liquid level is above the tank, tank top, or not? That is the first thing you'll have to figure out. And then make the diagram accordingly, and then you'll solve the question. If you just blindly draw it wherever you feel like, the question is not going to give you the correct answer unless you, by chance, you draw it correctly. So therefore, in such questions, first thing would be to figure out whether the liquid level will be above the top of the tank, or it will be in line with the top of the tank or below the top of the tank, whatever it is. Now, read what I have given here. How will you figure out? Now, we are talking of regular geometric shapes, okay? Now, by use of, we have seen in the earlier questions also, we did a question where the triangle was had apex down and the liquid level was somewhere here. If you remember in that question, the COPLL came, it was 8 meters of sounding. COPLL came as 4 meters, and KP also became 4 meters. Why? Because we subtracted 4 from 8, it became 4. Do you remember that, guys?
Yes, sir.
This question we had solved. Yeah, right. So now, please, we have basically drawn our inference based on theorem of parallel axis. So this is all mathematically arrived at. And what is that? That in case the tank or the compartment is partly full, that means the liquid level is below the top of the tank, or it is just full. Just full means it is in line with the top of the tank. That means there is no water in the sounding pipes or air pipes. Okay. Which the same thing can also be said, sounding is less than the height of the bulkhead, less than or equal to. If the sounding is less than or equal to height of the bulkhead, then for these regular geometric shapes, the distance of the COP from base would be, for rectangle, it will be 1/3 of the sounding. For triangle, apex down, it will be half the sounding. You see, the sounding in this case of triangle was 8 meters, and from base KP came as 4 meters, exactly half the sounding. And if I make the triangle with apex up, then it will be 1/4 of the sounding. This comes if you take B and D and solve, you'll get these results. So it's not something unusual. But these results are good only if the sounding is either less than or equal to the height of the bulkhead. Am I clear now? Any doubts on what I have said until now, guys? Guys, any questions on this? What I've just said? Is that clear? You can take. Okay. Now, using this property, first you'll figure out, and then you'll make the diagram accordingly, and then you'll solve the question, which we will do now. Okay. Now, the first part of this question is from MMD exam. The second part is not from MMD. I have just put it here. Let's first look at the second part. The bulkhead is, how much high is the bulkhead? Read the question. It is on the screen. What is the height of the bulkhead, guys? It's a rectangular bulkhead. Okay, so it is 12 meters broad. Okay, 12 meters broad, 8 meters deep. Let's do the B part first. Tank contains liquid and COP is 2.5 meters above the bottom. Okay, now what does it mean? Guys, if the tank is full up to 8 meters, if the tank, so we will carry out a check with the tank completely full to the top of the bulkhead. If the tank is filled up to the top of the bulkhead, in that case, what will be the COP from base using this table?
2.667.
Sir, 8 by 3.
8 by 3, very good. 8 by 3 will be 2.667 meters, right, guys? Okay. In the second question, he says COP is 2.5 meters above the bottom. So it is less than 2.667. Right. Now, as the sounding will increase, the COP is also rising. Okay, COP is rising with the sounding, not linearly, but it is rising with the sounding. So if my COP is only 2.5 meters above the base of the bulkhead, that means my sounding will be less than 8 meters. Yes or no? Correct, beta?
Yes,
Why?
sir.
Because if the sounding was
Sir,
8
can you
meters.
please repeat, sir?
Okay.
Repeat, sir, this.
Okay. Now I'm asking you the question. You tell me. Firstly, what is the height of the bulkhead? Tell me,
8
beta.
meters.
8 meters. 8 meters.
Okay. Secondly, answer. What is the shape of the bulkhead?
Rectangular.
Rectangle. If the sounding is equal to the height, that is 8 meters, looking at the table down below, what do you think would be the COP from base? Distance of the COP from base, not from liquid level. This table is from base, please remember. What will be the distance of the COP from the base, beta? In that case, if the sounding is 8 meters, equal to height.
2.667.
Very good, shabash. Now, if the COP is more than 2.667, then that means water is in the sounding pipes, correct, beta? Yes or no? Because then the sounding has to be more than 8 meters. If the
Yes, sir.
COP,
Yes.
if the COP, so if the COP is more than 2.667, then the sounding is more than 8 meters, the height of the bulkhead. If the COP is less than 2.667, then the liquid level is below the top of the bulkhead. Correct, beta?
Top of
It
the
is,
bulkhead.
yeah.
Yes,
That means the sound. That means sounding is less than 8 meters. Correct, guys? Understood?
Yes, sir. Yes.
So this means sounding is 8 meter or less than 8 meter, right?
No. If it is equal to 8 meters, then it will be 2.667 exactly. Yes or no? Then the COP will be 2.667. So let me make. So in this case, if the sounding is 8 meters, COP will be 2.667. If the sounding is less than 8 meters, then this will be less than 2.667, right? If the sounding is more than 8 meters, this will be more than 2.667. And now, am I clear in what I'm trying to say, beta? Is that clear to everybody?
Yes, sir.
Yes, sir.
So you will use this property first to determine whether the sound, where does the liquid level fall, where does the water level fall, or the liquid level falls. Now I'll clear this, whatever I've written. Any questions before I clear it, guys? Okay. Now let's do this question and we'll automatically get the answer to the second part should be obviously 7.5 because it will be 3 times. Now, but let's solve it. I'm doing the B part first, guys. This is the rectangle. I can solve on this. Not much space is required. It's 12 meters broad, 8 meters deep, and liquid level is somewhere below this, like this. Why? Because COP is less than 2.667 from base. And let's say this height is X. Now we have to find the value of X. Now you all know, guys, what will be this? This will be basically your immersed area. Okay. Where will be the geometric center of this immersed area? Here. What will be the distance from liquid level? X by 2. Yes or no? DLL will be X by 2. All of you understand that? Yes or
Yes,
no?
sir. Yes, sir.
Yes.
Okay. Right. So COP from liquid level will be equal to, because our formula is from liquid level, right? So let's apply that formula that we already know. ILL, now I have to use theorem of parallel axis. Okay, so it will be IGG of the immersed area plus immersed area into DLL square upon A into DLL. And this will be equal to IGG will be equal to, guys, 12 is the length, X is the side being cut. So 12x cubed by immersed area is 8x and DLL is x by 2 whole square divided by the area 8x into DLL x by 2. Does everybody agree with this expression that I have written or any questions on this? Yes or no? Please see.
Yes,
This
yes,
is
sir,
this
clear.
this is IGG. This is area. This is DLL square. Right, guys? Any questions on this?
Sir, breadth will be 12 we can understand.
Sorry.
Sir,
Area, sir.
Okay. I've taken area wrong. Okay, 12x. Thank you for correcting. Otherwise, it would have again been wrong. 12x. Okay, sorry. Thanks for correcting. 12x. Yes. Right. Is it okay now, guys? Okay, so this 12 gets knocked off. So what do we get here? This will be x cube plus this is 12x. This will become 12 into x square will become x cube, and 2 ka square will be 4. So this can also cancels out, becomes 3 divided by 12x. This 2 will cut this one. This will become 6x square in the denominator. What does it become now? This becomes 4x cube in the numerator and 6x square down below. Please solve it and see, does it simplify to this or am I making mistake? Take your time, solve it. Fatafat.
It's correct, sir. It's correct.
Yes, correct.
Right. So now x square gets cancelled with, we are left with x. This gets cancelled with 2 and becomes 3. And this COPLL, this is COPLL. So what do I get? COPLL is equal to 2 by 3 of the sounding. Correct, beta? Now, in this case, what will be the COP base? COP base will become x minus 2 by 3x. Yes or no? Correct, beta? Yes or no?
Yes, sir.
This is COPLL. From base, it will become sounding minus COPLL. And this will give you 1 by 3x. And this COP base value is given in the question as 2.5. This implies sounding is equal to 2.5 into 3 equal to 7.5 meters. Is that? Please look at it. Satisfy yourself. If you are not getting any point, let me know.
So can we directly calculate by these formulas which you are giving?
Beta, if it comes as a question, then you can't write straight away, right? But you know the answer before you start, right?
Yes, sir. Yes, sir.
You know the answer before you start, but you can, if it is a 10-mark question, you can't just write one property and say this is the answer. Right?
Yes, sir. Yes, sir. Got it, sir.
Is that clear, guys? Any questions on this?
2 minutes.
2 by 3x, x minus 2 by 3x. How it comes?
Sorry, beta.
X minus 2 by 3x. How it comes?
Okay. Now you tell me first. What is 2 by 3x? What is it? What is it?
This is COPLL from.
Very good. I wanted to hear that only. Okay. What is the question giving us? COP from base.
Wow, base. Yes, sir. Yes, sir. Yes. Okay, sir.
Right. So from the base will be x minus 2 by 3x. Yes or no?
Yes, sir.
Okay. So don't live with your doubts. Please keep clarifying. It's okay. I'm very happy most of you have picked up this, whatever was done yesterday. You seem to be in control of things. Can I clear this board, guys, and take up the part A then?
Sir?
Yeah, bolo.
Sir, assuming liquid is X meter above this.
So that is part A, na? That is, we'll do part A, na, beta?
No, similarly for part B also, sir. If X is my coming negative.
No. Calculations change. Don't do that. You can't take on top and X will not come the same negative, beta. Because after the full area is immersed, there is no further change in the area.
Yes. In that case, I'm getting 7.556.
So so don't do that. That's what I'm telling you, no?
Okay, so for below we have to use this.
You'll have to infer where the water line is, whether below the top of the bulkhead or in the sounding pipe or somewhere, right?
Yes. We have to interpret.
You have to, yeah. That's why these properties have been written here, no? But down below, you need to learn these properties, right? Okay. Can I clear the board, guys, if it's okay with everybody?
This equation COP base is equal to x minus 2 by 3x.
Yeah, so what is the doubt in this, beta? Tell me. The COP is 3 meters. What was our limiting value? 2.667. 1/3 of the sound height is one third of the height is 2.667, correct, beta? Our bulkhead is 8 meter deep. It's rectangular in shape. So if the level was in line with the top of the bulkhead, then the COP base should be 2.667. Yes or no? We discussed a while back.
Yes, sir.
Now
Yes, sir. Yes, sir.
here the COP from the base is more than 2.667. That means water is in the sounding and air pipes, right? So that means now for part A, the diagram would be like this, guys, which you are very familiar with. Liquid level is here. This is 12 meters. This is 8 meters. And you can take this head as X. Okay, or you can take sounding X, whichever way you do. It doesn't make a difference. You can take the head as X. So now, what will be the immersed area? Area will be, full area is immersed, that is 96 square meters. Okay. What will be the DLL? Anybody who wants to tell me DLL? DLL will be 4 plus X, yes or no? Geometric center of the bulkhead would be here. This distance will be 4 plus X, yes or no? Correct, guys? Correct. This will be the access through the geometric center GG. So now we write down. Now we write down COPLL. COPLL is equal to ILL, which will be IGG plus area into DLL square on area into DLL. I'm cutting short. I'm sure all of you can keep pace with this now. If anybody still has a problem, you can speak out and clarify. IGG would be equal to 12 into 8 cube upon 12 plus area is 96. DLL is 4 plus X whole square divided by area 96 into DLL is 4 plus X. Am I clear, guys? Yes or no?
Yes, sir.
Yes.
Yes.
Okay. Now, this will basically then become what? Okay. Now, here in this case, you can either subtract it later on or you can do whatever you want to do. Let me simplify it first. This becomes 8 cube. So it becomes 8 cube plus 96. Now, when you apply the A plus B whole square, it will be A square 16 plus X square B 2AB 28X. Am I right, guys? Have I opened it correctly? This is A plus B whole square is what you applied, right? Divided by 96 into 4. 96 into 4 is how much? 384 plus 96x. Am I right, guys? I've opened the bracket in the denominator, correct? Correct, guys?
Yes, sir.
Okay, let's simplify
Yes, sir.
further. Tell me, what is 8 cube coming to? 64 into 8? 8 cube?
512.
512. Let's open this bracket on top also. Plus 96 into 16 is how much? Can you multiply and give me? 96 into 16. We'll open this bracket.
768.
1536.
1536. 1536.
Okay. 1536 plus 96x square, right? Plus 96 into 8, beta.
768.
768x. We have opened the numerator also, and now divided by 384 plus 96x. Okay. Now this is COPLL. Again, you need to then subtract either from the sounding, or what you can do is, if COP is 3 meters, here this distance will be what?
5 plus X.
8 plus X minus 3. Yes or no? Correct?
Yes. 5 plus X.
Yes, sir.
Correct. The total sounding becomes 8 plus X. 8 plus X minus 3 will give you COPLL. Yes or no, guys?
Yes, sir.
Yes.
So this
Yes,
will
sir. Yes, sir.
yeah. So this will become equal to 5 plus X. Okay. Now, once you take this side, you will have some X square on this side also. So this will imply. Can you add these two values, 512 and 1536, guys? Add these values. This is 8, 4,
2048.
2048 plus 96x square plus 768x, and I take this on this side and multiply it. What will, if I multiply this will become here 5 plus x into 384 plus 96x, right? So you can open the right hand side also. This will be 5 into this will be 20. Open it, solve it then. 242 charge
1920.
1920, then plus 5 into this 3348x, right? 5 into 96x, right? Then plus 384x plus 96x square. Now what do you see, guys? 96x square gets knocked off from both the sides, yes or no? It gets cancelled, correct?
Yes, sir.
Okay. Now you have a linear equation in x. What is the equation you are left with? You are left with this. You can solve for x. I'm just simplifying, putting it everything here. 760x is equal to 1920 plus 480x. So 480 plus this, can you add this 384 and 480? This is 416, 864x, right guys?
864.
So now you can solve for x. Give me what is x equal to.
So 1.33 meters.
333.
1.33.
1.33.
333.
333 meters.
Okay. So x, the head is 1.33 meters. So what will be the sounding, guys? Sounding will be 9.333 meters. That is the answer, 9.33 meters, which you are seeing there. I'll remove the answer for people to review it. You don't have to be just confused with the simple a plus b whole square thing or opening up the brackets and dealing with the expression. Don't be scared of that. Just keep applying the normal maths that you know. Okay, I give time to everybody. Now sounding will be the 9.333 meters. Anybody has any questions, you are free to ask. Take your time to solve it by yourself if you want to. Don't be under pressure to say yes now, because if you are making mistakes, you'll be making mistake in simple mathematical expressions, nothing else. Sorry.
Yes, sir. In the middle, my net got disconnected. I just have one doubt that how did you get 5 plus x?
Which one is 5 plus x, beta? Look at the diagram. Look at the diagram. Look at the diagram. Tell me what is the sounding. If x is the head, then what is the sounding? Tell me what is the sounding.
It will be 8 plus x.
Very good. So write down in your notebook. Sounding is 8 plus x. Very good. Now, what is the distance of the COP from base given in the question?
3 meters.
So if the sounding is 8 plus x and the distance of the COP from base is 3 meters, what will be the distance of COP from liquid level, beta? COP-LL? It will be sounding minus
5 plus
x. That's what we've done. Because on the left we had this is COP-LL and we have equated to the COP-LL given to us, right?
Okay, sure.
And then we have solved for x. That's all. Understood?
Okay, sure. Yes, sir. Thank you.
Anything else, guys? Another 15-20 minutes, I'll keep quiet. You can review, make sure it sinks in.
Sir, yesterday I made this problem by taking x as below 8 meters, sir. So I
Yes,
get
sir.
the answer is 9 meters, sir.
So
Sounding as 9 meters.
So that you'll get wrong answer. That's not like.
Yeah. But I am saying that if we forget this formula of geometric shape and distance of COP, at the end we will maybe able to figure out that I make some mistakes, sir. I take the sounding lower level.
But how will you get to know if you're getting 9 meters? Of course, by solving, you're saying, okay. See, I don't know.
Yeah.
I'll have to look into more possibilities before I make a statement. But I think it's something you should just remember. There are only two that are horizontal ordinates. We don't mean horizontal parallel to ground, vertical perpendicular to ground. No. The horizontal or vertical ordinates mean the orientation of ordinates with respect to reference axis. Reference axis is the axis about which you need to get the moment of inertia. Okay, in different situations, different axis may be the reference axis, depending on what application we are doing. What do we mean by orientation of the ordinates? If the reference axis is parallel to the ordinates, then it's a case of horizontal ordinates. If the reference axis is perpendicular to ordinates, then it's a case of vertical ordinates. Have you understood what I have said until now? Don't worry about draw a diagram, show us, but is what I'm trying to say, is that well understood and received, guys? Understood, beta?
So can you just repeat once?
Reference axis means
the axis about which you need the moment of inertia. Correct? I said horizontal ordinates is the case or the situation when the reference axis is parallel. This symbol is for parallel, right? Reference axis is parallel to the ordinates. What does it mean? If this is my reference axis and my ordinates are like this, then it's a case of horizontal ordinates.
Horizontal ordinate, yes, sir.
If my reference axis is like this and my ordinates are like this is also a case of horizontal ordinates.
Horizontal ordinate.
Both are horizontal ordinates. Correct, guys?
Yes, yes.
Okay. But if the reference axis is perpendicular to the ordinates, that means if my axis was like this and my ordinates were like this, then it's a case of vertical ordinate. Or my axis was like this and my ordinates are like this. This is also a case of vertical. These two are cases of vertical ordinates. Correct, guys?
Understood now.
Is that clear to everybody? What do we mean by horizontal ordinate and what do we mean by vertical ordinate? That is the first thing you'll have to figure out even before you start solving the question, guys. A wrong judgment means wrong answer for sure. There cannot be even closer. It will be definitely out, completely out. Okay. So any questions on horizontal ordinate versus vertical ordinate, how to figure out? Is that clear?
No, sir, clear, sir.
Very good, shabash. Now, what is the approach if we have the case of horizontal ordinate? So let's figure out if it's horizontal ordinate. I identify the case to be horizontal ordinate. How do we get the moment of inertia? Okay, we already know how to get area. We all know how to get first moment. In Simpson's rules, we have already used it in phase 1. And now we will try to pick up how to use Simpson's rules to calculate moment of inertia. Okay. I'll take a simple, because we have done the application of thrust only. So I'll just take similar question. Let us say I have this bulkhead. We measure these ordinates at equispaced intervals, whatever the number be, don't worry. And let us say the liquid level is in the sounding pipe. This is the liquid level. If I have to now, how do I figure out which is the reference axis? Pay attention to what I'm saying. If I have to find COPLL, then I need moment of inertia about which axis, beta?
LL,
So LL becomes my reference axis. Is that understood? What do we mean by reference axis?
Yes, sir.
Now I see what is the orientation of my ordinates with respect to my reference axis. And in this case, I'm sure all of you would agree it's a case of horizontal ordinates, right, guys?
Yes, sir.
Agreed? Why? Because the reference axis is parallel, and you can see the breadths of the bulkhead are given. They are parallel to the liquid level, and therefore my coordinates are parallel to the reference axis. Therefore, it's a case of horizontal ordinate. Does everybody agree?
Yes, yes.
Yes.
Okay, fantastic. Now, how we have been solving for area and moment? What is the base behind Simpson's rules? I'm not going to derive Simpson's rules today, but I'll just take you. In schools, when we had to find such areas and which led to Simpson's rules derivation also, in such cases, what we used to do in the school, we used to take an elemental strip. What we used to take? Elemental strip. What did we mean by elemental strip? That a strip with very negligible thickness, which is dx. Okay, and let us say the breadth of it is y. Y is the ordinate here. Then in schools we learned what was the idea behind taking elemental strip. The idea behind elemental strip was that this thickness is reduced to such levels that in this thickness this curve became insignificant and the elemental strip became a rectangle. Yes or no, beta? That was the whole idea of the elemental strip, that the thickness is so less that the curvature is insignificant and the elemental strip has practically turned into a rectangle, right? Correct, guys? So if it turns into a rectangle, the area of the elemental strip, I'm sure you will know, it is y dx. Why? Because rectangle. Y length into breadth. One ordinate is y, the other is dx. Fantastic. And how did we get the area of the full bulkhead in schools? We got it by integrating the area of the elemental strip. In ship stability, how do we achieve this integration? We achieve this integration through Simpson's rules. Correct? And how do we make the table for area in Simpson's rules? We make the table like this. First we write the ordinate, then we write Simpson's multiplier, and then we have product of area, then we get SOP area, and from SOP area, all of you know how to calculate the area through the last step. Yes or no, guys? Anybody has any doubts about getting the area with Simpson's rules?
No, sir.
No, very good. So now, if I try to correlate my table, only I'm trying to correlate, there is no direct relationship, huh? Then what can I say? Okay, I was trying, this integration is achieved through Simpson's process. So what was I multiplying? Y and dx. In this case, my ordinate is y. So can I equate Simpson's multiply? Equate only, they are not same. Can I equate Simpson's multiplier to dx so that this third column became y into dx, and then it went through the process of the final step and the integration process was achieved. Is that okay, guys?
Yes, sir.
Yes.
So just repeat this one, please.
No, I'm just trying. I'm just trying to correlate this tabular form with this formula. That's all I'm trying to do. Trying to correlate for easy remembrance. There is no scientific value to it. Okay, it's only for easy memory, right? Ease of remembering. Correct, beta. So what is Simpson's rules? That's a process of it to integrate. So integration is achieved through Simpson's rules. So in this table, my ordinate is y. We all have been taking ordinates as y. Then can I say dx is my Simpson's multiplier just for the sake of striking a correlation, right? Correlation, right? Is that clear now?
Yes.
Now I'll change to green marker and then I'll change to blue. Now we come to the moment. Why we need the moment? Because we need the distance of the geometric center. Guys, those of you who have done classes with me, whether in physical form or online, would all know. And for the benefit of others, can somebody repeat, what do we mean by liver of an ordinate? Liver of the ordinate means the distance of the geometric center of that particular area or the ordinate from the reference axis. Correct, guys?
Yes, yes, sir.
Okay, dx is negligible, so it will be basically here will be the geometric center of this elemental strip, and let us say this liver from the reference axis is x. Okay. Now, what will be the first moment when I'm writing M? I'm writing first moment, guys. The first moment of the elemental state. What is the moment of any area? If you remember in phase 1, you were doing A1 into D1. A1 was the area, D1 was the distance of its geometric center from the reference axis. So the moment of the elemental state, about which axis? In this case, it is about liquid level. So let me write the axis also. This will be right. Clear, guys?
Understood, sir.
Okay. Take what is the time before I bombard? Okay. 10 take 4 minutes break because the horizontal is sunken, and 10:45 we start with the vertical COP, and maybe the liquid level is somewhere here. Then I'm sure first thing is you'll agree that A, the reference axis is liquid level, because if you need COP, then for COP, the reference axis is liquid level. Correct? All of you agree with me? Yes or no?
Yes, sir.
Okay. Secondly, if you see these ordinates, then you also agree with me that this is the case of vertical ordinates. Yes or no?
Yes, sir.
Because reference axis is LL, and the ordinates happen to be perpendicular to it. So it's a case of vertical ordinates, right? Now,
बूझ जाओ बेटा
in case of vertical ordinate, we do not always, depending on suitability,
पापा का बेटा नहीं है
do not always work about the reference
है
axis unless it suits us.
पापा का बेटा नहीं है ना
What do I mean?
नहीं है ना पापा का बेटा
That in this
बाबा के
case,
पास जाके कर ले
if
प्लीज
I
बोल रहा हूँ
take
प्लीज
an elemental strip
प्लीज
here,
प्लीज
let's
प्लीज
say this is the elemental strip I take, the ordinate is Y and the thickness is dx. What you need to do in rough is identify whether it is a case of horizontal ordinate or it's a case of vertical ordinates. That is the first thing you'll do. Then, in rough, if it is horizontal ordinates, write these three formulae. Area is equal to integration of y dx. Moment is integration of yx dx. And inertia is integration of yx square dx. Why you write this is because this will guide you in the formation of the table, in structuring your table. If it is vertical ordinate, please in the rough write the formula. Area is equal to y dx. No change out here. Moment will be equal to 1 by 2 y square dx. And inertia will be equal. I'm not writing the x's intentionally. That you'll automatically recall. This is only in rough you're trying to recall yourself so that you don't make a mistake. Now, can you see the formula for both? They are totally different, guys. Yes or no? In this case, in this case, one second. In this case, axis is of your choice. Levers are from the axis of your choice that you have chosen. In this case, axis is one where all ordinates terminate. These are the C differences between the two approaches. Now ask me the question, guys.
No, sir, the same confusion was there. Okay, sir, clear now.
Clear, guys? If you want, you can take the screenshot of this screen and refer to it initially, and then make sure you, and if you want to follow my practice, I still at this stage also write down in rough the formula before I make the table. That will hedge the risk of making mistakes. Is that clear? And then what will happen is you will not miss out half, you will not miss out 1 by 3. These will be these are the distinct advantages of writing it once and capturing it again. Can I go to the questions then, if everybody's taken down whatever is to be taken down from here?
So can you show the previous slide one, where you are working the derivation? Can you just one?
Yeah,
yes, sir, just 1 minute.
Sure.
Okay, thanks.
Okay. I'm more interested in this one. If anybody has any questions, otherwise take a screenshot, copy it down, whatever you want to do, and make sure you are able to recall this. This is the key slide now. Rest of the things were just to satisfy your curiosity as to why this has changed with horizontal and vertical ordinate. It was only to give you the comfort that yes, there is a reason why it's happening, but now this is what you'll be actually using. That's all. Okay, guys, I'm closing this one then. Okay, I'm discarding everything. Okay. Now we go to some quick questions on COP of curvilinear shapes. And it's a MMD July 22 question. Can you please read the question and make the diagram? Don't worry about the solution. Make the diagram. And you see, I'm prompting you with the steps down below. See what has come? Make the diagram. Please make the diagram. Read the question. I don't want to say anything. You'll find these questions much simpler, of course, because you're used to Simpson's rules already. Anybody who's still drawing the diagram or done?
Still drawing, sir.
Okay, draw. Let me know once done.
Okay, sir. Done.
Please mark the reference axis based on the question based on the requirement of the question. Identify the reference axis and mark it, whatever notation you want to mark it with. Now it's a COP question, so which will be the reference axis, guys, for COP? And thrust, pressure. The reference axis is liquid level, right? Very good. So now let me make the diagram also. 1, 2, 3, 4, 5. Okay, this is extra. Let me just cancel it. My mistake, I messed it up. These 2 points I come. Okay, 8, 7.5, 6.8. And then you can see what all you missed out. What all have you not loaded on your diagram? Guys, how much will be the common interval in this? Can you tell me what is common interval?
2.5.
Very good. Is 2.5 meters. Is this all that you have marked? Yes or no? Up to identifying the reference axis?
Yes, sir.
Very good. Very good. Then identify whether it's a case of horizontal ordinate or vertical ordinate. Which one is it?
Horizontal.
Horizontal. Everybody agrees in the class? Fantastic. Now,
Yes, sir.
yeah, very good. So then in the rough, write down the 3 formulae for horizontal ordinate. I'll not write you right now.
Sir, I'm unable to recall this H. Can you please tell just a minute?
What is H in Simpson's rules?
Sir, distance between these ordinates.
How do you get that? Read the question.
Okay, sir. Okay, sir.
Everything is there in the question itself, but don't worry.
Yeah.
There are 4 common intervals. N is the height, 10 divided by 4, right? Yes or no?
Yes, sir. I was taking this 8 meter. That's why I was getting confused. 8 plus 3, I was counting there.
Okay, fine. Okay. Have you written the formula, guys?
Yes, sir.
Yes, sir.
Okay. Based on these formulae, I'm sure you'll agree that recall the formulae. Next point you see, I've put down these pointers for you. And now make the table and apply Simpson's rules. That's all. I'm sure you'll agree this is the structure of the Simpson. You'll write the ordinates first, then you'll have the Simpsons. Look at the formulae. Are the formulae guiding you to this table and reference X is LL we can directly use? Yes or no? Correct?
Yes, sir.
Yes or no, guys? Okay. Those who have done phase 1 recently with me, which is the preferred order in which looking at the diagram, which is the preferred order in which the ordinate should be written? Preferred order, not that it is the only order, but preferred order from first to closer to the reference axis, right?
0, yes.
Correct? Yeah, so please write down the ordinates. Which rule will apply for 5 ordinates? Rule 1, yes or no?
Yes, sir.
Guys, what will be the lever? Okay, write down the ordinates. Right, like this, correct? Ordinates will be in this order. You have done, guys? Any questions? Then write down the Simpson's multipliers. Correct? You can match them on the screen then. If anybody is out of touch or something. Correct, guys?
Yes, sir.
Then fill up the lever first. Look at the diagram. What will be the lever for 8 meters? 1 meter. What will be the lever for 7.5 meters?
3.5.
3.5. So please fill up the levers. I'm sure you'll agree these are the levers, right? Anybody who's struggling for levers, let me know.
Sir, will you please explain that lever part, sir? I'm not getting only the lever part.
What is lever? We used in the derivation also, no? The lever beta. What was the lever? If I'm asking a question, you need to speak back. You just can't throw a question, keep quiet, and go into silence. In the diagram, I had used the word lever. What did you understand about lever then? Guys, I'll go crazy if I have to repeat the same question 10 times. You asked a question and now you're not responding.
It's the distance of the ordinate from the liquid level or the
I did not say the distance of the ordinate. Please correct yourself. I said distance of the GC of the ordinate from reference axis. Correct?
Yes, sir.
Reference from the liquid level.
Yeah, so what is the distance of, where is the person who was asking? Are you the one who asked me the question or it's somebody different?
So this is the different guy, sir.
Yes, but where is that guy who asked the doubt? Yeah, he's disappeared.
अरे बोलो यार कौन पूछ रहा है डाउट तो क्लियर करो अपने.
Anyway, maybe it's clear now. He's already settled. Leave it then. Okay, then you have another column for lever. Repeat the levers there. This is the best way to complete. Now pick up the calculator. get all these values and get the SOPs. Please complete the table and get the SOPs.
Sir, table is completed. Calculating
Okay,
SOP.
Yeah, get the SOPs. Okay, very good. Complete all the missing cells. You just have to keep multiplying and keep filling up the values.
Sir, SOP area will.
I must have just copied it. Yes, I'll correct it right away. You're correct. You're correct. But I must have copied from the previous cell and then must have forgotten to change it. And you may find the same mistake in the other slides also. Then. Sorry for that. Is that correct, guys, now? This gives you idea how to present your answer. You see, this gives you also clarity how to write, how to express yourself in your answer, right? You don't have to write these steps. They were only for guidance. No, this is not to be written on. Don't do this. Okay, please calculate the area. Now I don't have the calculation. I only have the answers. Answers are here. Now calculate the area. Area 1 by 3. The coefficient for rule 1 into 2.5, the common interval, into 79.3, the SOP area,
56.08.
56.08. I'm just writing 66.
66.08.
Okay, 66.08 square.
Slide, I think what you are writing is not visible.
Is it so with everybody? Whatever
Visible, sir. Visible.
Visible. Yeah. Okay. Fine. Do you want to sign out and reconnect? Let me know when you're back.
Yes, sir.
Let me know when you're back. Please do that fast.
Yes, sir. Now visible.
Okay, fine. So area is done. Beta, for thrust, what do we need? We need DLL. Yes or no? For thrust, you'll need, for pressure, you'll need DLL. Yes or no, guys?
Yes, sir.
So I'm sure you'll agree DLL will be equal to moment about liquid level upon area. Yes or no from phase 1? Correct, guys? Because the moment is about liquid level, so distance will also come from liquid level directly. Yes or no?
Yes, sir.
So what will this be equal to? 1 by 3 into 2.5 into 441.3 divided by area 1 by 3 into 2.5 into 79.3. 1 by 3 and 2.5 get cancelled out. How many meters?
5.565, sir. 5.565.
5.565 meters. Any questions up to DLL, though it's a repeat of phase 1, but still if there are any questions, right? Okay. Therefore, now the thrust will be equal to, you already know the formula for thrust. Please calculate the thrust. Pressure at the GC.
376.946.
Yeah, that is the answer here. That's matching. It's the pressure at the GC. Pressure at the GC will be DLL 5.565 into the density of the liquid, it is seawater, into the area 66.08. This comes 376.946 tons. Correct, guys? Thrust is done.
Right.
Very good. The COP question wants from the top of the bulkhead, but our formula will give you from liquid level only, as we did yesterday. There is going to be no change in that. Fortunately, my SOP inertia is about liquid level, so that's good. I put through the final step, coefficient for rule 1 multiplied by common interval.
Okay, sir.
Yeah, tell me.
No, sir. I got it. Thank you.
Okay. So SOP ILL will, so 1 by 3 the coefficient. Common interval 2.5. SOP inertia is about liquid level, so that makes our job easier. Into this is 30585.8 divided by area you have already calculated, also divided by DLL, which you already have. If you put all this here, hopefully, unless I have made any mistakes, this should be coming 6.99.
Yes.
Correct, sir. 6.992.
Yeah, but the question wants from bulkhead top. So COP from bulkhead top will be equal to 6.992 minus the head of 1 meter, which becomes 5.99 meters. Simple, guys.
सर ये डायरेक्ट इससे नहीं निकाल सकते क्या सर, ये POI से POI sum of POI divided by sum of POM?
I don't want to comment on it. It's your choice. I never cut short, beta, because I don't cut short. You want to pick up wrong practices somewhere, it will let you down, especially if you're using rule 3 somewhere, Simpson's rule 3, then the coefficient of the numerator and denominator would be different. So I don't cut short. You want to cut short and do it, it's okay up to you. Well, as long as you don't falter, right?
Understood, sir.
Because in rule 3 for first moment, you use 310 minus 1 rule, and for which the coefficient is different from rule 3. There can be concerns. So there can be concerns. Okay, so be wary of all that. If you are on top of things, you can do whatever you want to do here, right?
Yes, sir.
But if you don't want to take a chance, then don't take a chance. You are cancelling out there. No, what is the problem? It's eventually boiling down to that only. No.
Understood, sir. Understood.
Okay. Guys, any questions on this one? Simple, much simpler than the regular geometric shapes, yes or no? Again, a question which has repeated twice, February 19 and November 22. Please make the diagram. Read the question carefully. Don't worry about these vertical ordinates. He could have given height also. Just make the diagram. Now, in this case, fortunately, it is giving me about liquid level. Why? Because ordinates are terminating at the liquid level. So I can directly use liquid level here, yes or no?
Yes, sir.
Correct, guys? Right?
Yes, sir.
So now, we fill in the ordinates.
Yes, sir, but it is a little bit above than just we will do the
Alright, let's not bring anything here, right? Let's just remain confined to the question. Okay, don't bring in anything more here. As long as this question is understood, let's do that first. So write down the ordinates. Ordinates will be repeated here, and here. Correct? You can write whichever way you want. Doesn't make a difference, because in this case there is no lever involved, right? Secondly, tell me which rule is applicable for 7 ordinates.
Rule 2, sir. 1, 2, 3, 2.
Okay. It's your choice. My calculation, I'll give you answer by both the rules. So answer will be there by both the rules. But if you want to match the calculations, then I will only show for rule 1. Okay. So if you want to do by rule 1, you can go by rule 1. If you want to do by rule 2, you can go by rule 2. Answers will be obviously different, right? So I'll give you answers by both the rules. That's not an issue. I can help you check also if there's a mistake. but on the screen I'll show you only by rule 1. And Simpson's multipliers and everything, then multiply them and see if these are the values that are coming. I'll put the SOPs also, but see whatever I put down. Don't put SOP. Don't use the word SOP first. Use the word symbols of summation. Sum. You just sum it up here. Don't write SOPs here. There's a reason why I've told you. So I've just summed up the columns. And once everybody is done up to this stage, let me know. In the previous question, horizontal ordinates, we straight away used SOP word here. SOP moment, SOP inertia, right? In this vertical ordinate, I have used the only summation. That means it's the sum of the column. Why have I not? Can you mute yourself, beta? Thoda background aa raha hai tumhara. Haan. Why I have not called it as SOP is because if you see the moment formula, formula for moment was 1 by 2 integration of y squared dx. Now this sum of 42615, this sum is for y square dx. Half has not been accounted for. It is after accounting for half that it will become SOP moment. Okay, so you see I have added one more row. This gives absolute clarity of presentation. SOP area, there is no change because SOP area, there is nothing that you left out, right? SOP moment about liquid level has become half of this. So this 213.073 is half of that sum. And SOP inertia is 1/3 of this. Have you understood, guys, everybody?
Yes, sir.
Yes, sir. Yes, sir.
We have accounted for the half here and one. So this is 1 by 2 accounted for here and 1 by 3 accounted for here. That is why I changed my presentation in such a way that I don't miss out anything. And anybody who looks at my working also knows what you have done exactly. Guys, any question on this now? So the SOP moment will be 213.073. SOP inertia will be 750.761. Am I clear about this part? There should not be any ambiguity about here.
Yes, sir. Yes, sir.
Done, guys?
Done, sir. Done.
Done.
Yes,
Okay.
sir.
Okay, very good. Now we can get area by rule 1. I am doing by rule 1, rule 2, and people can continue on their own track, no issues. Rule 1 is 1 by 3. Common interval is 1, and SOP is 83.3. This gives you so many square.
27.76.
Okay, 27 point. Let me see. I also have the solution somewhere. Area comes to 27.767, right?
Yes, sir.
Okay. Then, yeah. Calculate DLL. Let me not give you anything. Calculate DLL.
2.558.
2.558.
Very good. 2.558. Anybody who's struggling to get DLL, please let me know. I will not write the steps now.
So thrust.
And then the thrust. Okay, yeah. Please calculate
69.
the thrust.
69.5.
You can match both the answers. Both rule 1. Yeah, 69.607 by rule 1 and 69.635 by rule 2. Correct?
Yes, sir. 605. I am getting 69.605.
Okay, fine. And 69.635 by rule 2. Those who are doing by rule 2, your thrust will be 69.635. Right, guys? Okay. The formula will give you COPLL. So first get me COPLL, guys. Okay.
3.523.
COPLL is equal to 3.523. You're absolutely right. For by rule 1. Please see if anybody is having any problems, let me know. It is so crystal clear in this, I don't think there will be too many doubts, but if still there is a gap somewhere, please let me know. He wants
2.477.
yeah, he wants from base. So from base would be sounding minus COPLL, and that will be 2.477 meter by rule 1 and 2.473 by rule 2. Please match your answers, and if anybody has any concerns, I'll wait for a minute or so to hear from you about your doubts. I'm sure these two questions would have given you enough confidence in handling the curvilinear shapes, right?
Yes, sir.
Remember those 4 steps. Make the diagram, identify the reference axis, sort out the issue between vertical and horizontal ordinate, make appropriate table, get going. You're unlikely to
what
make
is the
mistakes.
thrust? What is the answer?
It's on the display, but it's on the display beta by both the rules. Just see on your screen. Answer is on the display beta. 69.607 by rule 1.
Sir.
Yeah.
सर इन फॉर सेम क्वेश्चन सर, अगर इसका जो वाटर लेवल है सर,
अरे इसको छोड़ देना, उसको छोड़ देना, तू छोड़ दे उसको, तो यही तक रहे अभी, चिंता ना कर, तो ये सब जगह की सैर कराऊंगा.
So what's the sounding term? Like in the last COP base is equal to sounding minus COP.
Because the question is asking na COP from base, he's not asking from liquid level, bete. So
how much is the sounding coming? If anybody else can.
Sounding will be 6 meters, no? If the liquid level is in line with the top of the bulkhead, sounding is always of the deepest point in the tank.
Got it.
Sounding will be of the deepest point, right, beta? The base is at the deepest point, right? Okay. Never mind, keep asking your questions. Sometimes you may feel that it should not have been asked, but still don't hold your questions. Okay. Guys, if anybody is still solving, you can stop me, ask me to wait. Otherwise, I'm jumping to the next question.
So 1 minute, only 1 minute.
Okay. Once you complete, let me know. I'll wait for your confirmation. Because the idea is not about calculations, idea is about the concept. Please make the diagram to this question. Read the question carefully. It's not an MMD question. It's my own this thing, simple. Just to put to rest some of the doubts that people were asking. Sir, what do we do? Tell me now, make the diagram. I'll make the diagram later on and then you can match. Is the bulkhead shape correctly made, the guys, like this?
Yes, sir.
What will be the value of H?
2, sir.
8 by 4 equal to 2 meters. If it contains seawater to a sounding of 13 meters, means there will be a head of 2 meters now at the deepest point. Here is the liquid level. This head is 2 meters. This is the question everybody was trying to ask them. Am I right, guys?
Yes, sir.
Okay. Everybody convinced with the diagram? Please read the question. See if the diagram is in order. Okay. Now, is it a case of horizontal ordinates or vertical ordinates? What is the reference axis for COP and thrust?
LL, no?
LL. Yes. So is it a case of horizontal? Yeah, is it
Vertical.
very good. Vertical ordinates. Vertical ordinates. Now my question to you is, are all the listen to now, mute kar lo jara ek minute beta. Are all the ordinates terminating at the reference axis? Answer is no. Answer is no. The formulae that we have derived for vertical ordinates, y dx is area, moment is half y square dx, and inertia is 1/3 y cube dx, is about an axis where all the ordinates are terminating. When I look at this question,
Hello sir, I cannot listen to you.
Why? How do
I
you
cannot
speak?
listen to you. Something happened.
You cannot listen to everybody else can hear me?
Yes, sir, we can hear.
Yes.
Now,
Yes,
now,
sir.
how
We can hear.
now how do I respond to him when he can't hear me? Put it on chat.
Sir, I cannot listen to you, so I am signing out and joining again.
Okay. Let me know when you're back. Now there's no point in speaking. Okay. Let him come. The table will give me results from this x-axis. Do you understand now?
Yes, sir.
Have you understood? Has everybody understood? These three formulae will give me the results about x-axis. They will not give me about LL. In the previous question, fortunately, what MMD had done was the liquid level was brought to x-axis. So that's why it suited us, right? Correct, guys?
Yes.
Yes,
But
sir.
here,
Yes, sir.
yeah. So please be careful about it. So let's make the table for x-axis and get the values about x-axis. Never mind. I'm sure you'll agree that this is the structure. Okay, the axis I have used is BT. In my table, I have used BT, so I'll change it here as BT. Okay. So I'm sure you'll agree this will be the table. Now you see, now you understand what is the significance of putting these x's here. That means my results will be about BT. They will not be about liquid level. Do you agree, beta? Look at the table. Correct, guys?
Yes, sir.
Yes, sir. Yes, sir.
Understood. That's why I always insist upon indicating the axis so that you don't falter. Okay. Now the five ordinates, simple rule 1. So please make the table, repeat the ordinates, and see that you repeat these and do the summation. Come up to this and let me know. You can match up to this point and come to this value, these values. And if anybody has any doubts, you can ask me. Yeah, matching good, fantastic. Okay, then make the next row for SOPs. Make the next row for SOPs, beta.
Already made.
Very good. So let others also complete. Give a while then. Very good, fantastic. You remind yourself of the axis. You're absolutely clearly presenting. There is no ambiguity whatsoever. Okay. Please calculate. Yeah. Tell me.
So there is a friend of mine, Jaydat Kadam. He is disconnected and he.
Did you? Is this table complete for you, Kadam?
Yes, sir. Completed, sir.
Very good. These SOPs, you're okay with it? The last row, green one, this one, beta. You're okay with this?
Yes, sir.
Sure?
Yes, sir. Yes, sir.
Okay. Please calculate the area of the bulkhead, guys. And it is coming 57.333. Just check.
Yes, sir.
Yes.
Yes, sir.
Yeah. Okay. Fantastic. Now tell me, guys, from which axis will I get the distance of the geometric center now?
See, first we will calculate from BT, then we will add.
From which axis am I going to get? from BT I'll get XX or BT, right? Why? Because my moment, yeah. So dBT or dXX, whatever you want to write, depending on how you mark the axis, will be equal to moment about BT upon area. This will be equal to 1 by 3 into 2 meters into 333 divided by 1 by 3 into 2 into 86. This dBT comes to 3.872, correct guys?
Yes, sir. 3.872.
Okay, but we don't want from BT, we want from LL. Look at the diagram. If you add 2 meters to it, DLL would be equal to 3.872 plus 2 equal to 5.872 meters. Clear to everybody?
Yes, sir.
Once you have DLL, I am sure all of you can calculate the thrust, guys. I'll show you the thrust on the answer. Thrust is 345.067. Just calculate the thrust now. Okay, guys. If everybody is okay, can I continue with COP then?
Yes, sir.
Now see, my formula is COPLL is ILL upon A into DLL. A and DLL are already there on the screen. So now it's only ILL. The table will give me inertia about which axis. Look at the table. It's going to give me inertia about which axis?
BT.
BT. Now, based on it is 5 meters below. This is 3 meters. Somewhere here is the geometric center of it, and this is the axis through the geometric center, and this is the distance DLL that you have just obtained as 5.872. Right, guys? Correct, beta? Look at the diagram. I marked DLL in the diagram. Correct?
Yes, sir.
Correct. Okay. Now, I am going to get inertia about BT. I don't need about BT. I need about LL. Now, before you make mistakes, I don't like people making mistakes and then realizing it. Guys, if you recall the concept of theorem of parallel axis, somebody in the last class also towards the end of the class was raising that issue. Now, from BT, I cannot go directly here because theorem of parallel axis, one of the axes must pass through the geometric center. Yes or no? Correct, beta? So that means first I'll have to bring the moment of inertia from BT to GG, and from GG it will go to LL. Is that clear, beta?
Yes, sir.
Yes.
Okay.
Yes,
Just
sir.
for the sake of revision, if I have to write, okay, distance between GG and LL is DLL, and what have we called the distance between BT and GG? DBT. Correct, beta? Correct. Which is 3.872. Correct, beta?
Yes.
Correct. Now, can you tell me? Please tell me, how do I write the theorem of parallel axis between BT and GG? How do we write the theorem of parallel axis between these two axes? What is it?
So IBT is equal
IGG plus
to
A into
IGG.
IBT is equal to IGG plus area DBT square. DBT square.
DBT whole square.
DBT square. Let's talk in the notational form, right? Is that clear?
Yes, sir.
Does everybody agree this is the theorem of parallel axis between BT
Yes, sir.
and GG, right?
Yes,
In
sir.
this case, the table is going to give me this it will give me IBT, right? So from here, if I need to get IGG, what will this be equal to? IGG will be equal to, pay attention here, it is IBT minus A into DBT square. Correct, beta? Please pay attention to this minus that has quietly come in here instead of plus now. Yes or no?
Yes, sir.
Yes.
Okay. Why? Because moment of inertia is always amongst different parallel axes. It is the least, it is the minimum about the axis that passes through the geometric center. So when it is between GG and BT, if you are calculating about BT from GG, then you will add something. But from BT, if you have to get about GG, then you will subtract something. Is that clear, beta? That's how you can remember. Is that clear?
Okay, sir.
Yes.
Right. Likewise, can you help me in writing the theorem of parallel axis between LL and GG?
Sir, ILL is equal to IGG plus A into DLL का whole square.
Plus A into DLL square. Does everybody agree with him what he said? A into DLL. I correct? Correct, beta?
Yes, sir.
Yes, sir.
And what is IGG? This IGG I put here. So this will become what? IBT minus area into DBT square. This is my IGG, guys. Correct? What I have written in green is IGG. For the remaining, I'll change to blue so that there is clear distinction. You don't get confused again. Guys, this is what I have written here, where I'm putting the inverted commas. This is IGG. Do you agree with me from here?
Yes, sir.
Correct? Plus this area into DLL square. Correct, beta?
Yes, sir.
Divided by area into DLL will give me COPLL. Yes or no? Please look at this. IBT minus A into DBT square plus A into DLL square. This is theorem of parallel axis to be applied between LL and GG and GG and BT. Yes or no? What am I doing basically? What am I doing? Table will give me IBT. I am first converting it to IGG, and from IGG I am converting to ILL. Yes or no, beta? That's what I'm doing. Understood?
Yes, sir.
Any questions on what I have done until now, beta? So now you have the answers. What is IBT? IBT SOP is here 1844 thing. So it will be equal to rule 1/3, common interval 2, and SOP inertia about bulk at top is 1844.667 minus area you already have 57.333, DBT square 3.872 square plus area 57.333 into 5.872 square DL square, whole thing divided by area 57.333 and DLL 5.872. This should give you, now I'm doing in this box here, this should give you COPLL of 6.972. Just check, please. 6.97. Now, if anybody has any questions on COPLL, all your doubts which you are trying to raise in the previous question, are they put to rest now through this, beta?
So 6.928 are.
But that's okay. That must be a calculation rounding off. So 927, 928 is fine.
So till how much?
Not 928, 979,
6.972.
You check your calculation. You must have made 97. You must have made a mistake somewhere. It's a calculation related issue. As long as conceptually you are okay.
6.972, sir.
Okay. Guys, anybody who has problem in understanding this, I can clear the screen all over and I can again talk about it if the need be. Tell me. It's all understood?
Yes, sir.
And the question wants from base. So 13 minus this. Correct? So answer is there on the screen. 6.028 meters is the answer from the base. Sounding minus COPLL will give you the COP from base, right? That is a repeat of previous working.
Yes, sir. Done.
Okay. Guys, if anybody is still solving, please stop me. I'll wait.
Still solving, sir.
Please let me know once you're done. And make sure everybody is comfortable with this transfer of inertia from BT to GG by subtracting ABT square and then taking it to LL by adding A into DLL square. So be careful when you're coming from BT to GG, it will be minus. So don't make that mistake in a hurry. That's the common mistake people end up making. On the bulkhead at the position of the center of pressure when the ballast of RD 1.010 stands to one side of it. Yeah, so the tank is full of it. Basically, it's bulkhead of a tank, right? To its full depth. That means water line is in line with AD, top of the bulkhead. So it's a bulkhead of this shape with water line being here. Now, after that also, if you have any doubt, let me know. I can then elaborate more. This is the shape of the bulkhead. Okay, beta. And here is the water line. That is what I can make out of this question. Liquid level is here. Was that the concern?
Yes, sir.
Is that okay? First part of it?
Yes, sir. Yes, the first part is okay, sir.
Okay. So what is the total area that is? Yeah, okay. What is the total area that is coming, beta?
Sir.
Okay, whatever.
So we can do it by trapezium. 2 plus half into both the bases plus.
Yeah, but then you will not have the geometric center of it. No? You'll have to apply the theorem of parallel axis also, not center of pressure. First you can get, right? But you'll need the geometric center also. So you'll have more problems. It's better either you divide into
Divide by 3 parts. Yes, sir.
Yeah, so either you do in 3 parts or you can divide in 2 triangles. So the choice is yours. You can divide like this. Okay. Now second part, look from the side. Look from here. Here is the horizontal. This is the bulkhead now. Now I'm looking at the bulkhead from side, right?
Yes, sir.
Okay. Like you are seeing a transverse bulkhead in the side elevation of a vessel, right? Understood?
Yes,
okay. Now this was the bulkhead which is immersed, which is trapezium in shape, whatever the shape, you know. Now this bulkhead is inclined at 30 degrees to the vertical. Okay. In the next case, let me change to the blue. So this red one is the first case of the question. Okay. The second case of the question is this bulkhead is now inclined at this angle. That means it's making an angle 30 degrees with the vertical or 60 degrees with the horizontal, correct?
Yes, sir. 30 degree to the vertical.
Yeah, or 60 degrees to the horizontal. It's one and the same thing. No?
Same. Yes, sir.
Okay. Now this area of red one and blue one is same, correct, beta? Correct? Yes or no?
Yes, sir.
It's the same bulkhead which has been inclined, right?
Same bulkhead, yes.
Yeah. So basically the geometric center of this red one and geometric center of the blue one will be, as far as the area is concerned, they will be at the same place. But what will happen is, because of this inclination, this height will change now. The height of the GC will change, right?
Yes, sir.
So height of the GC in this case will become, you have this triangle which you have made now, where you have this bulkhead is like this, and so here is the horizontal. Sorry. Here is the liquid level. Okay. The bulkhead is like this. This is the bulkhead. This angle is 60 degrees. Here is the geometric center of the bulkhead. Okay. So what is the depth of the geometric center? This is the depth of the geometric center from, this is DLL now. Correct, beta?
Yes, sir.
Yes or no? Correct?
Yes.
So it's a right angle triangle which is formed here. So between this DLL And what do you know? You know this distance of the geometric center from the top of the bulkhead. You already know in the first part, correct? This distance is this you already know, right? So basically, if I call this triangle as A, B, C, then beta, if I have to have perpendicular, then it's sine 60 degrees. Sine theta will be equal to perpendicular BG, which is DLL, okay, upon AG, correct? So this will give you BG, which is equal to DLL, which will be equal to AG, you already know, into sine theta. So the height will change, okay? So then the pressure at GC will change, and so would the thrust change, okay? Is that clear now?
Yes, sir, yes, clear.
Okay. Anything else, guys?
Yes, sir. I answered one question in another group. 26 March.
One second. Is this question clear to everybody? Guys, this question part be clear to everybody? Okay, fine. Good. So I'll clear this. Okay, you have put some question, you're saying on 26th March. Double threads are given, so it's not an issue. It's from bottom they are given, so it is lower at the bottom end. Okay. How many of them? 1, 2, 3, 4, 5. So 3, 4, and 5. They are 5.7, 5.1, 4.2, 2.9. Sorry, we can double it up. Sorry, my mistake. 11.4, 10.2, 8.4, 5.8, and 2 meters. Correct, beta? Because these are half waves which are given, right? Correct?
Okay, sir.
The common interval is 2.5 meters. So 1, 2, 3, 4, 10 meters is the height of the bulkhead. Sounding is 11.5. So water is in the sounding pipe. Here is the liquid level. This distance is 1.5 meters. Correct, guys? This is the diagram.
Okay, sir. Now I can solve. I have made it the vertical. Like question is saying 2.5 meter vertical interval.
Yeah, it's not the vertical ordinate. It's the breadth. Breadth is going to be horizontal. It will be parallel to the water line.
Yes, sir.
Okay. Is this clear? What mistake he was making? See, when somebody is asking doubts, please be open to receiving those, because tomorrow you may also have the similar doubts in those questions. If you don't have, then that's good. But if you have, please let me know. So can I close this also? Unless somebody has a doubt on this, these two questions.
Sir, one more doubt in the same question. Like in this particular question. Sir, can you hear me, sir?
Yeah, I can hear you. Which question? Are you talking about this bulkhead that has been made?
Yes, sir.
Yeah. What is the doubt?
In this case, the sounding is 11.5 meters. Okay, I can solve this. But if the sounding is in between,
I will not go by ifs and buts. You please bring the question. Please bring a question. Then I'll not answer these hypothetical ideas which come to our activated mind now. Leave them aside. You do the questions. If you are able to do the questions, don't worry about anything else. Okay, but how can he give you something? If you are saying if he gives a water line here, how will he give you a water line here? Then the 10 Simpson's rules will be applied if the intervals are not same.
Yes, sir, that was better.
Simpson's rules will apply होना चाहिए ना बेटा. Stick to basics, right? Okay. Anything else, guys? Any more doubts? Yeah, tell me what is the doubt. Somebody had started with the doubt, and I think I made out. He was talking about the question I gave. Somebody was asking some doubt out there. Am I right? If there is any doubt, please speak up, because then we'll go on to the topic of today. If anybody has more doubts on
Excuse me, sir.
You need to know this word umpteen number of times in phase 1 Simpson's rule also. Guys, are you okay with the word Just imagine cutting the ship at the waterline, removing the top part, and now imagine having a bird's eye view. At the waterline, you will see seawater all around. But in between, some part you will not have the seawater. Why? Because the hull of the ship will keep the seawater away from that portion. This portion from where the seawater has been kept away by the ship at the waterline, this area, or this is called, this area at the waterline where the seawater has been kept away from is not visible because of the hull of the vessel. This area is called as the water plane area. Is that now, any doubts if you had, is that now better placed? Correct, guys?
So did you show any diagram or any?
Must know what is center of flotation. Again, this word you have been using it day in and day out. I don't want to ask you. This is the geometric center of ship's water plane area. I'm sure that also all of you know. Correct, guys?
Yes, sir.
Okay. So you know the water plane area. You know what is center of flotation, COF. Okay. Because we basically coming in the way of our progress. I'm sure all of you can recall how LCF was calculated for curvilinear shapes and regular geometric shapes in phase 1. You used to take the moment about after perpendicular and divide by the area, correct? This LCF or AF was calculated by how? You used to take the moment of what? Moment of water plane area. About which axis? Usually about after perpendicular. And this moment you used to divide about the water plane area, and that used to give you LCF, whether you call LCF or you call AF, whatever you may call. Correct, guys? This is, all of you are familiar with this working?
Yes, sir, correct.
When there were multiple areas, it used to be A1 into D1 plus A2 into D2 plus upon A1 plus A2. Yes or no?
Yes, sir.
Yes, sir. Correct. So we'll again be using this concept, which I just want you to be able to recall rather than struggling there. Now, next is, why do we need to calculate BML and BMT? Now, in phase 1 also, I told some of you to mug up one formula towards the end of the course where I said for a box-shaped vessel, this is so much, and for a triangular barge, it is so much. But why do we need to calculate this? Because in our hydrostatic particulars, we are given KML and KMT. And when you subtract kg from that, you get GMT and GML. Okay. Now, how do we get these KML and KMT? They are tabulated, they are fine, fantastic. But how do you get them? Now, if I take any of the KM, whether it is KMT, then it is equal to KB plus BMT. If I have to calculate KML, sorry, I wrote T for both, KML, then it will be KB plus BML. Now this KB thing, you have already learned how to calculate using Simpson's rules in phase 1. Phase 1, you already have calculated KB by Simpson's rules or regular geometric shapes. Correct, guys? All of you have calculated KB, right? For a triangular vessel, for a box-shaped vessel, you did in pre-C, second mates, and for curvilinear shapes, you did in Simpson's phase 1. So I'm sure all of you would agree that we have learned how to calculate KB earlier, right? Yes or no?
Yes, sir.
And now is the time to learn the second component, and that is why the need. Why we need to learn them? Because KM and KML and KMT have a lot of importance in our ship stability, which you know, and therefore we should know how the constituents or the components of KM are calculated. KB we know, and we now learn the second component of it, whether it is BMT or BML. So that is the need why we need to calculate them. Any questions until this point, guys? Now, please take down these formulae. Now, BMT, or let me clear this part and do one explain here only. Okay. BMT. How do we, what is the formula for BMT, beta? Irrespective of the shape, whether it is ship shape, it's a box shape, it's whatever shape. It is moment of inertia upon V. Now, when inertia, you should straight away object that, sir, you told us moment of inertia is absurd in the absence of whose moment of inertia about which axis. Okay. And what is V? Now, this moment of inertia is the moment of inertia of the ship's water plane at the draft at which the ship is floating. Okay. Now I have answered one part. Whose moment of inertia? The water plane area. About which axis? Now this is about, it's better if you're talking of BM transverse, the transverse stability when the ship rolls. The transverse stability when she rolls sideways, does she roll about a fore and aft axis or does she roll about a transverse axis? When a ship rolls, fore and aft. Transverse axis. She rolls about transverse axis. She rolls about a transverse axis.
No, sir, fore and aft.
Tell me. No. So there are some people who are. I need everybody. Moment of inertia of the water plane about fore and aft axis through the geometric center of the water plane, and we don't have to write such a lengthy phrase. We know the geometric center of the water plane is called as the center of flotation. Through the center of flotation. Why? Because that is the geometric center of the water plane. So BMT is moment of inertia of the water plane about a fore and aft axis. Why fore and aft? Because transverse stability is about fore and aft axis. So this way you can remember it. If you have a doubt, was it a thwartship axis? Was it fore and aft? You figure out, sir had told us the transverse stability is about a fore and aft axis. So BMT is equal to moment of inertia of water plane area about a fore and aft axis through its center of flotation. Okay. What is V? This V is volume of displacement. Technically. Okay. What is volume of displacement? How do you calculate the displacement of the ship? You multiply the weight of the water displaced by the, you calculate the weight of the water displaced by the ship. So that volume of the water displaced is the volume of displacement of the vessel. This is same as volume of buoyancy. Volume of buoyancy is same as volume of displacement. And as long as the ship is intact, there is no breach of hull. As long as the ship is intact, the V will also be same as the underwater volume. But technically the word is volume of displacement. When we go to bilging, you will realize that underwater volume and volume of displacement become different. Okay, so you be careful in using this word. Whatever be the volume of displacement, if it's equal to your underwater volume, use that. If it's not, then use whatever is the volume of displacement. Guys, any questions on that in this about this formula? If you have not understood anything, that if you will say, show us on an exercise, on a diagram. Let us say my water plane area is like this. Okay. Let us say I find my center of flotation to be here. And let's say this area calculated, this area is A. So through the center of flotation, I'll draw a fore and aft axis. Okay, this in this case is coinciding with the center line. If it is not, in case of Bill's cases, it may not. So never mind. Here it is fore and aft axis coincides with the center line. Otherwise, I can call it XX, YY, whatever I want to name. Here it is center line. So in this case, BMT will be equal to I of the water plane area about the center line divided by volume of displacement. Is the formula BML. And what is the formula for BML? Is equal to I Of what? Again, the water plane, obviously. But longitudinal stability, when the ship pitches, I'm sure you'll agree, or when the trim changes, it happens about a athwartship axis, yes or no? Correct, guys?
Yes, sir.
Yes or no?
Sir.
And
Yes,
trim is a measure of trim is a measure of longitudinal stability. So when longitudinal stability is involved, then it will be about a athwartship axis. So it is I of the water plane area, but in this case, it will be about athwartship axis. Through which point? Obviously, it's through the same point here, COF. Nothing changes, only this change. 4.5 gets replaced by athwartship, that's all. Divided by V, it remains the same volume of displacement. Correct, guys? This is the formula for BML. Okay, now going back to the diagram, if here is the center of flotation, then if I draw an athwartship axis through it, usually I represent by small f. So then BML formula with reference to my diagram will be I about FF of the water plane divided by volume of displacement. Please review both the formulae. See if you have understood or not. If you think you have missed out something or something is not clear to you, please feel free to ask. Because maximum problems are because people don't understand the formula. They start solving the questions. And people don't tell them what it is actually. So now I have told you that if you have a doubt about 4.5 or athwartship, you can figure it out by what I have shared with you, and you can just learn these formulae. So then we'll get going with the numericals pertaining to these two calculations, BMT and BML.
Sir, I have one doubt.
Yeah, tell me. I'm making the side elevation of it. So this is 40 meter, L is 40 meters, breadth is 10 meters, and it is floating in seawater at a draft of 3 meters. 3 meters, okay. Now, it's in seawater, okay. Guys, we want KMT and KML. We have just said, let's talk of KMT first. We just said KMT is equal to KB plus BMT. Yes or no?
Yes,
now, sir. And what is B? It is the geometric center of volume of buoyancy. In a box-shaped vessel which is intact, in this case, can you give me what KB would be equal to, beta?
1.5.
1.5. It will be half the draft, which is 1.5. Anybody has any doubts on this KB? Very good. Now, yeah. No doubts, no? Okay. Now, please visualize. Imagine the vessel. Now, let me change to some other color so that I can, before it is confusing. Imagine the vessel is cut here, where I'm drawing this light green line. And remove the top part. Can you tell me what will be the shape of the water plane, guys?
Rectangle.
What will be the shape? And what will be the dimensions? What will be the dimensions of that rectangle?
So 40 into 10.
Capital, the length L and breadth V. Yes or no? Correct, guys?
Yes, sir.
Correct. So now I'm making the water plane area, right? The water plane will be a rectangle whose length will be 40 meters and the breadth of the rectangle will be 10 meters. Does everybody agree?
Yes.
Yes or no? Okay. The day before yesterday lecture, where is the geometric center of a rectangle? Intersection of diagonals.
Right now it is
Intersection of diagonals.
intersection of the, yes, sir.
So that means this will be the geometric center of the water plane area. Yes or no? It will be
Yes, sir.
half the breadth along the, and at the same time L/2 distance along the length, right? What is the geometric center of the
Right,
water
sir.
plane area called? Center of flotation. So this is the center of flotation. Yes or no? Correct, guys?
Yes, sir.
Correct.
Yes, sir.
Yes, sir.
Okay. For BMT, what is the formula we just did? It is I of what? Water plane. About which axis? BMT. Which axis?
Fore and
Forward and
aft. Fore and aft.
Fore and aft. Okay. So let me draw through the center of flotation of fore and aft axis. Is it the center line of the vessel? Yes or no?
Yes, sir.
Yes, sir.
Yes. So instead of calling XX, YY, I can just call it a center line. So this becomes ICL upon V, ICL of the water plane. Have I written the formula correctly with reference to my diagram? Yes or no? Correct, guys?
Correct, sir.
Yes, sir.
Yes.
Okay. Tell me what will be the, in terms of LB, we don't have to worry about the values. Tell me what will be the moment of inertia of this water plane about CL. Look at the diagram. You already know it. I don't have to teach you that.
LB cube by 12. 14 into 10 into 10 into 10 upon 12.
LB cube by 12. LB cube by 12. Okay. And look
Yes,
at
sir.
the upper diagram. Tell me what will be the volume of displacement in terms of notations. Volume. I'm not talking of displacement. Volume or displacement.
14 to 10.
L into B. Let's keep it in notational form. No. L into B into D. Yes or no? Correct, guys?
Yes, sir.
Does everybody agree this is the volume of displacement?
Yes, sir.
1L gets cancelled. 1B knocks off 1B here. So this leaves the formula for a box-shaped vessel, which I asked you to mug up in phase 1, where I asked you to mug it up. But today we have come to that stage where we can derive it. Those who had done the classes with me, did I ask you to mug up this formula? Yes or no?
Yes, sir. Yes, sir.
Yes.
Correct. So now, you could have used 40 and 10. That's not an issue. Or I can substitute 10 here. So it is 10 square by 12 into 3. And that is your BMT. Can you calculate BMT and give me the answer?
$4.278.
4.278.
2.278.
4.27.
2.27.
2.27.
4.278.
4.27 km transfer, sir.
4.278. Okay, very good. So now you have KB and you have BM. So this will give you KMT.
Sir, 4.2.
Which will be equal to 1.5 plus.
KMT is 2.77. He's giving KMT
2.778. 2.7. Yeah, you guys can't even use the calculator. What do I tell you then? 2.778. So this will basically become 7, 8, 12.
2.78.
4.2. Okay. Don't be in a hurry to give KMT, no part of the question. Is that clear? That numerator, the denominator will be the same. L into B into D. B and B gets knocked off. 1L also gets knocked off. And that's why you did that for a box-shaped vessel. BML is equal to L square upon 12D. Do you remember now? In phase 1, you use this result, right? And this will be equal to 40 square upon 12D. And you give me only BML, don't give me KML directly. Please give me only BML.
44.4.
44.400, is it?
44.44.
Okay, 440. Okay. So this will give us KML, whatever it is that you can keep correcting. Add 1.5 to it, and that will give you the KML, right, guys? So answers are there on top: 4.278 and 45.944. KMT and KML. Same question, shape has changed. So let me make a triangular barge. You can also learn to make as we proceed further. Here is the triangular barge, which is 40 meter long, 9 meter high, and 12 meter wide. Okay. So 9 meter high, 12 meter wide at the deck. This is the barge. And this is 9 meters. That is the total height of the barge is 9 meters. And it displaces, so it will float at a certain draft, which is not given. So there will be some liquid line, water line will be somewhere here. And this will be the draft of the vessel, which is not given to us in the question. And the vessel is displacing 246 tons in RD 1.025. Correct, guys? Correct? Yes or no?
Yes, sir.
Does everybody agree with the diagram and the question? Or any doubts on that? Okay. Now, in this case, what will be the relationship between draft and KB? We have already done in our first lecture the day before yesterday. KB will be equal to what will be KB? 1 by 3D. Are you sure?
2 by 3 ground.
2 by 3 days, sir.
From bottom 2 by 3.
But in this case, 2 by 3.
अरे keel KB किधर से होता है? Bottom भाई KB is from keel always.
Yeah, 2 by 3.
So don't necessarily KB remains KB. It does not. You don't measure KB from deck, man. KB is from keel. Okay, so somewhere here will be the center of buoyancy, which will be 2 by 3, not d meter into d, right, beta? That means first thing is to calculate d. First thing is to calculate d. We'll use law of flotation to calculate d, which has nothing to do with this topic. It has got more to do with the use of what you already know. Okay. Now, in this case, obviously, we don't know this breadth also here. Let's call it as small b or x, whatever you want to call it. Now, by law of flotation, looking at these using capital B, using length L, using D, can you tell me, this is the capital D depth of the vessel. Now, using these notations which are on the diagram, can you tell me by law of flotation, what will be the displacement formula for it? What will be the displacement of the vessel, guys?
Sir, half into small b into small d.
Very good.
Into 1.025.
Into length also, beta. What you have calculated is only area.
Into length also, sir. So it will give the whole.
This is the cross. This is the cross-sectional area multiplied by length. So we know that half B into D is the underwater cross-sectional area. If I multiply by length, that becomes underwater volume. And if I multiply by 1.025, this will become the displacement of the ship. Yes or no, guys?
Yes, sir.
This is
Yes, sir.
very good. Now let's put the values. We know half. We do not know B. We do not know D. Okay, and we know length. For how many? For length is 40 meters. Okay, into 1.025 is equal to 246 tons. Am I right, guys? Okay.
Yes, sir.
Now, coming back to these two triangles, small triangle and bigger triangle, we have already used it earlier. By ratio, can we find a relationship between B and D, guys? It will be B upon what? Which is the corresponding side of the bigger triangle? Corresponding to small b, B by 12. Correct, guys?
12.
B by 12 equal to D by 9. D by 9. Yes or no? Correct, beta?
Correct, sir.
From here, we can get the value of maybe D or B, whatever you want to calculate. Doesn't make a difference. Both have to be calculated eventually. So D will be equal to 9 by 12B. Yes or no? Correct, beta? Right?
Yes,
Which
sir,
is
right.
equal to 0.75 B. Okay. This value of D we can use in this expression here. And what does this become? This implies half. Now instead of B, I can put 0.75 D into another D into 40 into 1.025. This is equal to 246. This has nothing to do with BML, BMT. This is normal law of rotation and your earlier learning. By doing this, can you calculate D and give me the answer?
TN4.
Anji, sorry?
Sir, we
I
have to
didn't get.
put B now, sir.
B 3 meters.
B 4 meters, D 3 meters.
Okay, no, okay. You put D. Okay. You put D instead of D. You put okay. My mistake. Now mine. Okay, you can put in. Okay, that's fine. You can put this as B. Okay, this is B and this is B. This will give you B. This will give you the value of B, right? Okay, fine. Okay, how much is B coming? Can you
B will be
calculate
4
B?
meters.
B is 4 meters. Okay, B is 4 meters. So if B is 4
B will be
meters.
3 meters.
D will be 0.75. So this implies D will be equal to 0.75 into 4, which is 3 meters. So draft is 3 meters. So this is the way we get the draft of the ship and we get the breadth at the water line. We get the water line. Any questions up to this point, guys? Told me that KB will be 2/3 of the draft. So KB will be 2/3. I'm writing with the top line. And draft is 3 meters. So KB will be 2 meters. Does everybody agree? Yes or no?
Yes,
KB
sir.
will be 2 meters?
Yes, sir.
Okay. Now everybody again imagine the vessel to be cut at the water line. Imagine having a bird's eye view and tell me what do you think will be the shape of the water line, guys? Water plane, sorry, not water line. What will be the shape? Rectangle.
Rectangle.
Anybody who feels it will not be, okay. Anybody who feels A, it will not be rectangle first.
Sir,
Everybody
can you just illustrate and show me that will fix in our mind then? Just one.
Now I'm making the water plane here. What are the dimensions of the
Maybe 40 into 4.
length and small b? Let's use notations, right? Small b and L, right, beta? Yeah.
14.
4 is the breadth. And, yeah, 40 is the length and 4 is the breadth. Correct, beta? Of the water plane. Yes or no? Does everybody agree? This is the shape of the water plane.
Yes, sir.
Breadth is 4 meters. Length is 40 meters, right? Okay. Very good. So now, where will be the center of flotation? I'm sure center of flotation would be here. Yes or no?
Yes, sir.
If center of flotation is here, draw. Now I'm telling you, draw the 4.5 axis through it. Please draw. If I want to name it, can I name it center line? Yes. Now write down the formula for BMT. It will be I CL of the water plane upon V. Look at the water plane diagram. Use the notations. Don't use the values right away. Use the notations. What will be the ICL? Capital L into small b cube upon 12. Yes or no?
Yes, sir.
Correct, guys. This will be the numerator. Capital L into small b cube, right? It will be cube of 4, not of the breadth at the deck. Right?
Yes, sir.
Yes, sir.
Divided by, in this question, how can I get the volume of displacement based on the information?
Into base.
Look at the question.
Displacement divided by
1 by 2 into small b into small d.
246. अरे यार तुम लोग कहाँ जा रहे हो? Displacement दिया है, density दिया हुआ है.
सर सीधा डिवाइड कर देंगे ना 240 से, that will volume.
तो मैंने क्या लिखा बोर्ड पे? Have I written something else?
No, sir, you have written right.
Yeah, so that's what I'm saying. So why you have to go back to the draft thing you calculated from displacement? Why you want to go back to it when you straight have displacement and density, right, guys? Straight away use it. No, why you want to go in circles?
Sir,
Right?
you were writing notation. I thought that's why.
Okay. So this is displacement upon density, right, beta? In notation,
Yes,
it will be
sir.
W upon density, right? Anyway, so now what will happen?
Yes.
You can put the values and calculate. Put the values and calculate. What will be 40 small b is 4 cube upon 12 into 246. 1.025 will go in the numerator and calculate the value of Bm. And add 2 meters to it. It should be coming then 2.889 is kmt, so it will come basically 0.889. It should come, right? But just see how much it is coming. Is it coming?
Yes, sir. 0.88.
0.889?
Yes, sir.
0.89. Yes, sir.
And add 2 meters of kb to it. That is the answer on top. You can see it's 2.889 meters is the kmt. So here, what have I done? Here the breadth at the deck and the breadth at the water line are different. So there should not be any confusion. We are dealing with water plane. In the previous question, it was because the breadth at the water plane was same as the breadth at the deck. That's why we used it, but we were to use basically the breadth at the water plane all the time. Guys, would you like to now calculate KML and match the answer? It's already given there on the screen, 30.889. I hope it's 30 only. Calculate. Draw first. Don't just calculate. First, draw an athwart shape axis. Mark it. You can mark it FF if you want to follow me. Write the formula for BML. It will be small b. So small b is 4 meters into cube of the length 40 cube upon 12 into 1.025 divided by 246. This will be the value of BML. And this should come 28.889. Yes or no? Just calculate and see.
$88.889, sir.
28.889. And then add 2 meters.
Sir, can I ask some small favor?
Yeah, tell me.
Sir, can
Take the lead. First, read the question. I don't want to even read it. For BMP,
Yes, sir.
I need this axis. Okay. If you have not understood, then you calculate the longitudinal location and mark the exact position. We'll calculate the longitudinal for BML in any case. Okay. But keep it simple. For BMT, you don't need to know whether it lies aft, does it lie forward, does it lie midships? No. Because you don't have to draw a athwartship axis for BMT, you have to draw fore and aft axis. So you should know, is it right at the port side? Is it inside of port side? Is it on the center line? Is it to the starboard of the center line? And I think in this case, there is no doubt, center of flotation will be on the center line. Does everybody agree?
Yes, sir. Yes.
And do you also agree that center line becomes the fore and aft axis through center of flotation? Yes or no?
Yes, sir.
Correct, guys? So please write the formula for BMT. You take the lead now and write the formula. I'll follow, then you can keep matching. What I've written, is that correct, or you have written something else? ICL of the water plane?
Same, sir.
Okay, guys. How many shapes is my water plane made of? Two shapes, correct?
Sir.
So like the center of like the center of pressure, when you had two bulkhead was triangular and rectangular, or semicircular and rectangular, what did you do? You added the inertia of the two portions, yes or no?
Yes.
Yes.
Correct? Okay, so here also you'll do the same thing, inertia of the rectangular part and inertia about center line of the triangular part divided by volume of displacement. Do you agree with me on this?
Yes, sir.
Yes, sir.
For rectangle, is center line a standard axis? Just look at the diagram before you further write. For rectangle, is the center line a standard axis?
Yes, sir.
Does everybody agree? Okay. My next question is center line a standard axis for triangle? Only answer yes or no.
No, sir.
No. Correct, guys? Does everybody agree that for rectangle, it's not a concern? For triangle, center line is not a standard axis. Does everybody agree?
Yes.
Very good. Very good. But see, if I divide this triangle into two, I take half the triangle. Does center line become a standard axis?
Yes, sir.
Yes,
Through the base. Correct?
Yes, sir.
So if I take this triangle, half blue triangle, then this side of the blue triangle will be 9 meters and this will be 6 meters. Am I right, guys? Right?
Yes,
sir. Yes, sir.
Yes, sir.
So the total moment of inertia will be twice of it. So how can I write? See how I can write. I'm not interested in putting values right now. ICL of the rectangle plus twice the ICL of half triangle. Is that clear, beta? Divided by volume of displacement. Is that clear?
Yes, sir.
Is this step clear to everybody?
Yes, sir.
Because now the water plane comprises of three portions. What? One rectangle, one half triangle, second half triangle. So both half triangles are identical. So it will be double of it. Now with values, tell me what will be ICL of the rectangle. Look at the diagram and answer. It will be 40
into 9 cube upon 12.
40 into 12 cube upon 12. Right, guys?
12 cube, yes.
Okay, very good. Then plus 2 into what will be the ICL of one triangle? BD cube by 12.
Cube upon 12.
9 into 6 cube upon
9 into
6 cube upon 12. Correct, guys? Divided by what will be the volume of displacement? 2000 tons of displacement in water of RD 1.020. Correct, guys? Write like this. Don't calculate each part now. Now pick up the calculator and on the run, just calculate the final value and give the answer. Don't waste any more time in calculating this, writing this. No. Calculate on the run and see whether you're getting it 3.103 or not.
Yes, so 3.1028.
Yeah, so 103 meters, right? Solve it, see it, and let me know if there's a doubt.
Yes, sir. 3.103.
If anybody has any doubts on the steps, please convince yourself with the steps and let me know if there's a doubt. Done? Everybody is good with it? That is why we had done that formula about base. BD cube by 12 formula we did to. Otherwise, you would have been forced to apply theorem of parallel axis here, which would have taken more time, right? So if you remember that one extra formula, that will help you in saving a lot of time here, right, beta?
Right, sir.
Yes, sir.
Okay. So now we come to BML. Let me see if the next slide sheet is the same question. For BML, don't mess up the same diagram. It doesn't take much time to make the diagram again. Always unless it is a simple one shape you can use. Otherwise, always be open to redrawing it. 40 meters, 12, 9 meters, 12. Okay, this is the water plane. Okay. Now, when I have to calculate BML, I need to draw athwartship axis. Okay. Now it becomes important for me to know whether the center of flotation lies here. Does it lie here? Does it lie here? Because depending on where it lies, my axis will be drawn through that point. Yes or no, guys? Correct?
Yes.
So it is imperative, it is important that first I find out at what distance from aft or along the length where does my center of flotation lie. And that's why I told you, you will use the same concept which you used in phase 1 to find LCF, where the water plane may have been made of two areas. So what is the area of the rectangle beta? Area of the rectangle is equal to 40 into 12 equals to 480 square meters. What is the area of the triangle? It's half base into height, 54 square meters. What is the distance of geometric center of the rectangle from after perpendicular? What is the distance? What is the distance of geometric center of the rectangle from after perpendicular, guys? Tell me. Look
20
at the
meters.
diagram.
20 meters.
20 meters.
20 meters.
20 meters. Yes, and so it will be midway, right? Okay, so here will be the geometric center. I'm calling it as G1. Okay, it is the geometric center of the rectangle. Where will be the geometric center of the triangle? It will be here.
43 meters. 43 meters.
Very good. So D triangle from after perpendicular will be 43 meters. Does everybody agree? So what are we saying? This distance on the diagram, load on the diagram, this is 43. Sorry, this is 20. And this distance is 43. Correct, guys? Right?
Yes, sir.
Yes or no? Now we can find out the AF of the vessel or the LCF. What will it be? Longitudinal moment of the triangular portion plus the longitudinal moment of the rectangular portion divided by the total area. So it will be basically 480, the rectangular area, into distance of its GC, that is 20, plus 43. The triangular area 54 into 43 divided by the total area 480 plus 54. Can you guys calculate AF and BP?
22 decimal 326. 326.
After 22, I'm with 326. Okay, 326. Guys, please, everybody to calculate and everybody to agree with this step before we run somewhere. Okay, very good. Everybody's okay with it?
So
Calculation of, yeah, guys, about which we have taken the moments. A to G1 is 20 meters and center of flotation is 22. That means center of flotation is somewhere here, right, guys? And this distance is AF. Of load the diagram 22.326 meters. Yes or no?
Correct.
Correct. Now
Right.
for BML, we need to draw an athwartship axis through center of flotation, which I've already drawn, and I can call it as FF. Okay. Now I can write down the formula for BML. It is IFF of the water plane divided by volume of displacement. Does everybody agree with this formula that I've read? Yes or no? Okay.
Yes, sir.
And this will be equal to, like the previous part, IFF of the rectangular part plus IFF of the triangular part divided by volume of displacement.
Right.
Look at this. How can we calculate the IFF of the rectangle, guys? Can you tell me now? Just give me the idea, not that you, which concept
So
will you
by-
apply to get?
Theorem of
Theorem of
parallel
parallel
axis.
axis.
Parallel axis. This axis is passing through the geometric center of the rectangle. Let me call it as XX. Similarly, we have another axis passing through the geometric center of the triangle. Let me call it as YY. I have marked, load the diagram first before you come here. And now, see if I'm writing like this, is it okay with everybody? And I'm putting a box bracket only for the purpose of consolidation of understanding. Otherwise, box bracket will have no meaning. IFF of the rectangle will be equal to IXX of the rectangle. Why? Because XX passes through the geometric center of the rectangle plus area of the rectangle into this distance. Let me call it as D1 into D1 square. Do you agree with me? This is this part of it. Yes or no, guys?
Yes, sir.
Correct. D1 is the distance between FF and XX. Yes or no? Look at it and let me know first if there is any concern. It's straight theorem of parallel axis.
No concern, sir. No concern.
Okay. And what will be the value of D1? Let me put on the diagram. It will be 22.326 minus 20. Yeah, 2.326 meters. Okay.
326.
Yeah. Let the distance between FF and YY be D2. What will be D2 equal to? D2 will be equal to 43 minus 22.326. How much it comes to?
20.674.
674. I have loaded my diagram so that I don't have to run here and there. See, the diagram needs to be loaded exactly the way I am loading it. It will become easier for you. Now apply the theorem of parallel axis for the triangular portion, guys. Plus IYY of the triangle plus area of the triangle D2 square. This is this part. Please look at, evaluate and tell me if it's okay. Yes or no?
Yes, sir.
And this whole thing divided by volume of displacement. I'll take a pause here for everybody to understand, absorb. Give me a go ahead, because then it's only a matter of putting the values. I'll not put the values unless everybody says that they've understood this step of. I wanted IFF of the full area. Area comprises of two shapes. So I'll have to take IFF of each shape and add that. But FF unfortunately does not pass through the geometric center of rectangle or the triangle. Then we saw that in this case, theorem of parallel axis can be used. And so we introduced these two axes, XX and YY. XX passes through the geometric center of the rectangle. YY passes through the geometric center of the triangle. And we have applied the theorem of parallel axis and brought down this BML formula to its current form. Is that clear, guys, with reference to our diagram, of course? Is that clear, guys?
Yes, sir.
Clear, sir. Clear.
Yes, sir.
Now we'll straight away put, and these are good enough steps. You don't have to write anything more than that. No explanation is to be given that you're using theorem of parallel axis or not. No, nothing. Next, I'll straight away put the values. IXX of the rectangle will be BL cube by 12. So breadth is 12. Length is 40 cube upon 12. This is one value I have put here. Do you agree with it? Plus area of the rectangle we have already calculated is 480. D1 is already marked in my diagram. It's marked as 2.326 square of it. The second term I have put the values. This box bracket has no relevance. We can keep adding all the terms. Plus IYY of the triangle. It is a standard axis parallel to the base. Base in this case, 12 will be the value. Beta, do you agree with me? Anybody has any doubts?
Right.
plus area of the rectangle triangle is 54. T2 is already on the diagram, 20.674 square, divided by volume of displacement. Displacement is 2000 tons in water of RD 1.020. And now with this expression, don't calculate each part. Use the calculator. You have to be a smart user of your calculator now, beta. And this will give you PML equal to, unless 45.759.
45.859, sir.
Okay.
0.859 आया sir. 45.8.
Okay, I have written 7.5. Okay, maybe I have written it wrong, or I don't know. I have done it on the run. You have also done it on the run, and maybe it's 859. I can correct it.
Sir,
No issues. Beta, tell me.
Sir, if I do it, because I have started with doing that with this, instead of BDQ by 36, I used BDQ by 12 and used the axis YY
Then
like at the base of the triangle. That will.
But then you can't. Then you can't bring directly to. Then you can't bring to FF. No, yesterday we learned it during that curvilinear vertical ordinate ke time we discussed that issue. Na, can you bring from directly there to FF? If you are taking this axis, first you will. This is the standard axis, but not passing through the geometric center of the triangle. No. What is the prerequisite for theorem of parallel axis?
Sir, that's correct. It's not passing through the geometrical center, but we have already included when we calculate BDQ by 12, the parallel axis for this much of the.
Parallel axis we applied between y. You are saying you are confusing yourself also and confusing others also. You are saying I'm taking this axis ZZ and here is FF. Can you take it, apply theorem of parallel axis between these two?
No, negative, sir. Cannot.
So that is the mistake, no, beta?
Yeah, I got it, sir. Got it. Understood.
From Z. Sorry.
859.
Everybody's saying everybody's saying 859. Then I must be wrong. 45.859. Okay, fine. Everybody is saying 859. It's okay. Yeah. Okay, fine.
Yes.
Okay. So don't make these mistakes, beta. Theorem of parallel axis, one of the axes has to pass through the geometric center. If you're taking about the base, that's why I said use the correct formula in the right place. You cannot be deviating from the basics. If you deviate from basics, you will mess it up for yourself. If you are taking about base, then you'll have to first take it to YY and then bring it here. Why increase your work scope unnecessarily? You can't bring directly from base to FF.
Understood.
Is that correct, guys? What you have made? Is this what you have made as the water plane?
Yes, sir.
Okay. For BMT, anybody has any doubts about the diagram, guys? Please speak up. When half ordinates are given, what does it mean? The other half is exactly identical, yes or no? Correct, beta?
Yes, sir.
So that means the center of flotation, wherever it may lie, the center of flotation, wherever it may lie, it will lie on the center line, yes or no?
Yes,
correct?
sir.
Therefore, CL becomes, wherever it may be, I'm just marking it randomly. I don't know whether it is here or somewhere else. But CL happens to be a 4.5 axis through center of flotation. Does everybody agree? Yes or no?
Yes, sir. Yes, sir.
Yes, sir.
So what will be my formula for BMT? BMT is I CL of the water plane divided by V. Guys, I'll ask you some simple questions. Which is my reference axis here?
CL, sir.
Center line.
CL, okay, very good. Reference axis is CL, like liquid level you had in the COP questions. Very good. If CL is my reference axis for BMT, then is it a case of vertical ordinates or horizontal ordinates?
Vertical, sir.
Vertical ordinate.
Okay, got it?
Because perpendicular to the center line.
Yes, yes. Okay. So obviously for moment of inertia, you'll have to use vertical concept, right? Now, what I'm trying to tell you here is, at which, is there any axis where all these ordinates are terminating?
Center line.
Center line. They are half, right? Now, what I'm saying is, here he is given you half breadths. Suppose these breadths were given full. If breadths are given full, you can't use the vertical concept with full breadth. You'll still have to make it half, because then only they'll terminate at the center line. Correct, beta?
Correct, sir.
Yes, sir.
In this question, he's given you half breadths. So you may feel, okay, I'll use half breadths. Tomorrow somebody gives you full breadth. Then you'll have to still take half breadths and solve it. You can't solve it with full breadth. Why? Because with the full breadth, the breadth would be like this. The ordinates are not terminating at the sides. They are all terminating at the center line. So I'll have to divide into half. Yes or no? Have you understood what I'm saying?
So you mean to
Yes,
say
sir.
that if full ordinates are there, they will not terminate. If half, then it will terminate at center line.
Yeah, then they are terminating at center line, the straight line, correct?
Yeah, correct.
Correct.
Can you repeat?
So eventually, sir, we have the ordinates should always terminate on the reference axis. That's what we are going to, right, sir?
No, not at the reference axis. They should, for vertical ordinates. Why in case of COP, were they all terminating at liquid level every time?
Yes, sir, it was.
Were?
No.
In the question that
sorry,
we did in the question that we did last time, where the water
Yes, sir.
was in the sounding pipe, were the ordinates terminating at the liquid level?
No, negative side, they were not.
So why are you misrepresenting the entire case that they should always terminate at the reference axis?
No,
If they
I'm not.
terminate at the no, you made that statement, no, beta. That's what I'm saying. So if they terminate at reference axis, you're fortunate, but they have to terminate at a straight line, right?
Yes, sir, they have to terminate at a straight line.
Yeah, but you said that I was commenting on that part of your statement. Beta. Okay, anyway, that's fine. Okay, fine. So have you taken note of it that if the full breadths were given, still it has to be converted to half breadth for solving? Have you made a note of it? This issue, will that remain with you now?
Yes, sir.
For moment,
1 by 2 y dx.
Y squared dx.
Half of y squared
y
dx.
squared dx.
Y squared.
Inertia 1 by 3 y cube.
1 by 3 y
Okay.
1
Yeah.
by 3
In
y
this
cube dx.
in this question, y cube dx, right? In this question, you don't need area, you don't need moment, because you don't need the location of center of flotation. You know it's lying on the center line. Okay, but if you have any doubt, you can stick to the same table. Don't worry about it will not take much time. I'm just telling you a method where you'll hedge your risk of any mistakes. So basically your tabular form would be the ordinates and Simpson's multiplier. These are 10 ordinates. Simpson rule 2 will apply. You have product of area. Just write down, but don't total it. No need to total. Don't waste time. Then write the ordinate, product of moment about center line, No need to total. You don't need it. Then ordinate product of inertia about center line. This will first you will have the summation, and then you will have the SOP inertia. Right, guys? Am I correct? You remember this format?
Yes, sir. Yes, sir.
Yes.
What I'll be needing is this part. Please make the table, calculate. Don't waste time in adding it up. If you add up, no harm done. Only thing is you'll waste your time. Please calculate this. Complete the table. If anybody is not understanding, you are free to ask. I'm here very much in attendance. The summation comes to 603831.7. Unfortunately. And why is it coming that high? You see, the length of the ship is only 180 meters because there are 9 intervals into 20, 180 meters. And for a 180 meter long, the maximum half breadth is 35.3. So that means the breadth will become 70 meters. You will never come across a merchant ship which is only 180 meter long and 70 meter wide. Yes or no?
Yes, sir.
It is because of the abnormal length to breadth ratio, more spread out breadth wise, that BMT is coming much higher. Okay. So the first time when I calculated, I was also taken aback by the value. But then once you can figure out why it's happening, it's because of the abnormal ratio between length and breadth. So then it's okay. You have a justification for it, but that this I'm just discussing. You have nothing to do with. You just leave the answer, whatever it comes. So you don't have to justify anything, but it is just to draw your attention that this BM value for a normal ship-shaped vessel is very high. And in this case, it's so because for a length of 180 meters, you will not have a ship which is 70 meter wide. Okay, guys?
Okay, sir.
Okay. Now we calculate I'm clearing this screen. Now we'll do it for BML beta. Okay, discard. Make the diagram again. In such cases, don't play with the same diagram. Always make the diagram again for the water plane. Make the diagram again, please. One, 13, 24, 5, 33, 35, 35, 23. Is the diagram made, guys?
Yes, sir.
So in this case, we will firstly recall the formula for BML. It is I of what? Water plane. About which axis, beta? BML which axis?
Athwards.
Through center of flotation, right?
Yes.
Okay. So now tell me, if I draw an athwartship axis, I don't know where the center of flotation is. I'll have to find that out. But if I draw an athwartship axis through center of flotation, guys, then is it a case of horizontal ordinates or vertical ordinates?
Horizontal.
Horizontal ordinates.
Horizontal ordinates. Okay, so firstly, horizontal ordinate. Now I do not know where center of flotation is. So that means I'll be forced to work about after perpendicular and then make adjustments. Because I don't know where center of, so I can't draw a athwartship axis unless I know where the center of flotation actually is. So what do? I draw a parallel axis, that means an athwartship axis through the after perpendicular. So now you have already told me that it's a case of horizontal ordinates. So for horizontal ordinates, it's y dx, yx dx, and yx square dx. So make the table. Now we'll make it for half again. So see, we have always been naming that exercise thing as FF. We'll name it later. So what you can make the table now is, first will be the half ordinate, semi-ordinate, whatever is given. Then you'll have the Simpson's multiplier. You'll have the product of area. Why we had to take after perpendicular? Because you need an axis. Otherwise, you can't use the horizontal ordinate concept, right? And I don't know where center of rotation is. So that means now I take lever about after perpendicular. See how I've written it. It can be 0h, 1h, 2h, 3h, 4h. You all know that. Then this will be the product of moment of output. Then I'll repeat my lever again once again. This we did yesterday. And I'll have product of inertia about after perpendicular of how much area? Of half the area. So what will I get? I'll get inertia about after perpendicular. You'll complete this table and you'll give me the SOP area beta. In this way, you'll directly get SOPs. You'll get, of course, this is half area, SOP half area. Then product of SOP moment of half area and SOP inertia beta. Give me all these three things. I'm putting the values for you to validate. Please complete the table and calculate the values. All of you know how to calculate it.
So I have one doubt, sir. So I just wanted to ask, instead of taking this half ordinates, can we take it like
Yeah,
multiply by 2 and
yeah.
solve it by?
Yeah. You can do. In this case, you can do. There's no problem. There's absolutely no problem.
Yes.
Better. Now on the diagram, each common interval is 20 meters. So from after perpendicular, this is 20, 40, 60, 80. Somewhere here would be the center of flotation. See, now you have to mark it with the common interval. Why mark randomly here? Is that clear? Have I marked the center of flotation in the correct place between the correct coordinates? See, beta. Four intervals will make 80 meters and then another 3 meters, right? Center of flotation would be between 35.3 and 35, yes or no?
Yes, sir. Yes, sir.
Correct. Now for BML, what do I need to do? I need to draw 4.5 axis through F or athwart shape?
Athwart shape.
Sir, athwart shape.
Athwart shape. What do I name it? You can name whatever, but FF. Let's standard. Okay. Now with reference to my, what is the distance between after perpendicular and FF is equal to AF, right? 83.725. I've gone on the, put it on the diagram. Correct, guys? Yes or no?
Yes, sir.
Yes, sir.
So with reference to this diagram, do you agree with me that BML will be equal to twice, or first let me write it, a simple formula. It will be I of the water plane area about FF, full water plane obviously, upon V. Since we have dealt with half, so we'll make it 2 into I FF of the half water plane divided by V. So now 2 is what I'm doubling up. IFF of the water plane. Now guys, the table gives me SOP inertia about which axis?
AP, sir.
AP. Guys, I want to write in this box theorem of parallel axis between AP and FF. What will I write? Theorem of parallel axis.
IFF plus total area into sir AF square.
No. I write the theorem.
Sir, IAP equals to
Very good.
IAP is equal to
plus
IFF plus area
AF
into the
Correct,
distance which we found, AF.
Yeah, AF square,
sir.
right? Correct. Have I written correctly? If I take it right, okay. But
Right,
what do I have? I have AP. What I want to calculate from AP is IFF. So if I transpose these sides, IFF, like yesterday's case, it will be IAP minus A into AF square. Please, I'm sure yesterday also we deliberated upon this issue. Yes or no?
Yes, sir.
Am I right, guys? I want to draw your attention to this part, this part. Correct? Yes or no?
So this A will be half area, sir, right?
When we take half, it will be half because that is doubling up. It's area basically. We are just writing the theorem of parallel axis, right? Area, whatever area you're taking, right?
Okay.
So now this FF, I'm writing in terms of AP by theorem of parallel axis. What will this be equal to? This will be box bracket I AP of half area. So if this inertia is for half area, that area will be half area, correct? Minus half area into AF square, right, beta? Now that answers your question whether it should be half area or full area. If inertia is of full area, then area will be full. If inertia is of half area, the area will be half, right? divided by volume of displacement. Does everybody agree with this steps? Do like this, the way I am writing. If you do like this, there will be no confusion ever in your minds.
So if we calculate with full ordinate, we won't be doing this multiplied by 2.
But that's all. That's all.
Yes, sir. Yes, sir.
That's all. You'll use full area. You'll use the inertia for the full area. Correct, beta?
Right, sir.
You're absolutely
We
right.
won't be doing
You'll
multiply
just,
by 2.
yeah, this box bracket will not be required then. Okay. Okay, beta?
Yes, sir. Yes, sir.
This will be equal to 2 into, now guys, IAP of half area we can write because we have the SOP. It's 3 by 8 into common interval 20 into SOP inertia. It is written on the screen also. 13947.3 into 20 into 20 by, because h square, minus half area is 4747.5 into AF is 83.725 square. Whole thing divided by volume of displacement. Volume of displacement is 1,15,000 tons divided by 1.025. And you write like this, pick up the calculator, solve it on the calculator, and give the answer. And the answer should be coming as 152.636, unless I have made any mistake.
Yes, sir. 152.636.
Okay. That will be the BMI. Oh. Applicability will have two parts. One is with minimum numbers and something more than that. More than that, if the total number of ordinates is odd, that means it is 5, 7, 9, 11. If the total number of ordinates is odd, rule 1 can be applied. Okay. Rule 2, minimum is 4, fine. More than 4, if your number of ordinates fall in series, which series? With 4, you keep adding 3, 7, 10, 13, and like this. If your number of ordinates happen to 7, you can use rule 2. If they happen to be 10, like in this case, you can use rule 2. If you are 13, you can use rule 2. You can keep adding 3, and next will be 16, then 19, and like this. Okay. Now, when the number of ordinates is more than 3 for rule 1, then the Simpson's multipliers will be 1. This 1 you keep to the left. This 4, 1 you take to the extreme right. And in between, you keep filling on these blocks. 4, 2, 4, 2, 4, 2, and end with 4, 1, so that your number of multipliers has become equal to number of ordinates. So if you have 5 ordinates, you'll have 5 multipliers. What will they be then? 1, 4, 2, 4, 1, because it has to end with 4, 1. If it is 7, then it is 1, 4, 2, 4, 2, it will end with 4, 1. So you'll keep inserting these blocks of 4, 2 in between till the number of multipliers become equal to number of ordinates. And of course, you will end with 4, 1, right? Here, again, the same thing. Those who don't need this can sign out better. Those who don't need this, I know you don't need, you can sign out. You keep 1 on one side and 3, 3, 1, the remaining thing on the other side. And since you are adding 3 ordinates every time, you have to add the blocks of 3 multipliers. The multipliers will be 3, 3, 2, 3, 3, 2, and you'll end with 3, 3, 1. So this is how you'll decide on which will be the multipliers, which rule to apply. When you have, say, number like 7, both 1 and 2 can be applied. It's your choice which one you want to apply. Then the last thing here is coefficient. Coefficient is 1 by 3 for rule 1, 3 by 8 for rule 2. Every time you use rule 1, coefficient will be 1 by 3. Every time you use rule 2, coefficient will be 3 by 8. And the final formula which gives you the value will be coefficient, which is either 1 by 3 or 3 by 8, into common interval, spacing between the ordinates, into SOP. So if it is SOP area, you'll get area. If it's SOP moment, you'll get moment. If it's SOP inertia, you'll get inertia. This is the final formula to get you the result. Is that clear, beta? Does this help you in recalling something from phase 1?
Yes, sir. It does, sir. Thank you. Thank you so much.
Okay. You can go through that book a little bit if you have more hesitation. Okay, beta. Just run through it. Don't leave it for the last day. Okay.
Oh, yes, sir.
Okay.
Thank you. Thank you.
Okay. Okay, guys. If it's okay, then can I sign out, guys? Some of you may have already gone. It's okay. Chalo, take care then. Okay. Bye.
So one thing. So I just wanted to have the inquiry regarding this NAVED's classes from tomorrow, sir.
Yeah, bolo. What is the query?
Sir, what all topics will be
Of FSC to GM and KG. We can quickly have a recall of it. We all know what is free surface correction. We know free surface correction is FSM upon displacement. Correct, guys? Or any doubts on that? Is that correct? Or anybody has any doubt on that?
Correct, sir.
No,
Correct.
correct, sir.
Okay, then how do you get FSM? You get FSM by multiplying something called as I with the density of the liquid. I'm sure this also. Yeah, correct.
Yes, sir.
What is this I which you have been picking up from the MV Hitchip tables? This I is the moment of inertia. Again, now your question would be, why are you stopping at moment of inertia? You have not told us which area, which axis. This I in this FSM is the moment of inertia of the free surface. So which area? The area of the free surface in the tank. Okay, the free level, the free liquid level surface, whatever is the area. If it is rectangular, it is rectangular. If it is triangular, it is triangular. If it is circular, it is circular. If it's curvilinear, then it's curvilinear. So it is the moment of inertia of the free surface. And about which axis? About fore and aft axis through the geometric center of free surface. I'm not saying water plane this time. I'm not saying center of flotation. Geometric center of the free surface. So that means you have to identify the shape of the free surface. You'll have to figure out its geometric center. And through that geometric center, you will draw a fore and aft axis. Okay. Now this is the axis drawn through the geometric center of the tank. Whether it coincides with the center line of the ship, does not coincide with the center line of the ship, doesn't matter. Okay, because we are talking of a wing tank, obviously the fore and aft line will never coincide with the center line of the tank. So please be very clear what I'm saying. I said it is about fore and aft axis through the GC of the free surface. Is this what I have written here clear to everybody, guys? What is I? Right. In the first application COP, you were visualizing the shape of the immersed area. You see, in COP, the area involved was the immersed area. In BM, it was the water plane area. And in I of the free surface, it is the shape of it is the area of the free surface that has to be taken into account. Am I clear now? When you look at all the three, I think it becomes absolutely clear in your minds as to what we've done and what we're going to do. Okay. And then, of course, application of FSC to GM, we all know KM T minus KG is GM solid minus FSC is GM fluid. I'm sure all of you know it, right, guys? This all of you know. I don't think this needs any discussion.
No, sir.
Okay, fine. And lastly, what do you mean by fluid kg? All of you have done GZ curves. In GZ curves, you are taking corrected kg, or that can also be called as kg fluid. And how were you obtaining it in GZ? You were adding the free surface correction to kg. I'm sure all of you can remember from your phase 1. This you were using in drawing of the GZ curve, right, guys? So kg fluid will be equal to kg. When we say kg, by default we mean kg solid, and you have to add FSC. Whereas from GM solid, you have to subtract FSC to then get GM fluid. All this is just a quick recap so that we don't struggle. Whatever I've ticked is just a quick recap, correct, guys? And what I have just added is, what is this small I out here? This is the moment of inertia of the free surface about a 4.5 axis passing through the geometric center of the free surface. Any questions on whatever I have written and said so far, guys? What will be the shape of the free surface?
It will be, sir, circle.
So why are you asking me to explain it?
Okay, sir.
Okay. Okay.
Okay, sir. Okay, sir. Thank you.
Yeah. Okay. If you have some other shape of the container, then it will be different, right? Okay. Is that clear to everybody, guys, what I've said, or any more questions? Already done that. And now we come to this question. The free surface of a 4-peak tank is triangular in shape with 12-meter width and 15-meter length. If the 4-peak contains FS water of RD 1.005, calculate the FSM in the tank. Please draw the free surface. Now you are not drawing the water plane, you are drawing the free surface in the tank. As per the question, please draw the shape of the plane surface, free surface in the 4-peak tank. Have you all done? Mark the dimensions appropriately. Done, guys? I'm not drawing it. I want you to do it and lead. Done it?
Yes, sir.
Okay, very good. I'm sure you would have drawn like this. If not like this, then you tell me what is the concern. This is the length of the 4-peak
And
free surface, and this is the breadth of the free surface. Correct, guys?
yes, sir.
Please mark the geometric center where you think is the geometric center of this free surface. Now I'm using the word free surface. I'm not saying triangle. I'm saying mark the geometric center of this free surface. I'm sure all of you would agree that the geometric center would be somewhere here. Yes or no?
Yes.
Correct, guys? Please draw a 4.5 axis through this geometric center. In case of 4-peak, it may be coinciding with the center line, but I don't want to write center line at all because this can be misleading to you. It's only for your. So instead of that, I'll call this axis always XX. XX may coincide with the center line, may not coincide with the center line. Am I clear about it? Correct, Vita?
Yes.
So FSM will be equal to, he says find the FSM. It will be I into DI. And look at this. How can I get I? I don't have to speak now. Can you tell me how do I get I in this case? I about XX. Correct. I XX. Oh, now let me write like the way we have been writing. I XX of the free surface will be equal to twice into I XX of half of area. Correct, guys? Correct. This will be equal to now 2 into, tell me, what do I cube and what do I multiply? Tell me, guys. I don't want to give you any hint. You are already on top of it.
12 into 15 cube. No, sir. 6 in
नहीं सर, नहीं सर.
6 into 15 cube.
6 into
12 cube होगा सर, 12 cube
15
होगा.
into 6 cube upon 36, 12 upon 12.
PD cube upon 12. You want the moment of inertia of this triangle about this axis, guys. So this axis is forming the base. If this is the axis, then what is the height of the triangle? 6 meters. Yes or no? Correct? Why
Yes,
so
sir.
why so much of confusion, my dear? And FSM would be equal to 2 into 15 into 6 cube by 12 into the density of 1.005. Units of FSM would be ton meter. Ton meter. And see if the answer is coming 542.7 ton meter, beta.
Yes, sir.
Yes, sir.
542.
Okay, anybody has any questions on this one? Right. A longitudinal bulkhead on the inboard side. The breadth of the free surface in the tank measured at equi-spaced interval of 4 meters interval from forward R. This is my own question. So the idea is not to have too many ordinates or something. Idea is just to make sure that we are clear on the concept. Find the FSM of the tank when it is partly filled with seawater of RD 1.010. Now, let me give so that we have the similar diagram. Let us say, guys, this is the forward side of the ship and this is the after side of the ship, so that all of have the same orientation. We don't create confusion. Now, can you draw the shape of the water plane? Keeping top of the page as forward and keeping the bottom part of the page as aft. Now draw this free surface and mark the ordinates. I'm sure all of you can visualize this free surface. If you have doubts, even then, draw it in rough. Don't just keep sitting and looking at the board, beta. Because you cannot solve a question unless you can get the question right. Solution follows after understanding the question. So don't always try to follow the class. You need to lead the class. Has everybody drawn the water plane, whatever they thought of?
Yes, sir.
Okay, now I am drawing. If you are in agreement, fantastic. If your diagram does not match with mine, then if you feel that you have made a mistake and you have understood the mistake, then fine. If you still feel that no, you have not been able to figure out, then let's discuss. Okay. They are given from forward. So here is the center line. I'm drawing on the starboard side. If somebody has drawn on the port side, it's fair. That's not an issue. Because my hand usually works on I'm a right-hander, works on the right side. So that's why I'm keeping it on this side. But if somebody has done on the port side, it's perfectly fair. No issues about it. So that does not need any deliberation. Guys, is the diagram correct? Tell me.
Yes, sir.
Anybody who feels that he is not able to understand the diagram as per the question?
Yes, sir.
Correct, sir.
Let us say the geometric center is here. Let's say, I'm just hypothetically saying. Then what do we have to do next? Once the G is found, then what do we have to do next? Tell me, to find FSM.
So this is the fore and aft.
We have to draw fore and aft
Axis will be
axis.
fore and aft.
Okay. So draw a fore and aft axis through G. Mark it XX the way we have been marking. So do you agree with me? Okay, which is the axis of interest in this case now for I of free surface?
So the one which is getting terminated, the one where all the ordinates are getting.
You're not heard my question only.
Center line.
Which is the axis of interest?
4.5.
In the diagram, yeah,
Longitudinal bulkhead. Longitudinal bulkhead.
you want moment of inertia about longitudinal bulkhead. Is that your axis of interest?
Vertical axis. Vertical axis.
Which one?
XX.
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 XX, sir, XX.
You for moment. What is I? I is about which axis? Is it horizontal ordinate or vertical ordinate? Okay. And for vertical ordinates, we must have them terminating at one axis. So that means x, they don't all terminate at xx. So therefore, we will have to work about first this axis. This is because we have to work around out of compulsion, not out of choice. Had I been able to work about xx directly, I would have been happy. So that means I'll have to work about zz or yy, whatever I call first, and then get about xx. Am I right, guys? Have you understood why it's being done so?
Yes.
Correct me. And what will be the tabular? Make the table for vertical ordinates about zz. First write the column headers, then I'll write. Make the Simpson's rule table for moment of inertia about zz for this particular case, which is on display. I don't want to give any hint. I'll make, and then you can compare.
Sir.
Okay. Does everybody understand? I don't even want to say what I have done in green. Does everybody understand what has been done, or any doubts? Please speak up if there are any doubts.
No doubts.
Very good. So now, guys, anybody wants to stop me, or shall I just continue? Okay.
Continue.
Okay, guys. Now FSM will be equal to I about xx of what? Free surface multiplied by di. Now I about xx we need. Okay, guys, we are going to get about z. Okay, so this is what my problem statement now is. So what do I need to do? I will have to use theorem of parallel axis, for which I will need this distance d also. Yes or no? What is common interval? Common interval is given as 4 meters in the question. So can you please calculate quickly the area of the free surface? How much is the, I've written A, but I'm talking to myself and saying it's area of the free surface. How much is the area of the free surface?
82.5.
82.5.
82.5.
Very good, guys. Then can you calculate D, the distance between ZZ and XX? I don't want to give any hints now.
4.049.
4.045 is what I am getting, beta. Unless I have made a mistake.
4.045. Yes, sir. 4.045.
Okay, very good. Guys, everybody, all 50, 60 of you are aligned on this. It's giving me a lot of pleasure to actually see that when people are understanding, it's actually giving a lot of happiness, guys. So I hope A and D is okay with everybody. What will give you the D from Z? Can you mute yourself? There's an echo from somebody's system. Okay, thanks. Okay, now guys. I'll not give you any hint. I need IXX. Can you tell me what will be the expression for by theorem of parallel axis for IXX? Be careful, I can only
IZZ minus A into DZ square.
You write whatever you want to write in rough. Give me the expression for IXX. IXX is equal to what?
IZZ minus
IZZ
very good.
minus
Why,
A
very
into
good.
DZZ
IZZ minus A into D square. Correct, guys? This is minus out here, right? Correct? Equal to IZZ will be equal to, we have used rule 2. So 3 by 8 the coefficient, 4 the common interval, and 1378.333 is the SOP inertia. The units of this I will be meter raised to power 4 because it is the second moment of area, moment of inertia, guys. and this value comes to 717.632 meter raised to power 4. Can you calculate and confirm A, the value? 2, have you understood the process until this point?
Yes, sir. Answer is correct, sir. 717.6.
Yeah, but have you understood what is done? That is also to be confirmed, beta.
Yes, sir. Yes, sir.
So I'm happy that most of the class said IZZ minus AD square. And this gives us FSM, guys. FSM will be equal to 717.632 into the density of the liquid, and it will be so many ton meter. The answer is on the screen. It is 724.809. Answer correctly. Only thing is I missed out on this expression which you have corrected me. Thank you. IXX will be equal to IZZ. So first is IZZ I'm writing. I'm writing it all over again here. Into 4 into 13, 78.333 minus area 82.5 into D square 4045 square. And this is what comes to, as per my calculation, which is subject to correction if there is any mistake. This is the IXX calculation. You can ignore what was done here, okay? You can ignore this one. Is that clear now?
Clear, sir.
So I give you 10-15 seconds for everybody to close it out, have a relook at the solution, and raise their concerns if any.
So just wanted to ask, like, in this kind of questions, you can directly write IXX is equal to IZZ minus A into D square.
Yeah, you can write, or you can write about ZZ, and that's up to you. You can write straight also, nothing wrong. That you knew everything, but if you were to do it on your own, for sure you'll miss out some part if I tell you to do now. But whatever I'll be doing is all that you know. There is nothing new that is going to come. Okay. Now, first is, let me make the vessel. It's 40 meters, 10 meters, 3 meter draft. And so this is the initial draft of the vessel. And our displacement is not a kg is given. Kg initial is given as 3.5 meters, guys, in the question. Our FSC initial is given as 0.080 meters. And then, of course, the tank is there. Wherever it may be along the line, doesn't matter. Okay. I'm sure with this, since she is floating in seawater, we know the dimensions of the box-shaped vessel. We can get the initial displacement. Can you get the initial displacement and give me the value? If somebody is not getting it, then only I'll explain. Guys, can you get the initial displacement? Write down the step and get it and tell me the value.
1230.
Very good. 1230. Is everybody getting 1230? Yes or no? Or I change the question. Is there anybody in the class who doesn't know how to get 1230? Please speak up.
1230, sir.
Yeah, anybody in the class who is not able to get 1230 or doesn't know how to get the initial displacement for this particular case. If everybody knows, then I'll not take everybody's time here. Then it is 1230. Okay, very good. What is the kg initial of the ship? Kg initial is given as 3.5 meters. Guys, can you find out the weight of the ballast that is taken?
51.25.
51.25 is saying. Anybody who doesn't know how to get the weight of the water ballast taken, question is on display. This is simple concept of
Can you
volume.
explain about the displacement also and its weight?
Now I'll not explain you displacement, beta. I asked 3 times. Are you being fair to the class? Because you thought either I'll explain myself or somebody else would ask. Are you being fair to the class? Tell me.
Yes.
You're being fair to the class. When I asked you at least 4 times before proceeding further, you did not open your mouth.
Yes, sir.
Sorry?
I already asked you, sir, to explain about that.
When did you ask me? After I went to small w, right?
Sir, one question. Sir?
So one second here. Let me finish with one person first.
Okay.
Did you ask me when I was in displacement initial, beta? That's not the way I teach here, please. I give everybody enough opportunity to ask doubts.
Sir, one question.
Let him speak first, Nayar. Your question I'll take. Wait for a while. I'm talking to the person who was asking about initial displacement. You cannot just fool around with the class like this, man. That's not the way I expect my class to behave, honestly. Otherwise, effectiveness of the class will go for a toss. Then I'll be only in appeasement policy to just get people for tutorials, nothing else, and there'll be no efficacy then. You can't get who asked about initial displacement? Can you identify yourself?
Myself, Saurabh.
Saurabh, you can't make out how to get the initial displacement by law of flotation? What is the underwater volume of this ship? Tell me, beta. Look at the diagram. Tell me what is the underwater volume. Ajay? How will I get underwater volume? What do I add? What do I multiply? What do I divide? Saurabh, speak fast.
Yes, sir.
No. What do I add? Divide? You tell don't give me the value. Tell me what to add or divide or multiply. What numbers to do?
14 to 10 and 14 to 3 into 10.
14 to 10 into 3 is underwater volume. You are sure about it? And if you have the underwater volume, how do you get the displacement of the ship then?
Multiply with the
Sorry?
volume multiplied by the RD, sir.
So then do that and tell me how much is it coming on your calculator? How much is it coming on the calculator? Calculate fast, or please give me the value. Saurabh, how much is it coming? Calculator has to multiply, man.
Yes, sir. I'm okay. So 96.
96.
Thank you so much.
40 into 10 becomes 400 and you are telling me 96.
अरे RD 1.025 मल्टीप्लाइंग विद 0.6 इसके साथ कर रहा है सर, तभी 96 आएगा इसका।
क्या चीज?
सर ये जो अपना 0.080 दिया है ना, RD की जगह उससे मल्टीप्लाई कर रहा है तो 96 आता है, वही कर रहा है वो 1.025
बेटा 90 नहीं, we are talking of initial displacement of the ship. वो 96 कैसे हो जाएगी यार?
40 into 10 into 3 into 1.025.
How can
डेंसिटी
1200?
गलत है
अरे कितनी भी डेंसिटी गलत ले लो यार।
नहीं उन्होंने क्या किया ना, जो एफएससी दिया वो डेंसिटी ले ली उन्होंने, तब गलत आ रहा उनका।
भैया फिर तू ही पढ़ सकता है उसको। जो तेरा दोस्त है क्या, जो तू यू नो हिम इनसाइड आउट, इज इट?
नहीं सभी वैल्यू आती है, अगर वो 0.080 ले रहा है वही मिस्टेक है।
Saurabh, in which density is the ship floating? Why were you getting stuck on it?
No, I was confused about the RD, sir. Now
It will be small w, then calculate small w. If small w will be equal to the volume of the water ballast. It is taken in a tank which measures 10 by 5. So 10 into 5, and it's taken up to a sounding of 1 meter. Into sounding, this becomes the volume of the ballast multiplied by density of the seawater becomes 21.25. Correct, guys? Yes or no?
Yes, sir.
Okay.
Yes, sir.
Okay. What will be the kg of the water ballast? Okay. Somebody had to board out. So please ask.
Yes, that was me. Sir, is it important to show
water ballast, guys?
0.5.
0.5. Sounding, half of the sounding. Any questions? Okay. Saurabh, are you okay with 0.5, beta? Saurabh, are you okay with 0.5 kg of the water ballast final displacement? फटाफट calculator हाथ में उठाओ.
just a minute.
To get the ship's BM in the final condition, I need to get the ship's kg in the final condition, and I need to get the ship's FSC in the final condition. Yes or no?
Yes, sir.
Correct?
Yes, sir.
Okay. It is a box-shaped vessel. What will be KB equal to in terms of parameters? Half of draft. So that means first I have to get the draft final. Now, how do I get draft final? It's a box-shaped vessel. What is it displacing? It's displacing 1281.25 tons. If I divide it by 1.025, what does it become, beta? Just write like this and finish it off. You will not explain, because if you go on explaining, the question will never come to an end. So this DF comes to 3.125. Anyway, in the class, anybody has any doubts, you can ask me. Is everybody okay with how we got the draft final? Final displacement was divided by the RD of the water in which ship was floating. That gave us the underwater volume. And if the final draft is DF, the underwater volume will be length into breadth into draft final into the density of seawater. It is equal to 1281.25. You keep DF on one side, take everything else, 1.025 will come here, length will come here, breadth will come here, and this is what we have done here straight away. And we got this draft. So what does this give us, guys? This gives us KB, and KB will be 3.125 divided by 2. So how much does the KB become? 1.563 meters. So this is KB. All okay up to KB? Any questions up to KB, guys?
No, sir.
Okay, very good. Now we come to, next we need is BM. Look at the tank and tell me, guys, what will be the shape of the free surface? Only the shape. Name the shape right now. What will be the shape of the free surface in the tank?
Rectangle.
Okay. And okay, I'm drawing the rectangle. Now tell me what will be the dimensions of this rectangle of the free surface. What
40 into 10.
40 into 10. Are you sure? Look, read the question.
10 into 5.
10 into 5? 10 into 5.
10 into 5. 10 into 5.
This is the shape of the free. Gentlemen, I have not drawn the water plane. I have drawn the free surface inside the cuboidal tank. So the dimensions of the free surface will be 10 into 5. Yes or no?
Yes.
No, sir.
No.
That means a new free surface has been created, correct?
Yes, sir.
Yes, sir.
Okay. So what is this IXX coming to? 125. So what will be the FSM caused? Let me first deal with FSC.
104.167.
104.167.
167.
Okay, fine. What will be the FSM caused, beta? But I don't know.
Multiply by density.
Yeah, multiply by density. It is coming 106.771 ton meter. Okay, now let's take a pause here. Calculated how much is the FSM caused because of part filling up of our empty tank. Is everybody okay with the FSM that is caused? Saurabh, especially you, beta. If
Yes,
you're not clear, let me know. What have we done? So I was wanting BM, but I started on with free surface. So now I'm calculating final FSC. Okay, so I'm calculating this part first. Now wait. So what have we done? The tank was initially empty. Then we partly filled up. The tank has a free surface. Free surface will be rectangle. Why? Because it's a cuboidal tank. Dimensions of the free surface will be 10 into 5. Geometric center of the free surface will be at G. We drew a 4.5 axis. IXX is a standard axis, so 10 5 cube by 12 and multiplied by density of the tank content. This gives you FSM caused. Is that clear, guys? Yes or no? What
Yes, sir.
FSM initially, beta, when the ship was there in the initial condition?
0.080.
Was that FSM?
98.4
FSC, sir, multiplied by displacement.
Yes. Okay, so initial FSM was your FSC was 0.080 and displacement was 1230, which comes to 98.4 ton meter. Correct, guys?
Yes, sir.
This will give us final FSM. Final FSM, you add the two, it becomes 205.171. Correct? Everybody is okay up to FSM final?
Yes, sir.
Okay. So now, what will be the final FSC?
0.160.
Final FSM divided by final W.
Yes, very good. So final FSC, I'm writing in blue here, will be final FSM, that is 205.171 divided by final displacement 1281.25, and this final FSC comes to 0.160. Is that clear?
Yes, sir.
Yes, sir.
This is 0.160 meter. I have already calculated this FSC now. Guys, up to FSC, everybody is okay?
Yes, sir.
Okay. So this we have applied what we learned today. Actually, I wanted to calculate BM first. I wanted to calculate in this order as they were listed, but never mind. I went this way, so it's okay. Guys, call yesterday's class for BM, which is the area of interest. Name the area of interest.
Water plane.
Water plane. It's a box-shaped vessel. What will be the shape of the water plane now? Now I'm going to draw the water plane as you tell me. What will be the shape of the water plane? Rectangle.
14 to 10.
What will be the dimensions of the rectangle?
14 to 10.
14 to 10.
14 to 10. Where will be the geometric center? Here. And that is called a center of flotation, right? Correct, beta?
Yes, sir.
Now when I draw the... Yeah, tell me.
Sorry to ask you.
Yes, sir.
Yes, sir. Yes, sir.
So this axis will be center line. Correct?
Correct, sir.
Yes, sir.
So the BM of the vessel, how much will be the BM? BMT. It will be I of the water plane about the center line. This particular diagram is this diagram. Yesterday we did for a box-shaped vessel, it is B square upon 12D. Yes or no?
Yes, sir.
So BM in the final condition will be equal to B, you can find by I upon this also, or you can cut short. It's your choice. Since you know the formula for rectangle, box-shaped vessel, you can use cut short also. Okay. So this will be, yesterday we arrived at this formula, B square upon 12D. Yes or no?
Yes, sir.
Yes, sir.
Or you can say I upon V, whatever way they'll cancel and come. Yes or no, guys?
सर इसमें हमेशा हम लोग BMT ही लेंगे, BML नहीं लेंगे.
बेटा अगर लॉन्गिट्यूडनल KM, लॉन्गिट्यूडनल GM, लॉन्गिट्यूडनल BM की बात होगी तो आपको L लगाना पड़ेगा उसके बाद में. और ट्रांसवर्स के लिए आप T लगाओ या मत लगाओ. If you don't put anything, by default it becomes transverse. Okay.
Okay, sir. Thank you.
Okay, guys. So, guys, can I cut short on this formula, or do you want me to take that I upon V thing? I think we should.
No,
such
this is okay, sir. This is okay.
Yes, such a lengthy question. We should cut short always on steps, right? We cannot keep writing story for every step. Then.
But you can write this step on the exam also, sir. No problem.
Yeah. You can say for a box-shaped vessel. For a box-shaped vessel, BMT is equal to B square upon 12D. You can just put that, no?
You can write it. Okay.
So in this case, breadth is 10 of the vessel, 10 into 10 upon 12, and final draft 3.125, guys. Be careful, don't use the old draft.
2.667.
Yeah, 2.667. So don't use the old draft. That is the mistake sometimes people make. I'm warning you upfront. So now we have got BM 2.667 meters here. The BM has also come now. Let me know if there is any doubt up to this point. Okay, what is left now? KG.
KG final, sir.
KG final, yes. So KG final, you know the initial displacement, you know the initial
Moment
KG.
लगा के वो निकालें.
Correct. So KG final, let me do it here for every, and you do like this the way I'm doing it. See, don't unnecessarily write too many steps. Talk to yourself like this. KG final will be initial vertical moment, which is initial displacement into initial KG. I'm talking to myself and I'm just writing. I have loaded the weight plus the vertical moment of the weight loaded, 51.25 multiplied by the kg of 0.5 meter for that ballast, divided by the final displacement 1281.25, and this kg, firstly everybody to evaluate this working, and then this comes to 3.380 meters.
3.380, sir.
Yeah.
Yes,
Guys,
sir, same, sir.
Yeah, everybody's okay with this kg that I have written. I have spoken to it. I have explained also. But if anybody has any doubts, let me know. So now we have everything here. 3.380 minus FSC. When we do this, we get GM
0.69.
0.690.
0.69.
Yeah, 690 meters is the answer. So in this one question, you have used the concept of the law of flotation. Okay, you use the normally when you drag a pontoon, so its 4.5 direction will be determined either by the length if it is given, or it will be determined by the side on which the lesser resistance is offered. So do you agree why I have called this as 4.5? Because tomorrow somebody may say, I want to treat it's 4.5 the other way. I want to treat 4.5 like this. You can do it. But A, it is against the normal shipboard experience. Secondly, this will complicate the question further. The question can still be solved, but the question will become more complicated for you. So we will take this as the 4.5 side. Am I clear, guys? Guys, am I clear?
Sir. Yes.
Okay. Now, this pontoon in the light condition is floating at a draft of 4 meters. This is in the light condition, it is floating at a draft of, so draft initial is equal to 4 meters. Okay. And then we take ballast up to 2 meters. That's up later on we'll do. Okay. Now, and then then 2 tons of weight is placed off the center line. So if I want to draw it in the diagram, then this is my center line, guy. This is my center line of the pontoon. If this is the 4.5 side, this is the center line. Then 2 meters on each, whichever side you want to take, it is kept on 2 tons of weight is kept here. And obviously, this will cost. This is what you need to find out. Is the question now clear before we start solving it? Or any doubts in the question, guys?
So just 1 minute, sir.
Yeah.
So they haven't mentioned which side, right? Placed or load of 2 meters.
No, port starboard it doesn't matter. So it is kept on one side. So it will list that side, which side it is kept, right?
So here we have kept on the starboard side. What I mean.
It doesn't make a difference. If you talk this as forward, this becomes starboard side. If you call this aft, this will become port side. This was only 4.5 direction I meant actually, right? So it could be kept either way, either side, right? For me, in the diagram on this side, these cylinders were coming, so showing on the other side was easier for me without messing up the diagram, right? So I put it on the other side, right? Correct, Peter?
Okay.
Okay. Guys, do you all agree with the diagram, with the text of the question? Because if there is a problem with, if there is a disconnect between the question and the diagram, let's first resolve that, because proper understanding of the question will help in solution. So I don't want to start solving the thing.
So can you mention in the diagram 2 meters from the center line also, so that
this distance is 2 meters, beta.
2 meters. Okay. Yeah.
This distance is 2 meters, right? Clear?
Yeah. Clear.
Okay. Can I proceed, guys?
Yes,
If the diagram is clear, okay, very good. Now, tell me who's going to tell me the firstly. Now I'm not going to do it as a question that you just do this. No. If this question comes to in the exam, how will you figure out? He says calculate list. You will spend 1 minute to figure out what all you need in the rough. What will you do? First, you will say, I need to calculate list. What is the formula for list? Formula for list is tan theta is equal to GG1 transverse upon GM, right? And what is GG1? It is small w into D upon capital W into GM. Does everybody agree with the formula for tan theta?
Yes, sir.
So that means I need to get all these. In this question, do you have small w? Tell me, read the question and tell me if you have.
Yes, sir.
Yes, sir.
Yes.
Yes, sir.
Okay. Do you have small d? Yes or no?
Yes, sir.
This D is not draft. This is not draft.
2 meters, sir.
2 meters of the center line. Okay. The displacement will be of course the final displacement, guys. We'll have to get, and we'll have to get the final G. And once we are able to get, this is not fluid, this is final in the final condition. And once we are able to get this GM, then we are good to solve the question, yes or no?
Yes, sir.
Yes.
Yes, sir.
Now you know this is how you figure out what all you need to calculate. So now displacement will be what? Initial, the light displacement of the ship. And in the light displacement, the vessel is floating, the draft is floating at 4 meters even keel condition. Guys, would you like to help me in figuring out how do I get initial displacement?
Yes, sir.
Yeah.
Volume of cylinder into my density.
Volume of one cylinder plus the volume of the second.
So volume of 2 cylinders into density.
Yeah, underwater, not the full volume. Underwater volume of the
underwater volume.
Yeah, correct. Multiplied by the density of the seawater. Correct, guys?
Correct, sir.
And what will be the volume of the cylinder underwater volume? It will be the area of the base multiplied by the draft height, right? Height of the underwater portion is equal to the draft meter, right, guys? So you see, it is such a lengthy question. You cannot keep writing area of the base into height, volume of the cylinder. You cannot write all this data. What will you do? And if anybody is not understanding, please let me know. I'll parallelly open another sheet here. Yeah, I'll use this one then, or let me open one more, a blank sheet, in which if I have to explain something to you in more detail, I can go there. Okay. I'll open a parallel sheet here. So I can keep flipping between the two sheets without having to mess up this one to explain everything. Okay. Now, what will I do? I'll write like this. I'm talking to myself. Pi r square. So what do I do? 22 by 7 into r is 2 square. This becomes area of the base of one cylinder multiplied by the height, that is 4 meters draft. This becomes volume of one cylinder multiplied by 2 becomes volume of both the cylinders. Multiplied by 1.025 becomes the light displacement. I have spoken to myself, I was talking to myself so that I don't miss out anything. And I end up getting the light displacement as 103.086 tons. Value is not the issue. Calculator will give you the values. If anybody wants more clarity on how we got initial displacement, please let me know. Anybody in the class, if has a problem with the initial displacement, let me know. All good about it, guys?
Yes, sir.
So this is the cylinder, one cylinder. Its water line is up to this place. This is the underwater volume of this cylinder. Draft is 4 meters. Volume of this cylinder will be the area of the base. This area, which will be pi r square into height is 4 meters. This becomes the volume into 2 for 2 cylinders multiplied by density of seawater is the displacement of this particular raft in the light condition. Yes or no, guys? Correct, beta?
Yes, sir. Right, sir.
Okay, very good. Saurabh, are you aligned, beta? Saurabh, are you aligned? अबे क्लास में है तो नहीं है, गायब हो गया. He's not there. Okay, never mind. Okay, then he says the cylinder, you take ballast in the cylinders up to a height of 2 meters each. That means I take ballast this one and I ballast this one. And what is the sounding? Sounding is 2 meters. Does everybody agree with what I marked in the diagram?
Yes.
Sir, repeat again, sir, please.
Question says, then you take each cylinder to a height of 2 meters. What does it mean?
Okay.
Correct. Okay. Now, can you calculate the weight small w? I can call it as W1. That is the weight. Can you calculate W1? Again, I'll not write lengthy story.
51.537.
It will be the volume of the water ballast up to 2 meters multiplied by density. In one cylinder, how much is the water ballast? Area of the base, 22 by 7. R square, 2 square. Into what is the sounding? 2 meters. This is the volume of water ballast in one particular cylinder. We have 2 such cylinders into 2 water ballast that you have taken, which comes to
51.543.
51.543 tons.
Just half.
Any questions on W1 calculation, guys? I can go on the other sheet and explain in more details if anybody has doubt.
It's okay, sir.
Okay. Anybody, guys, on W1? If no doubts, fantastic.
No, sir.
Very good. Guys, what is the light shift kg given to us in the question? KGI? 3.5 meters.
3.6.
3.6. Okay, 3.6 meters. Guys, kg of this water ballast, kg1.
3 meters.
kg1 of the water ballast.
1 meter.
1 meter.
1 meter, beta. Half the sounding, na beta? Yes or no?
Yes, sir.
Yes, sir. Yes.
Pakka?
Yes.
Okay.
Yes, sir.
Anji, sir.
Okay, very good. Then what is the weight on deck? deck weight?
2 tons.
2 tons. What is the kg of this weight?
15 meter.
15 meter given in the question, beta. 15 meter and 2 tons. Now with this information, we are good to get the final displacement. This implies final displacement will be what? Light displacement of 103.086 plus the ballast 51.543 plus the weight on deck 2 tons, and this gives me a final displacement of 156.629, correct?
Yes, sir.
Yes, sir, correct.
So now we have got the third thing also here. I can go back into blue or I can write red only. Final displacement is 156.629. Now only find is GM. Correct, beta? To get the list now, what is missing is GM only.
Yes, sir.
Any questions up to this? So see how we worked. We started with the formula for this list. We started figuring out what we need. We tried putting things together, and one by one, we have the W now, we have the D, we have the final displacement. Only thing missing is GM now. Correct, guys? You cannot keep giving additional information. You see these steps when I'm writing, you can actually finish these in 3, 4 lines, 5 lines. Otherwise, you'll get lost in the working. We are not, but it is an imperative that you keep talking to yourself, because if you don't talk to yourself, you'll be lost again. Okay. We have just in the previous question seen that GM is equal to KB plus BM, which gives KM minus KG minus FSC. Yes or no, guys?
Yes, sir.
Yes, sir.
So we have to get all this damn thing now. Now, in this case, first look at the diagram. Look at the diagram. Tell me, what will be the relationship between draft and KB? Is there going to be any relationship? Yes or no, and why?
It will be half of the final draft.
It will be half of the final draft. Anybody in the class who feels it should not be, then I'll explain. If everybody is aligned, then it's okay. Tell me, guys.
Sir, I just want to ask if the weight is placed either side, because it's not on center line. So will the draft on one side will be not more than the draft on the other side?
Beta, when we do stability calculations, we do it for even keel upright conditions. Even keel and upright conditions. Okay.
Okay.
This GM will be for upright even keel. Okay. That is why it's called GM initial, right? This is actually GM initial, if you remember, right? Initial GM is for upright condition, right?
Yes.
Any more questions, guys? So, okay, that means if I get the draft final, will everybody accept KB to be D by 2?
Yes, sir.
Okay. Now I know the final displacement. Now see, draft final will be equal to, again, I'm talking to myself. We cannot keep writing too much. 156.629. When I divide by 1.025, that gives underwater volume. And then I divide by the area of the base of this particular underwater volume. That is the area of the 2 cylinders. And area of 1 cylinder will be 22 by 7. Don't use 3.14, use 22 by 7. R square, 2 square. It is for 1 cylinder, and into 2 for 2 cylinders. Has everybody understood what I have written in this?
Yes, sir.
And this will give you the draft in the final condition. And this draft, unless I have made any mistake, subject to, of course, correction.
6.078.
Let me see. Well, it is 6.078 meters, right, guys?
Yes, sir.
Yes, sir.
Okay. Any questions up to draft? So if there is no question up to draft, then KB will be DF by 2, and this KB shall be then equal to 3.039, correct?
Yes, sir.
So we have got the KB 3.039. Guys, anything up to KB? Okay.
No, sir.
Okay. Now, I'll go on the other sheet and come back here. This is
So
our
now can we after this go to BM then, like in the order?
we are going to BM only. Last time by mistake I went to FSC. We'll go to BM only. Don't worry. This was the deck out there. Here it is on the cylinders. And here is the final water line. This is the final water line, okay, after the weights are put on board. Tell me what will be the shape of the water, yes, tell me.
Sir, I think my screen is hanged. I'm getting a video a little bit later, so I'm logging out and logging in back. My name is Shiv.
Okay, when you're back, let me know.
Okay, sir, I'm back now.
Okay, very good. Okay, guys, look at this diagram that I have drawn. This is the final, so this is draft final, okay, whatever we have got. What will be the shape of the water plane in this case? It is obviously at the water line. What will be the shape of the water plane? Can you visualize?
Two circles.
Two circles.
Circle.
People are telling me this, that one circle like this, one circle like this, correct? Is that what you're saying? One circle for this cylinder, one circle for this cylinder. Yes or no?
Yes, sir. Yes, sir. Yes, sir.
Yes. And this will be my fore and aft line. Yes or no? Center line of the ship, right?
Yes, sir.
Now you tell me, guys. The center of flotation is the geometric center of the water plane area. In water plane area, we have, this is only for explanation. I'll go to the working with the other sheet back. Area A1 and A2, they are identical. We know geometric center of area A1 is at G1. We know the geometric center of area A2 is at G2. Where do you think would be the geometric, where will be the center of flotation now in this case? Where will be the center of flotation?
Midway distance from G1 to G2.
Between G1 and G2.
This will be center of flotation would be here. Does everybody agree with me?
Agree, sir.
Agree, sir.
Okay. Then I'll go to that sheet. I'll draw the water plane here. Whatever I need to put in the answer sheet, I'll be doing there. On this one, I'll only be using for explanation. Tell me, beta, what is the doubt?
Can you please repeat? I just lost connection.
Okay, fine. Because it will become messy now. Otherwise, if I start doing here and there. Okay. Now what I'm making is the water plane area. Water plane area at final draft. For final water line, whatever you are saying. You have already told me they are going to be two circles. Center of flotation would be here. And this will be the center line, fore and aft axis passing through the center of flotation. Yes or no, guys?
Yes, sir.
Correct. Now, what will be the BM in this case? BM is equal to BMT, I'm talking obviously, is moment of inertia of the intact water plane about center line, because center line is fore and aft axis through the center of flotation. Yes or no?
Yes, sir.
Correct, beta? So it is ICL of water plane divided by volume of displacement, correct? Yes or no? I've used the formula for BM that we learned yesterday. This will be equal to 2 into ICL of one circle, correct? Yes or no?
Yes, sir.
Divided by volume of displacement, correct, guys? Yes or no?
Correct, sir.
Yes, sir.
And what is the formula for, let me use blue ink there, it will go into the diagram a little bit, so it doesn't then bother us if the ink color is changed. What is it a center line standard axis for a circle? Yes or no?
Yes, sir. Yes,
Yes,
sir.
sir.
Yes, sir.
Yeah, so this 2 is 2. then it is pi R4
Pi
upon
R4
4 or pi D4 upon 64, whatever you want to take.
By
Yeah.
R4 by 4.
Okay, 22 by 7. R raised to power 4 is 2 raised to power 4 divided by 4. This is I about center line of one circle multiplied by 2 divided by volume of displacement, guys. We know the final displacement. What is it? 156.629. And if I divide by 1.025, I'll get the volume of displacement, yes or no?
Correct, sir.
Yesterday we were doing it, no? When displacement was given. Correct, beta? Yes or no, guys?
Yes, sir.
So BM in the final condition, please calculate, is it coming 0.165 meters?
Yes, sir. 0.165.
Yes.
Fantastic. So now you have plus 0.165. Please review BM. Let me know if there are any questions on BM.
सर एक बार ICL एक बार कंफर्म कर देंगे प्लीज
क्या कंफर्म करना है बेटा?
That formula, sir, I forget to about this thing.
So flip your pages, no? You don't have the notes?
Yes, sir.
Then? You would have the formula with you.
Got it, sir. Got it.
Got it? Okay. It is pi D4 upon 64 or pi R4 upon 4, right?
Yes, sir. Yes, sir.
About the moment of inertia of a circle about any of its diameters, right?
Yes, sir.
Okay, guys, BM all understood up to BM?
Understood.
Yes, sir.
Yes.
Okay. Now, I'm sure kg does not need any deliberation. You guys should be good enough to get the kg. Kg in the final condition will be equal to initial vertical moment. That means initial displacement into initial kg. Initial displacement is 103.086. Initial kg is given 3.6. So initial vertical moment 0.86 into 3.6. Plus, what are the weights added? Weight added is ballast. What is the weight of the ballast? It is 51.543. What is it? It's kg. It's written as 1 meter here already. Plus the vertical moment of the weight on deck, 2 tons
2 into
15. Divide by the final displacement of 156.629. And this gives us in one step, because we cannot make kg, we cannot make kg itself a new question. 2.890 meters.
0.89.
Yeah. So minus 2.890. I put kg here. Please review kg. If anybody has any doubts, let me know. Done, sir? Done up to this place? Shall we proceed further? Okay.
Yes, sir.
Now, I have already told you, beta, FSC final will be equal to FSM final divided by final displacement. Does everybody agree? I'm writing here on top to save space. FSC final will be equal to FSM final upon displacement final. Do you all agree with this?
Correct.
Yes, sir.
FSM final will be equal to initial FSM, if any, plus minus the change. If a free surface is created, you'll add the FSM. If free surface is removed, you'll subtract the FSM. Am I right, guys?
Right, sir.
This will be equal to FSM initial plus minus FSM cost upon displacement final. I'm sure all of you are aligned on this part, right? Does the question give you anything about initial FSM? Can you read the question and tell me if any FSM, FSC is given?
No, sir.
Not given.
No, sir, because light ship is there already.
Okay. Light ship, but there, okay, fine. But it's also nothing is the question, right?
We take it to 0.
Okay. Now look at the diagram. In this diagram, now you have taken ballast up to 2 meters. Do you think the cylinders are completely filled or there is a free surface created now?
Free surface created, so we'll add the FSM.
Yeah.
Free surface created.
So we will have to calculate the FSM cost because there is a creation of FSM. Yes or no, guys?
Yes, sir.
I go to the same diagram again. We have water ballast up to 2 meters. So here is the water ballast. Here is the water ballast. Forget about this one. Don't look at this one anymore. Now I'm saying, what is the shape of a free surface? Now, this was water plane, guys. Don't confuse the two. Shape of free surface. What will be the shape of the free surface?
Again, circular.
Again, the same. The two are coming same, never mind. But once we were talking of water plane, now we are talking of free surface. Is that correct, beta?
So what is the answer? Cylinder or surface?
Cylindrical. Surface can be cylindrical. Cylindrical is a 3D body, beta. Surface is a 2D body.
So circle is the answer. Okay.
Yeah, your glass, the free surface in your glass in front of you is the cylinder, right?
Yes.
So this free surface is a circle. This free surface is a circle. So the two free surfaces are. Now don't look at this, otherwise you'll unnecessarily get confused between water plane and free surface. Now only focus on the free surface, nothing else. Do you agree these are the two free surfaces? Correct? Yes or no?
Yes, sir.
Yes, sir.
Where will be the geometric center? Now I'll not call it as F. I'll call it as G. Understood? And
Yes, sir.
for free surface I need to draw a 4.5 axis through it. And what have we been calling this axis? Not center line, we'll call it as XX. So that there is a clear distinction between water plane and the free surface. Clear, bit?
Okay, sir.
It is the same thing, but there I have written F, here I am writing G. There I have written center line, here I am writing XX. Correct, beta?
Yes, sir. Yes, sir.
So that there is no confusion between the two surfaces, right?
Yes.
In this case, both happen to be same, but there is complete. Am I clear? Can I go to the working sheet then?
Sir.
Yeah, tell me.
Sir, can you explain why this is
725, guys?
Yes, sir.
Okay. Now, please review this question. Through this, you can see on this sheet, everything is clearly visible to you. And if you spread out too much of it, this question will become unmanageable. You will not be able to control it. So you need to be smart in executing your steps. And the best way is...
Only to find GM, there are so many steps. The rest all came in one step.
Yeah, but whatever it is, but all those steps, contributory steps also, you need to be smart enough that they are closed out in one step each, BM in one, but may support them with the diagram as you are doing them, because otherwise you'll get lost, right? Okay, guys? And it is for sure MMD question. So that should also send a message that questions like this, comprehensive, which put everything to test. One list question, testing you the concept of list, testing you on the concept of law of flotation, testing you on concept of free surface, testing you on concept of kg, testing you on concept of kb and bm. Everything is being tested in this one question. Bolo beta.
The list is, I think.
We mean that the water plane area over the range, if you say the full ship is wall-sided, that means from keel to waterline. If you say the ship is wall-sided between 3 meters and 5 meters, then between 3 and 5 meters. So when the ship is wall-sided over the range in which it is wall-sided, the water plane area of the ship is identical in that range. Then the ship is said to be wall-sided. Is that clear, beta? Understood? The water plane of the ship shall be identical when the ship in that range, when the ship is said to be wall-sided. When a tank is said to be wall-sided, what is the counterpart of water plane area in the tank? It is the surface of the liquid. Yes or no? Correct?
Yes, sir.
So when a tank is wall-sided, see, I can only refer to wall-sided tank here and walk away, but tomorrow you'll again have this word with ship, then you'll again get stuck. Tank is wall-sided means that the surface of the liquid at any sounding in the tank, from bottom of the tank to the tank top of the tank. So if the tank is, this is the bottom of the tank and this is the top of the tank. You take the free surface at any sounding, all the free surfaces will be identical. All the free surfaces will be identical, like the glass in front of you. If you see the free surface at different soundings, at each sounding, the free surface will be circular in shape. So the glass is said to be wall-sided. Is that clear, beta?
So just one thing, if I would like to say, if you can correct me. Basically, to be wall-sided, the shape has to be symmetrical. Anywhere even slight deformation is there, it doesn't become.
Symmetry is about an axis, beta. Symmetry
I
is
mean,
about
it has to be a proper shape, like not deep.
an undivided DB tank, length 18 meters, has the following half ordinates of the water line. Again, guys, my orientation would be, you can draw whichever way you want. I'll take the top of the page as the forward, the bottom part of the page as aft. You can draw whichever way you want. These breadths are half breadths are given. So obviously the breadth on the other side would be exactly a replica of it. Fuel oil is filled up. So basically, if you see this tank is what, like it's how many ordinates? 1, 2, 3, 4, 5, 6, 7 ordinates. So basically it is less in the forward part, then increasing from forward they're given and increasing.
So are you drawing anything by any case? Because you cannot see.
You can also draw in the meantime, beta.
No, sir. If you're okay, now do it.
This is the tank. This is not the ship I'm drawing. This is the tank part I'm drawing, and half breadths are given. 7 of them. Okay. This is the center line of the tank. Need not be the center line of the ship, but this is the center line of the tank. So this is the free surface or the surface of the tank at some level. And these are 2 meters, half of them 2.5, 3.9, 5.2, 6.7, 8 meters, and lastly it is 10.1. Guys, is the diagram clear to everybody?
Yes, sir.
Okay.
Yes, sir.
Okay, first let's figure out what we need to calculate. Question says get the kg final fluid. What is it equal to? What is kg fluid equal to?
kg plus FSC.
Initial kg plus correction. FSC.
kg plus
kg final plus FSC, right, guys?
Yes, sir.
FSC final, correct? And what will be FSC final equal to? FSC final will be equal to FSM final upon displacement final, correct, guys? Am I right?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So this is what we need to now calculate. We first need to calculate the kg solid. We need to see if there are slack tanks. and get FSC and add it, and that will be the answer to the question. Understood? Is the scope of the question clear first before we start solving? Okay, beta. Okay. What is the initial displacement of the ship, guys? Look at the question and tell me what is the initial displacement.
20,000.
20,000 tons. What is the initial kg of the ship? 10 meters. Is there anything given about any FSM initial? Not
No,
given.
sir.
So I'll take 0. Correct, guys? Correct?
Yes, sir. Yes, sir.
Yes, sir.
Yes, sir.
So firstly, I'll need to get final displacement, for which I need to add the amount of oil taken. Now it is wall-sided and you have taken to a sounding of 0.8 meters. Being wall-sided, I'm sure you'll agree that the volume will be equal to area of this base multiplied by the sounding of 0.8 meters. Yes or no? Like we did in the case of cylinder. In case of cylinder, we took the area of the base pi r square into the 2 meters of sounding. Yes or no?
Yes.
So here the area of the base will be the area, this entire area which is drawn here, right, guys? This full area, correct?
Yes. Yes, sir.
Yes, sir.
Into 0.8 meters will give us the volume of the oil.
Yes, sir.
Yes or no?
Yes.
Multiplied by RD
Yes, sir.
will give weight of the oil. So right. So weight of the oil we'll have to calculate. Second, what will be the kg of this oil? It's a wall-sided tank.
0.4.
0.4.
Because all are similar. Yeah. Very good, Shabash. So that will help us in getting the final kg of the ship and final displacement of the ship. Now, does the question say that the tank is slack? Has he given us the height of the tank? Yes or no?
Yes, sir.
No, sir.
He has not given us any height of the tank,
No,
right?
sir.
Okay. So it may be possible the tank gets full when sounded to 8 meters, 0.8 meters. But this question does not say anything. Now there is, when the question is silent and there is something missing, what will be safer? To assume the tank to be slack or tank to be full? What will be safer from stability perspective?
Slack.
Slack.
So the question does not say the tank is slack. Unlike the previous question where it said cylinder was only 2 meters filled up and we know it was floating at 4 meters earlier, so cylinder was much higher. In the previous question, that box-shaped vessel, the height of the DB was 2 meters and we ballasted to 1 meter. So there it was absolutely clear that the tank's free surface is created. In this question, it is not evident from the question whether it is not clearly stated whether free surface is created or not. When it is so, the safer side would be to presume that free surface is created. Am I clear about it, guys?
Yes, sir.
Okay.
Yes, sir.
So since these ordinates are half ordinates, do you agree that the geometric center of this free surface, this will be the shape of the free surface, then do you agree that the geometric center of the free surface will lie on this line XX? Yes or no?
Yes, sir.
Yes,
Yes, sir.
Correct. So I will have to be about XX, yes or no? For free surface moment. Correct, bete?
Yes, sir.
So then does it become a vertical ordinate case or horizontal ordinate case? If XX is
vertical.
And vertical, we'll have to take half ordinates, so we'll continue solving with half ordinates, will not make them full. We'll make the table fair. Now, why with half ordinates? Because you also have to get moment of inertia of this surface of this area about XX, and that can happen only when you take half ordinates. Am I clear, beta? Correct? Guys, clear why we have taken this decision? Okay.
Sir,
So
not
now,
get.
what is it that you did not get? Tell me.
So why here taking, sir, half, sir?
Half is given in the question. What is it that you have not got? Tell me that.
So here area we will calculate, sir, half ordinate only.
You will make different tables for area and different table for moment of inertia, or you'll make only one table?
We will make a different table.
You want to make different tables. Why? You have a lot of time in the exam, is it?
No, sir.
Yes. So if you have to get I of the free surface, for that, look at this diagram. You have to calculate I about which axis?
Axis.
XX. Yes or no?
Yes, sir.
So if you have to calculate about XX and you take full ordinates, will you be able to calculate about XX by taking full ordinates? Yes or no? Tell me that.
We'll take, sir, half ordinate.
No. Arey, don't say this now. I'm asking you, if you take full ordinates, instead of 2, you take 4, instead of 2.5, you take 5. Can you calculate taking 4 and 5 and 7.8? Can you calculate I about XX? Yes or no?
Yes, sir.
You can calculate.
Yes. We can calculate. We can.
How? Tell me how you can calculate by taking full.
No, we will do, sir, half actually.
No, please. No, I'm talking to the person who said we'll calculate. Please tell me how will you calculate, beta?
No, sir, cannot calculate, sir.
Why? Now you tell me why you cannot calculate. Okay, give me the reason for that.
Because, sir, we are taking, sir, center of the ordinate.
So, no, the answer I expected was that for I it will be a case of vertical ordinates, and for vertical ordinates it is important that all ordinates terminate at one axis, and the formulae are based on that. Correct?
Correct.
Yes, sir. That is the logic you should have given. Am I right, guys? That is why we are taking half ordinates. Yes or no?
Yes, sir.
Yes, ordinates are terminating at XX.
Yes, so we'll work around. So we might as well work around with half, right? So now please make with half ordinates a table. You will have the half ordinate here. Then 7 of them you can work by rule 1 or rule 2. I have worked with rule 2. So I will give you the answer by rule 2. Okay, I think I've done by rule 2. No, I've done by rule 1 or 2, or I've got both the answers. I don't know which one have I used. Take a second, let me just see which rule have I used. By 3. So I think I've used rule 1 only. It seems I've used rule 1. Let's see. Okay, now mind. Let's use rule 1. Okay. 7 ordinates, you are at liberty to use rule 1 or 2. So let's use rule 1. If it doesn't match, never mind. I'll correct later. So half ordinate, what will be the next? Simpson's multiplier. What will this give us, guys? What will this give us? Next column.
Product of area.
Product of full area or half area?
Half area.
Half area. So don't miss out on that. Then what will be the next column?
Ordinate.
Half ordinate. Very good. This will give us product of moment
Of half area, half.
Yeah,
Half-
about
about
XX of half area. Then you'll again repeat half ordinate, and this will give you product of inertia about XX of the half area. Will you directly get SOPs or you'll get summation first?
Summation.
Directly,
SOP, sir. Directly.
How can you get directly, beta? Who will account for 1 by 2 and 3 by 1 by 3? What's wrong with you, yaar? Vertical ordinate, now you're going back to the start line again. Correct, guys?
So you have solved with second rule, right? So you are solving the second rule.
I don't know, yaar. I think I've solved by rule 1 because I can see coefficient 1 by 3 used. Let's solve by rule 1 if you want to match with me. If others are solving by rule 2, I have no issues, but So now, guys, we will get the full area. So half area, and then we'll multiply by 2. So half area will be equal to, we have used rule 1. So 1 by 3 Common interval 1, 2, 3, 4, 5, 6. So H is equal to 18 by 6 equal to 3 meters, right guys? Correct?
Yes, sir. Yes, sir.
So 1 by 3 the coefficient, 3 the common interval, and 96.1. So half area is 96.1 square meters. This implies full area is equal to 96.1 into 2. So 192 square meters, right guys? Correct?
Yes, sir.
Okay. So now, what will be the weight of the oil taken? Weight of the oil will be equal to the volume of the oil, which will be, okay, everybody is there up to area, or somebody is still lagging behind? Let me first confirm that here. Otherwise, people will miss out.
Sir, doing it, sir. Wait for a minute.
Okay, do it, and then come. Small W1. How come I am written one? Achha, my area was wrong. No, that's why it was okay. Okay. So guys, this answer of mine may not match. So that will be subject to correction, of course. I'll keep correcting my notebook also. One 138.38. Okay. This will give us the final displacement, guys. Final displacement would be equal to initial displacement of 20,000 tons plus 138.384. This makes it 20,138.384 tons. Correct, guys? Yes or no?
Yes, sir.
Yes, sir.
So we have the final displacement. Okay. We know the kg. Kg of this weight will be equal to kg of this small w. Kg of the small w will be half the sounding. So 0.8 by 2, 0.4 meters. Yeah, this will lead us to the kg of the vessel in the final condition. Initial vertical moment 20,000 tons into initial kg, yeah, plus weight of the oil 38.384 into kg 0.4 divided by the total displacement 384 and how much?
9.934.
9.934. Okay, 9.934 is the kg final. Is everybody good up to kg? Let me know.
So this is what we got is kg final, right?
No, yeah, this is kg final solid, not the answer. Answer wants fluid kg.
kg fluid.
Yeah, so kg final is 9.934. This is solid kg. This is not the answer. Correct, guys?
Yes, sir.
Okay, now we have to get the FSM cost because initial FSM is not there. So FSM cost, initial FSC is not. So FSM final, I can say, will be equal to FSM cost. Why? Because there is no initial FSM. Right, guys?
Yes, sir.
And in this case, that will be twice of what you have got here. So rule 1 we have used, coefficient 1 by 3, common interval 3. SOP inertia is 1477.132. This is for half the area, beta. And you multiply by 2, it will become for the full area moment of inertia. And this comes to 4, 6, 2, 14, 15, 9, 2, 2954.62264 meter 4, right, guys? FSM final. Correct?
Yes, sir. 2954.264.
Correct. We have got it for half and then we doubled it up. This is for doubling up, right?
Yes, sir.
Okay. So this will give us FSC final. FSC final would be equal to 2954.264 divided by the final displacement of 20,138.384. How many meters?
सर उसको डेंसिटी से मल्टीप्लाई नहीं किया सर.
Okay, my mistake.
Sir,
My mistake.
इसको
Okay.
0.94 आएगा.
Okay, into 0.9. Okay, let me do it here. Sorry, you please do it. Complete the step up. FSM will be 0.9 also. So what will be this value? Correct this value then.
2658.837.
2685.8.
2605.
2605.
2605.
2605.838 ton meter now. Okay.
Yes, sir.
So this will be 0.9. I
No, sir,
multiply.
I'm getting 2658.
2658.
2658.
2658 decimal
838.
838 ton meter. Okay, this seems to be correct, beta. 26 because it will not reduce by that much. You are only multiplying by 0.9. Okay, so the final FSC final will be equal to final FSM 2658.838 divided by final displacement 384. How many meters is the final FSC, beta?
0.132.
132. Okay. What was the kg final? 9.334. So kg fluid in the final condition will be sum total of this 664.9. So 9.466 is the answer, guys. You can ignore my answer. That is obviously wrong then. That's obviously wrong. My answer is wrong for sure.
So just one question I wanted to ask.
Yeah, tell me.
This is related to very initial steps. So in the
5.64 is the top one. Okay.
The middle one is 5.08.
These are full ordinates, right? Okay.
Yes, sir, full ordinates. And
Yeah.
bottom one is 4.52.
Okay. What does he want you to calculate?
Water level is still 3 meters. That
So
is
water level is here, right?
Yes, sir.
So what is the problem? What does he want you to calculate?
Thrust on thrust.
So what is the issue, beta? Calculate this area by rule 3 and calculate the geometric center of it. So your for 5.8 minus 1, it will be 5.8 and minus 1, and that will give you this area. Correct? Can you calculate this area by rule 3? Tell me. If you have a problem, then I repeat rule 3. Simpson's rule 3.
No, I tried with rule 3, sir. 5.8 minus 1 mein.
Yeah.
And CG I'm getting around 14, sir.
No, it can. No, you have not used 310 minus 1 then. That's one. Okay. Let me just clear this one, and can I clear this board and do this question with it, guys? I'm just clearing it. Have you taken down?
Yes, sir.
Okay. Now you'll have to repeat the values once again. I don't mind taking them here. So the upper one is 5.64. Okay, 5.08 if I'm not mistaken, is it?
Yes, sir. 5.08
and
4.52.
4.52 and H is 3.
H is 3.
And here is the liquid level, right? That's the question, right? This is the immersed area, no, beta?
Yes, sir.
Okay. So the immersed area A will be equal to 5.8 minus 1. Coefficient for rule 3 is 1 by 12 into 4.52 into 5 plus 5.08 into 8 minus 5.64 into 1. Can you calculate this area and give me how many square meters is the immersed area?
24.28.
24.28. Are you okay up to this place, this point, beta?
Yes, sir.
Okay. Then to find the moment, we'll have to use 310 minus 1. When we use 310 minus 1, we will get the moment about this axis. Correct, guys? Those who have recently done with me would understand that this will give you moment about x-axis, right? About this ordinate, right? Correct? So moment about x-axis of this area will be equal to coefficient h by 24, h is 3. 1 second. Have we multiplied one by common interval? Did we multiply by 3? No. Just see.
No, 14.4 आएगा sir. If we multiply with 3, 3 is not multiplied.
So how much is 14.4? 400. Okay. It is coefficient into common interval into SOP, right? Right,
Yes.
guys?
Yes, sir.
So moment about
Yes,
XX will be 3 by 24 into common interval 3. Some of you may be doing h square by 24. It's up to you. Into 4.52 into 3 plus 5.08 into 10 minus 5.64 into 1. How much does this moment come, beta? This will be cubic meter, will be the units of it. How much does it come?
Yes, sir. So 179.94.
94, okay, 0 meter cube, okay. Now when I divide this moment about xx by the area, I will get the distance of the GC from xx. This cannot be 174. Is it 174? Just see.
22.02.
How much?
22.02, sir.
It cannot be that much here. It cannot be 179. Check again. Don't worry. Take your time. No worry here. Don't worry. Check again, please. Because your distance dxx cannot be more than 3 in any case here. It has to be 22.02. Okay. So dxx will be equal to 22.02 divided by 14.400. How much does this come, beta? dxx?
1529.
1.5.
Okay, very good. Now for thrust, we need distance from liquid level. We don't need from xx. So DLL will be equal to 3 meters of sounding minus dxx 1.529. Am I right?
Yes, sir.
How much does this come? 19794 and 1.471?
Yes, sir. 1.4. Yes, sir.
Yeah. So now the thrust will be equal to, is it seawater or something else?
Seawater into 1.025.
Into the seawater 1.025 into the area of 14.400. If now also it is not matching, then the answer is wrong. Okay.
The same, sir. 21.7.
21.70971.
Okay. Now if it is matching, it's so. If it is matching, good. If it is not matching, then answer is wrong. Okay, that's what it is.
Sir, I just had one more doubt. Like if there is one more ordinate added up, this is 3 ordinates. We can use this rule 3.
Well, then you use 14125.
Okay.
Where is the ordinate? You see, you're now out to create confusion. Add one more ordinate. Add where? In the immersed part or non-immersed part? You're just now creating confusion for yourself and everybody else now.
No. My doubt is like if they give one more ordinate and give some other draft, then just for an example, sir, I'm asking.
For example, what? Give me the example, no?
Like suppose one more ordinate is on top of 5.64. Suppose some 7.
Okay,
and
then
draft
what?
they have insert some 8 meters.
How can they give you 8 meters? Well, yesterday also somebody asked me this question, and I said, then is the Simpson's rules applicable when they are not equispaced? If the draft is 8 meters, then you need this width. Then are they equispaced? Then ordinates are not equispaced, no?
Yes, sir.
Then how can Simpson's rules be applied? Simpson's rules itself will fall flat, no?
Yes, sir.
Okay.
Okay.
That is a prerequisite condition for Simpson's rules, that the ordinates of the area or volume of interest should be at equispaced intervals. Yes or no, guys?
So that means if they give some sort of this question, then the draft will be exactly equispaced places.
It has to be, yeah. It has to be.
Okay, sir.
In this question also, he wanted you to use rule 3, and there is no formula for moment of inertia for rule 3. That's why he's not taken you to COP. He's shied away from that, right?
Yes, sir.
Right. So that's what it is.
But the rule 1 can be applied here, correct?
Sir, this can be done in one more way, sir.
Which is the other way, yeah?
Like bottom portion, we'll consider it as a trapezium. The above portion is 5.08 and bottom is 4.52.
How can you?
Height is
But how can you consider it trapezium? If you consider it trapezium, then the error will depend upon, because you are treating it as a straight line. If you want to change this thing into a trapezium, then the error will depend upon how much is the aberration. You are saying I'll treat it like this. Let me change to blue. Now you are saying I want to treat it as a trapezium, then the area would be out by this much, whatever it is. You are saying this is the shape you are taking. What about the areas which are left out? What about these areas which are left? And they can be different depending on the curvature. What about these areas?
Yes, sir.
Who will address them? Correct?
Because I tried with this trapezium method, I was trying out with the Simpson's method, I did not get the answer. The trapezium method, I got the answer, 21.7.
That depends, no? How much is the curve closer to the straight line? If the curvature by luck is closer to the straight line, the error may not be much. But if there is a huge aberration, then there will be error, no?
Yes, sir.
Even by trapezium, you would not have got exact answer. You may have got a better answer, but not exact answer, right?
No, 21.712.
So you will not get the same answer. That's what I'm telling you. How much is the error? That depends. How much is the curve deviated from a straight line, right?
Yes, sir.
Okay.
Okay, sir. Thank you, sir.
Okay, guys. I'll sign out then. Done for the day. One topic done.